surprise here that many named threat group actors are using this persistence mechanism, and so it's something that pretty much everybody should be concerned about. Everything from the low-level groups all the way through to your APTs, and this is often used as a backup or additional secondary or tertiary persistence mechanism. So they're going to try to persist in multiple different ways, and if they can just add in another scheduled task while they're doing those other things, they might do so. So definitely something to be worried about. Okay, so let's talk about detections. Let's say we're doing this right. We want to be able to detect new malicious scheduled tasks as they're created. There's lots of resources out there that will talk about, hey, here's what you can do to go detect the scheduled tasks. Starting with command execution. So you can say, yeah, we'll monitor for command execution for when the scheduled tasks are created. But as you dig into that, it's more than just CMD execution of the big things. You can also create scheduled tasks through WMI. You can also use PowerShell, and there's multiple different ways which require multiple different sets of logs to go and analyze. And so as a security analyst, if you're trying to dig through all that stuff, you typically have to rely on something like an EDR to give you the right information if you're not already overwhelmed with the just massive amount of stuff that exists. Some other resources will say, well, you can look for files being modified. Scheduled tasks actually exist inside system root, inside system32, and in a directory called tasks. Every scheduled task is an individual file inside of that. And so theoretically, you could just look for modifications or new files created inside this directory. If you've ever had to do like enterprise-wide file modification analysis, that's not sustainable. And that's miserable by itself. So probably not the most efficient way to do that, but theoretically, I guess it could be done. Similar to command execution, you've got things like process creation. Again, just massive amounts of metrics and analytics to kind of dig through. Registry key creation always pops up, and I love when they say, yeah, just look for new registry keys being created in all the places that a registry key could exist to do the thing. Yeah, that's not sustainable either. So the last thing that I'll bring up, and this is probably the correct way to do detection for new scheduled tasks. If you have sysmon enabled in your environment, it has the ability to detect scheduled tasks and give you additional metrics on that. And then Windows logs, events 4698 through 4702 all have to do with scheduled tasks. Point of note, none of these logs are enabled by default. So you actually have to go into your enterprise, you have to enable that logging, and then you have to go look for the thing if you're concerned about scheduled tasks as a persistence mechanism. Okay, that's detection. So that then begs the question, okay, now we're going to go back, we're going to enable that detection, we've got those logs, and we can look for malicious scheduled tasks. But what about all the scheduled tasks that already exist inside of my environment? What about if any of those are malicious? And so that's what I'd like to focus on, because that's what I was interested in. So we're going to start with some PowerShell analysis, and this is probably where some of the misery starts for all of you, but I'll try and make it not so terrible. I have a demo. The last few presentations I've given at a couple different conferences, my demo has gone absolutely terribly. I don't know if I gave enough sacrifices to the demo gods or whatnot, but it hasn't gone well. And so I've actually recorded the demo this time, so it should go smooth. Of course, I did that, and we're going to have all kinds of AV issues. So we'll see. As it's up, we'll see if we can get through this. Okay, so I've got VS Code up. I'm inside of a build. This is a Windows 10 brand new build. I've emulated an attack on it, so it's got some other things. There is one malicious scheduled task within this environment, okay? And so we're going to go find that, but the get scheduled task commandlet, we can do a .count, and we can see that this endpoint has 148 scheduled tasks by default. Well, plus the one, so 147 plus one malicious one, and that's super normal. Windows 11 has about 160, and then my daily driver that I've used for a couple years, it's at almost 300 scheduled tasks, which is insane to me. And so when you expound that problem to an enterprise and you talk about thousands of endpoints and trying to sift through those scheduled tasks, that's a lot of work. Okay, so what can we do then? As a typical threat hunt process, the next thing that I'm generally interested in is what kinds of information can I pull back? What are the fields, what are the data points that I can see? Because at its core, threat hunting is really nothing more than saying, okay, I know what normal looks like, and I really just need to find the things that are abnormal. And within those abnormal things, I can hopefully find the malicious stuff, and hey, that's like threat hunting at its core. So getMember allows us to see all the fields that get returned. We see things like author and date and description, metadata information about the scheduled task as it's created. In PowerShell, you'll also see this thing here for instance array. So each one of these properties then has properties that have an array of properties inside of it. And so you've got to dig a little bit deeper if you want stuff like the action or what is actually being executed within this scheduled task when it starts up. So we can do get scheduled task.actions, get member for that, because that's probably what we're interested in, right? Is the execution or processes, applications that are running. And then we can see things like, this is the problem with recording the demo, I've got to wait for the recording to go through. We can see things like the execution and the arguments. So this is that application, any additional arguments that's executed alongside of it, so on and so forth. Okay, so we're digging through those, we're getting all the metrics for it so that we can now make a more informed query on the kinds of information that I want to return. And so if we do a get scheduled task.action.execute, this is going to return a long list of all the execution parameters, aka what application is being executed. We see defrag, exe, tz, sync, so on and so forth, just massive list. Let's clean this up a bit. We can group the objects by that property and then sort them so we get a nice counted list of how many times each one of those applications was returned. Okay, cool. Here's where the misery really starts to begin. What you may notice here at the bottom, so this first column here is a count of how many times it was seen. At the bottom, we've got 73 results where there's nothing in the execute field. So Microsoft does this really cool thing where they say, we've got some scheduled tasks that we want to run on the back end, but you as a user, oh, by the way, you as a local administrator or even domain administrator, you don't really need to know the details of what we're doing. So we're just going to hide that from you. Cool. Thanks. That's super helpful. I'm sure an adversary would never take advantage of something like that to just hide all the execution details in a scheduled task. Super helpful. Okay, that piece aside, by the way, and that's legitimately how they do it, whether those are active running scheduled tasks or not, and we'll look at a couple other properties that make this more difficult. But there are some that we can see the details for. So most of these are returning back with things like windir or in system root. And so as part of trying to find an easy win or something that might stand out a bit easier, I'll filter out both of those results. So filter out anything that says windir or system root in it, and we get a slightly smaller list of things that are executed. Okay, now looking through this list, a lot of stuff executing in program files, applications as they should. One thing starts to stand out is that sc.exe by itself without an absolute path. So sc is used to start up services. If I'm thinking about what an adversary may do, they may be using sc to then start up some service as part of a persistence piece. So if we wanted to dig into that, we could then say, okay, get scheduled task. We're going to filter for execute equal to sc.exe and return those details. When we do so, at the core, we're going to get that high-level metadata stuff. So we see the task name here is set to upnp host config, upnp probably universal plug and play. We can see the task path, or the folder structure that it sits in, is inside Windows, or Microsoft Windows UPnP. And then if we want that execution details, we have to run the same query, but just pull back execute, and it returns what was actually ran, or what is supposed to run on the scheduled task. So there's the sc.exe, and now we can see the arguments. This is config UPnP host start equals auto. This is legitimately how Universal Plug and Play, or UPnP, is started, built in as a scheduled task. They just didn't give it the absolute path to sc.exe, which is a little weird, but not outside the realm of something that Microsoft would do. And this kind of also gives a little insight into the threat hunting process. I talked a bit about how simple it really is at its core, but 99% of the things that you get back is, oh, this looks weird, but it's actually a legitimate thing. Welcome to threat hunting. Okay, so false positive, great. What else can we look for? Well, we see the arguments there. Maybe there's interesting things in the argument details coming back. So we can do the same thing, pull back actions.arguments, return a massive list of all the interesting stuff there. Now, thinking a little bit more about, okay, maybe the adversaries like to use PowerShell. And so now I want arguments where PowerShell is listed out in any of those execution details. So I'm going to filter on that same argument field, but now return back anything that has PowerShell in it. And we have two results. So let's look at this. The execute, or that parent process that spawned, is cmd.exe, that then launches PowerShell as a child process, or as that sub-argument underneath it. PowerShell is then executing with, let's count them, no profile, non-interactive, no logo, setting the execution policy to unrestricted, and then calling a PowerShell script file. Okay, going through my security mindset here, that looks super malicious, right? The second result does the same thing. This first one calling an initialize instance.ps1, second one calling an ec2 launch.psd1 file. So super cool. This is exactly how Amazon spins up every EC2 instance in the cloud. Thank you, that's super helpful. So we can see how the miserable journey that I went to try to find these anomalous tasks, it makes it very hard to find the things that are anomalous when the legitimate companies are making tasks that look super anomalous. Cool. Okay, so arguments. Oh, and this should also demonstrate why it's really, really important to go through your environments and learn what things are in existence, or what things are being executed, so that it's easier to find those truly malicious anomalies. So this next part, I'm going to walk through a couple different fields that might help narrow us down into some more anomalous things. There is a task path. This is the logical folder structure where each of these tasks exist. Most of the tasks exist inside the Microsoft Windows directory. Okay, most of them are Microsoft scheduled tasks as created by default, especially on a brand new build like this. So we can then say, okay, show me all the scheduled tasks that don't exist inside the Microsoft folder. So should be the non-Microsoft scheduled tasks. So right up there at the top, we see the two Amazon EC2 launch scheduled tasks. Below that, we have something really interesting here. We've got Microsoft Edge Update and OneDrive. Okay, so you're telling me that Microsoft created a directory called Windows and Microsoft, and then created scheduled tasks and didn't put them inside the directory that they created. Cool, thank you, Microsoft, super helpful. Yet another instance where they're just not consistent to their own standards, making it that much more difficult for the defender. I mean, to be honest, it'd be way too easy if they, kept to their standard, and so this adds a bit of a challenge. I like a bit of a challenge when trying to find the adversary, Okay, what other fields might we be able to go see? So there's another field called user ID. This is like the system user that runs the scheduled task. So we can group back all those properties, get that nice clean list, and what we see returned is another instance where 47 of these tasks have nothing in the result. Microsoft's like, you just don't need to know those details, so we're just gonna hide them from you. Cool, thanks, appreciate it. Some administrator stuff, they've got a SID in there as a result. Just some really interesting, weird ways. There's no clear standard for how or why you should run scheduled tasks a certain way. So Microsoft, being the massive organization that they are, doesn't follow any good standard, which is nice and helpful. Now, similar to the user ID field, there's an author field. Author field is who created the scheduled task. So if we return back all of those details, what we'll see here is most of these created by Microsoft Corporation, no huge surprise there. And then we've got 48 results of, blank. Probably Microsoft, just the, secret ninja Microsoft. What I especially love here is now we have Microsoft without corporation. So Microsoft Corporation, blank, Microsoft without the corporation on the end. And then up here at the top, there's a real fun one of Microsoft Corporation with a dot at the end. Just to be a little bit different, because why not? And this is part of the process, like trying to find those things, and it's really difficult sometimes, especially when Microsoft seems to be the biggest adversary in this space. One does stand out as a bit anomalous here is that user01/administrator. So that's host name of the machine and local administrator account. When creating scheduled tasks, it's not necessarily a normal thing for the local administrator to create scheduled tasks within an environment. And so if we wanted to dig into that a little bit, we could filter on that scheduled task with the administrator as the author. And we return back this task. Task name as Intel sitting in the root task path folder. Again, that's that higher level metadata stuff. I want to know what is being executed, so I'll return the execution details. And inside that path, we can see that it is executing this explorer.exe. Except explorer.exe is running out of the administrator app data local temp directory, not where explorer.exe should exist. Cool? Okay, so this is the malicious task, and we could go a little bit further into doing file analysis on that executable, but we found it. Now, I showed you lots of different ways that it's kind of easy to hide amongst the normal legitimate tasks that exist, but this is pulled from an actual example of a larger named threat group that created a scheduled task for persistence exactly like this. Okay, so they often leave something to be desired in their own capabilities, despite being what we'd consider a higher level APT. So you can still find them, and you might be able to find things like this, but even more concerning is those other things that I kind of talked about. Okay. So naturally, my flow for this is, all right, I've done the command line analysis. I can scale that out, but probably not the best way to go filtering manually through all the scheduled tasks. So I would like to get that into a pretty visualization or dashboard so that I can start to find those anomalies a little bit easier. Thus begins my next miserable journey is trying to get these scheduled tasks as they exist. Like I talked about before, they're in a directory. Each file is an individual XML file, and because I want them in Elasticsearch, because that's where my experience is, and I'm familiar with that tool, I need to get them into JSON format. So, cool. Sounds easy enough. I'll just get them from XML to JSON, ingest them in, and build some cool, pretty dashboards. Attempt number one. No foreshadowing here. I'd love to say that I got this perfectly the first time, but didn't quite work out that way. So we start out step one. I need to export the tasks. Like I did before, I'm going to go to PowerShell for this because I'm more familiar with this. I'm not an amazing developer by any stretch, but I can do a little bit of scripting. And so I wrote a quick little script with PowerShell. What this does is pulls back all our scheduled tasks, puts them in a single flat directory, and then gives them the XML extension. So nice and clean, cool. I've exported them from the box. I've put them in a folder of my choosing, and now they're named with .xml, so I can do something else with them. Step 2, I'm going to convert them now to JSON. Again, please don't judge my code too much. I've modified JSON a little bit with Python before, and so I went to Python for this, and I created this simple script. Effectively what it's doing is it's reading in all the XML files, and then it's converting your angle brackets to pretty squiggly braces and trying to keep that structure within the fields so that it's now from XML to a JSON format and nice and pretty squiggly brace, whatever format. Cool, so now I've got a massive amount of JSON files. Perfect. Step 3 is to import them into Elastic. Great. Not so much. So unfortunately, Elasticsearch actually requires them to be an ND JSON format, so new line delimited format. And it's a little bit picky about how it wants that ingested in. Okay, so attempt number 2. Well, actually, there's a tool called JQ that's used command line to be able to view JSON files in a little bit of a prettier format so you can start to do a bit of analysis. You can also use JQ to convert from that basic JSON format to ND JSON format. Great. So that's a simple one-liner right there, nice and easy, and I'll import that into Elasticsearch. Great. Not quite. So it turns out these scheduled tasks are actually like multi-nested, complex files with fields, and they don't follow the same format from scheduled tasks to scheduled tasks, so Elasticsearch did not like how I tried to ingest those in. Okay, so attempt number 3. Back to Python. As I mentioned before, I'm an amazing Python developer, and so I just didn't include my code because it was so awesome and not because it was terrible. Either way, I wrote another script in Python. Effectively, what I was trying to do is flatten the structure of the JSON file, get rid of some of those nested fields, and make it easier or allow Elasticsearch to be happier as I tried to ingest this in. Now we import. Fail. Still too complex. I'm sure it had nothing to do with my amazing Python developing skills, and more to do with just Elasticsearch is making me super angry at this point. But either way, we're now on to attempt 4. Okay, so I was avoiding this from the get-go. I know the correct way to do this. The correct way to ingest a new file format into Elasticsearch or some other thing is to use a proper schema and a proper ingestion process. So that would mean, for Elastic, creating a logstash pipeline, which is more work than I wanted to do, which is why I was avoiding it. Logstash has an XML parser. Great. Okay, 30 minutes later, the task scheduler schema has 658 lines in it. And yeah, that's my life for the next month or more. So I gave up. Okay, so that is legitimately the correct way to do it, and I would love to stand in front of all of you and say I promise that I will get back to that pet project and finish it. I'm not going to make any promises, because creating a Logstash pipeline from scratch is miserable, and I need help. So if any of you know one that exists, and I tried really, 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 really hard to find one and couldn't, please let me know. Otherwise, maybe I'll do it at some point. So attempt number 5, I know another way I can actually get data in is, well, Elasticsearch will take CSV files. Well, okay, so at this point, I gave up on my developing skills and just pulled some random application off the internet, so I'm probably owned by Russia or China, who knows. But there's lots of tools that do the same thing. So I effectively just converted all of my JSON files over to CSV format. It super simplified all of the files, so now we're in comma delimited. Each field name is now just a directory path to the field name itself, and I've got a bunch of CSV files. And import was successful. Yay, I finally made it there. If you're familiar with Elasticsearch, The way that you ingest CSV files into Elasticsearch is manually dragging and dropping and ingesting those files one by one. So almost 150 files later, yes, they were ingested into Elasticsearch. No, that is not the way I'd recommend doing that for an enterprise. However, I wanted to create dashboards, and I ingested the files and created dashboards. So that's where we're at. For this, I didn't record the demo, so I'm sure it's going to fail. This is part of a Docker container that I'm making open source to everyone, so if you want to be able to sift through this data, if you want the dashboards and visualizations to yourself, part of this was an exercise in learning the schema format so I could better inform the Logstash pipeline and figure out the important fields that I want to be able to create those visualizations for. So if I go over to dashboards, I created 5, just kind of categorizing the data in different ways. So this is, I'll try to make this a little bit bigger. This is the overview dashboard. I like to start with just a, hey, high level, how many scheduled tasks do we have? Is there any big metadata pieces? There's a version for scheduled task. By the way, try Googling like scheduled task version and good luck. There's like a bajillion different things. And then down at the end of each one of these dashboards, I have a saved search. So if you want to dig into each one of these scheduled tasks to learn each one of the fields, gain more details, so on and so forth, you get that. So I'll kind of walk through these quickly. I think I'm doing decent on time. Just to show you some of the other fields and information that you'll see to give an idea about how we might find some more anomalies or might find some more different ways to find these malicious scheduled tasks. So this is within actions, right? So the actions or the execution details for each scheduled task. We see here, this is like the command field. If I go back out real short, each one of these has a count on it. So you get a nice clean data table list of, hey, how many times each one of these fields was seen or these results was seen. You can then filter on that and get the full details. Allows for full text search, so if we want to search for things like PowerShell or other phrases, you can do so. This makes it a much more sustainable way to do threat hunting. Of course, if you can get the data into Elasticsearch to begin with, but we'll bypass that for just a second. What's also interesting here is there's a field for working directory. So 2 of the scheduled tasks have this working directory, effectively a different location than where the scheduled task may or may not be created. Interesting implications there. And then a few of the tasks have data for COM handler class ID and COM handler data. Again, I'm kind of just walking through these as additional ideas that you might want to use or things you might want to go look for. So those are our action fields. If I go back, I've got principals. I've got a dashboard for principals. This is effectively that like ownership information of the scheduled task, things like group ID, the principal ID that the scheduled task is running under. Even though Microsoft hides a lot of the information in those hidden tasks, you can actually dig into the details. That digging in requires more of like going and finding the registry key entries that are being modified and then trying to Google what that registry key does to try and figure out like what Microsoft is actually accomplishing. So there is a process to learning what each one of those things are doing, but within some of these fields, there's things that aren't hidden. So you can gain a little bit more insight into what each one of the scheduled tasks is attempting to accomplish. Principal ID, there's run level, there's also login type. So based on the scheduled task, you can specify the kind of login type that it will then execute under. Interesting thought process there. Registration info follows that similar thing. So we've got that author-based information. URI is the file path to where those scheduled tasks exist. I get lots of errors about shard failures because it doesn't like the data format of any of these scheduled tasks as I've ingested them. Again, CSV is not the correct way to do this, but I have a dashboard. What you'll also notice up here at the top is a timeline view. Okay, so each one of these scheduled tasks also has a time associated with when it was created. The one that's way here at the end, 2022-07-26, that's when I created the malicious scheduled task. That is another great way to go look for new scheduled tasks that may or may not be malicious. What's worth noting about this data point entry is if I go back to the beginning, there's a task that sits there at 2005. This machine was not created in 2005. That is when the scheduled task was created by Microsoft, okay? 2 points to that. One, now you know that there's like older tasks that say they have older dates to them. Two, thanks. That means that you can modify that date to be whatever you want. So while this may be a useful point to say, hey, this is a newly created scheduled task, that's not necessarily an accurate field. Got some source description. There's the security descriptors, if you really want to dig through those. That's a whole talk in and of itself. And some description-based information. Last dashboard I want to show you is the settings. So there's some really interesting fields inside settings. These are additional things that you can enable or disable based on how you want to run it. By default here, we have this cool field called hidden. There's 37 hidden tasks by default. That's separate from like hiding the information inside of it. That's taking the scheduled task and making it invisible inside Task Scheduler. Cool, thank you, Microsoft. That makes it even more helpful that you've added in those extra fields for an adversary to be able to hide with, right? 51 disabled tasks. Again, this is a brand new build of Windows and it ships with disabled tasks, either based on your configuration or your build in the environment. They still exist. Those are legitimate things that if you're using something like Microsoft as a defense tool, it's going to ignore any Microsoft things. So if an adversary is able to modify any of those existing ones to do other stuff and you're not detecting on that, yet another way that an adversary can establish a more hidden or robust persistence. There's a lot of other settings set. These are all true-false type fields. Sometimes they say it's false or nothing. Sometimes they say it's true or nothing. And then sometimes the fields are true or false. You know, just because we don't like standards. Idle settings, do we want this to start or stop on idle? Do we want this to only run if the network is available? Interesting. Do we want to only let it run when it's idle or when it's going on batteries, or there is a unified scheduling engine piece and there's a whole nother train of thought with that? Either way, lots of data, lots of information here. I could probably talk about so much more than this, but I wanted to get this out because I can't find anybody else who's doing the same kind of research, who's saying, okay, what scheduled tasks already exist inside of an environment, and how do I find the malicious ones that are already there? Lots of things for detection, and please try and do detection, especially because you should be concerned about this persistence mechanism, but we probably need to get better at trying to find those malicious scheduled tasks that may or may not already exist within the environment. Okay, with that, that takes me to the end. I did want to leave a little bit of time for Q&A. My socials are there at the top, and then there at the bottom is the GitHub link that has all of the resources, some instruction, the Docker containers, script files, so on and so forth. I didn't include my super awesome Python script because, you know, I was too proud. But everything else is there. So thank you all once again. Any questions? Yeah. I'm working on it. So the question was, did you try and replicate how Microsoft is able to hide those scheduled tasks? And it is more complicated than I thought it was going to be. That was the question I hoped I didn't get. But natural progression, right? I think it's possible. Follow me on social media, and I'm sure I'll come up with additional things. I'm going to continue this research for sure, because I find it incredibly intriguing. So yeah, that's what I'm working on now, but I haven't successfully been able to do it in a way that an adversary would do it, right? That's realistic.
There a throwback username for GitHub?
Sorry?
Your username for GitHub?
Oh, there is kind of a story. By the way, I'm known by like a bunch of different, oh, I'm sorry. Is there a story to my username on GitHub? My username is Loopholes. I've also been known by VVCat and a couple other things, but Loopholes was a made-up word for when you can't remember somebody's name. And I'm really bad about remembering people's name, and so that like worked as a handle for a really long time. So not super interesting story, but yeah, kind of one. Yeah?
As a quickie way, Jake, is it possible to just search the dates of all scheduled tasks?
Absolutely, but like.
For inside, you know, like for like, don't you, like I'm going to tell my semi-intelligent cousin, go do this.
So the question was, is there a way to search the date of the scheduled task for anomalies, right? There is. So just like how we pulled it with PowerShell, you can pull that date field that I showed in the dashboard visualization thing. What I did know is it is very easy to change the date when it's created. You can specify any one of those metadata fields, and if you don't specify it, it will create the date that you created it. Otherwise, you can just say, hey, yeah, this was created in 2012, around the same time that Microsoft created some other scheduled tasks. So yes and no. The adversary that I emulated was Fin7, and they're known to be semi-decent, yet that's exactly how they created their persistence. So your mileage may vary on that.
I was just going to ask, had you found any persistent schedule tests that actually would give you privilege escalation as well? Because I know in like Windows XP, back when like before SP2, all like scheduled tasks that you would create were always ran as admin. Or actually system.
Yeah, great question. Question was, have I found any scheduled tasks that are able to establish privilege escalation within the scheduled task? I haven't. I've found scheduled tasks that if an adversary has already compromised that level of integrity, then they can run it within that integrity user. Though you've got my brain thinking about, like, can a user specify the user ID, which is the privilege level that it would run under. I'd imagine Microsoft would probably prevent that. I know in XP they did a really, really bad job at preventing those kinds of jumps, but I need to try it out. Yeah, I've not found any in the like wild though, if you will.
Did you explore using WinLogB and sysmon module for WinLogB to get this data in?
Yes, question was, did I explore using WinLogB or any of the like beats functionality to ingest the data in? Yes, absolutely. The problem is they are structured in a way to format event data logs. Scheduled tasks as they exist aren't in a log format. They're in a scheduled task format, which is separate. And so if we were enabling those like event 4702 or whatever they are for new scheduled tasks as they're created, WinLogB will absolutely ingest the data in. But any existing scheduled tasks, because they exist in that really weird XML format, WinLogB won't read the data and pull it into Elasticsearch.
Sysmon reads the data.
Sysmon will read the data, yes. Oh.
The sysmon module for WinLogB will pull all that in.
Yes, if you had enabled sysmon data and you have the data as the scheduled tasks are created, then absolutely you can view it inside of Elasticsearch.
So sysmon as part of your initial system build would get all this stuff set for you.
Sysmon as part of your initial build, would it get all the data for you? Sysmon doesn't actually return all the information that exists inside the scheduled task as metadata fields. I've got 1 minute left. But it will give you most of the important information on initial build. And if you're starting with a clean build, then yes, you'll get all that data. I think I saw back corner first.
Yeah, I was curious, have you seen or heard of any threat actors or even red teamers modifying the existing legitimate Microsoft scheduled tasks for their own persistence? Is that something that's common, rare, hard, novel?
So the question was, have I seen any threat actors modifying the existing Microsoft scheduled tasks to establish persistence? I will say that it is not difficult to modify existing scheduled tasks to do what you want them to do. I'll leave it at that. My time is up. Please, all the questions, come find me. Absolutely willing to talk more about this. Thank you all once again so much for coming to this talk.
Yep, yep.
That one is a girl, but I have, so I have a
And one is, yeah, one's married, one's moved out. Yeah. Two, four are in various stages of college. You've spoken here before. So same deal as before. For today, the streaming people are the table with the computers.
Okay, got it.
If you can generally stay in a single place, that would be better. Because the camera's on you. That way they don't have to pan to track you.
Yeah, don't do the Bruce Potter thing.
It also makes it easier for you to stay consistently on the mic. And I know you've presented a ton of times before, but repeat the questions that you received.
I love it. Please keep telling everyone that. The worst thing in the world is when you're watching a recording and you're like, why would you repeat the question?
Or like, what are the hell? Or then the answer, yeah, that makes a lot of sense. What makes a lot of sense?
Sorry, somehow I'm still very nervous.
It happens. Don't worry about it.
There's a occupational hazard, activity-related hazard with this kind of thing.
Where are you based out of these days?
Seattle.
I'm flying there on Sunday.
Oh, holy crap!
Yeah, I'll
I
be
am
there
too. Which flight are you on?
5 o'clock,
Yes.
American Airlines.
No.
No, sorry, Alaska.
Yeah.
Yeah, Alaska.
Yeah, I'll be on the plane with you. If you're not in first class, then we can sit.
I am not in first class. I've got a few announcements. So, welcome back. Before we get started with this talk, we've got a couple of things to give out. We are still giving away t-shirts as a thank you for a donation. So please head down to registration if you haven't yet. We have a number of t-shirts still available as a thank you for donation. A whole bunch in kid sizes. So if you have kids that are upcoming hackers, please come by and get a t-shirt. At 2 o'clock we will be selling previous conferences bags, as well as what we call a box of prep. So the box that we gave away last year with additional stuff stuffed in it. Again, all of that money goes directly to charity. We take no money from that at all. It goes straight directly to charity. So please come by again at 2 o'clock. If you are parked in the hotel and you commuted here, come by registration. We have a little ticket that will help give you a little bit of a discount. If you are staying in the hotel, your parking should be discounted based on your hotel registration. The charities that we're giving away for are, of course, EFF. We all know and love EFF. They've been one of our primary charities for the entirety of ShmooCon. But this year we're also giving donations to Broadway Cares. So please, you all have given a lot of money thus far. I think the last I heard was over $10,000 in charity. So thank you very much. Really appreciate that. You good mic-wise?
Check that.
All right, we're
Hell
good
yeah.
mic-ways. All right, I have a t-shirt and something. Let me go see who this t-shirt is from. From Ridgeline International, but this one's not bundled, so I can't throw it very far. And then Profian gave us this small little bag, but more importantly in the bag is a hat and a lanyard and at least something else. I can't tell because it's tied up. So for those of you in this general area, pay attention. All right.
Where's the adventure throwing it?
We just lost HDMI signal. Are you plugged in? Are you up?
Yeah, I'm here. Uh-huh.
All right. Just a second. We're going to vamp for a second. So I have known Jay for our next presenter, who's now the slides are back up again. So Jay, I think we've known each other for more than 20 years. If you want to give us individually money, you can buy a book from 20 years ago and we'll get 0.00001 cent.
Which means we probably don't mind if you found PDFs online.
Right. So please give a warm ShmooCon welcome to Jay Beal, who will be talking about escalating privileges with Kubernetes.
Hey everybody. Wow, this is it's really good to be back. I've got a couple mics here, and I'm hoping the levels are good and I don't feedback on you. Cool. Well, I'm here to do a Kubernetes talk, and I'll be showing you something I found that is some 0-day, and I'll be showing you some other fun stuff. So I'll just jump right into it. So first, I have a bio slide, but nobody ever reads these. They're just seas of text. You could never kind of get through it. So I decided to make a different kind of bio slide, and I hope this catches on. So like Kaz said, the book that he and I, or one of the books we wrote together is up in the corner, but there's more recent stuff like my child on here. Anyway, so this is my bio. I work at InGuardians, and this is a really special ShmooCon for us. We started coming to ShmooCon early on. Before we hit that point where you couldn't buy enough tickets, we would just bring the whole company to ShmooCon and make it our all hands. So for us, this is our 20th anniversary, and it's homecoming. So thank you for thank you all for saying hi. I've actually seen some of you wearing t-shirts of ours from years back, and it like made us all really happy. We like took pictures and everything. Without that much further ado, what are we going to see? So what I'm going to do is talk to you about what happens when you take a Kubernetes cluster and put it on a cloud provider. The one in question today is going to be AWS. I'm not picking on AWS because all of the cloud providers will have this same kind of problem to solve, and they've done some cool work solving it, but you have to know like kind of where the weaknesses are, how much you can, what you can trust it with, and what you have to do, what your part is, what your responsibility is to make things safer. So we're going to go through and basically talk a little bit about Kubernetes and AWS, and then I'm going to do some demos. We're going to attack three of the systems that we use to make things make it so that cloud workloads can do things and have some authentication and privilege, but do that a lot more safely. And that's really hard to talk about generally, but don't worry, we're going to get super into it. I really enjoyed Mark Manning's 2020 ShmooCon talk. He did some really good Kubernetes stuff. If this is the first Kubernetes talk you're seeing at Shmoo, you should go watch his. I'll wait. Okay, cool. So a quick little intro. I can't tell you all of what Kubernetes is, so I will give you the barest minimum of what I can in background. So real quick, I think what we know is Kubernetes is something where it orchestrates work, it orchestrates programs that are going to run on computers in containers. So we call it we basically say maybe it's a software-defined data center via container orchestration. But very confusingly, you will come to a talk like this and you've said, I'm ready to hear about containers, and we'll keep talking about these things called pods, and that will be very confusing for a while, and don't worry, it gets easier. But short version, what you're seeing here are a bunch of pods. Pods are the smallest unit of compute. They have a container in them. Sometimes they have a volume in them. They often have a volume in them. We'll talk about volumes a little bit when we're going through some of this today. But containers are in pods. Pods are on nodes. For the rest of the hour, whenever you see a six-sided shape, that means you're looking at a computer. And that computer is a virtual machine or a physical machine. In AWS, it's going to be a virtual machine, and we're going to call it a node, or we're going to call it a virtual machine, or we're going to call it an instance. I'm going to try to say node over and over just to keep it really simple. The nodes are the things that have the pods on them. Now, this is a weird one, but a node is a Linux, well, for us right now, a node is going to be a Linux machine. Containers are just, containerized programs are just a bunch of programs running on a Linux machine, and Linux kernel's keeping track of, is doing some like note taking and being like, okay, this one can only see this part of the file system. There's whole really cool talks on how little a container is and kind of what it is, but it's cool. So anyway, our issue is that we're going to have, so that's our kind of like simple background for Kubernetes at large. If you came for an introduction, I have thoroughly failed you. But we're going to do fun stuff. So Kubernetes clusters are basically there to run programs. So we can talk about programs, or we can talk about programs running in containers. We can talk about processes on Linux machines. But the simple way to abstract it is to say it's a workload. So if I say a workload, I'm generally kind of mean a program running in a container, or I mean a container. So we'll say workload. It's kind of what the cloud folks talk about, partly so that they can, like in one breath, talk about something where you've got a virtual machine, or where you've got a container running in a Kubernetes cluster, or you've got something that's serverless. It's a workload. So what's running in those containers, in those pods, on the clusters are workloads, the programs that have to do things. And if they're in a cloud environment, they're probably, some number of them, are probably going to be using cloud services. They're probably going to be using the APIs that Amazon holds. I mean, I think, what does Amazon have, like 30, 40, 100, stop me when I get too high, different products. So all of these different things, whether it's like those S3 for storing things, or ECR for holding your container images or whatever, all of those different APIs you basically have to authenticate to most of the time. So then you say, okay, well, that's fine, but these programs that are in the containers, it's okay, I'll just give them all a credential, right? I'll give them a long-lived credential. I'm sure there's some way to cycle them. That'll be fine. You'd be like, well, how will you do that? You could put it in the container image, but we've all heard not to do that because, well, the container image is going to get used in multiple environments, and maybe it's going to get used by other people, and all kinds of bad juju. So we don't do that. What we do instead with Kubernetes or with cloud in general is we kind of like push configuration in, or we let things pull configuration in, but it's kind of dynamic like that. So one of the biggest ways that this happens, that this works out, is you have a container that's running in a cluster on a cloud provider, and it basically reaches out to this thing called the metadata API, which we'll see in an image in a sec, and says, hey, could you please tell me what my AWS IAM role is, and give me a credential for it, give me a short-lived token that I can use? It's like, yeah, sure. So just backing up for a second, the way this worked before we had containers running in machines was this service, this like, I'll give you your credentials if you just query the right point of the network. This was done at the level of a computer. So those nodes, those virtual machines on which we have our containers, each node gets one AWS IAM role, and it just gets one. So that's fine. You're running a virtual machine, you got a program on that virtual machine. It's not like the 90s. We don't put 15 different kinds of programs on a virtual machine normally. We have a virtual machine sized the right way. It's elastic, boogie, woogie, woogie. And that virtual machine pulls down its credentials, and it does the things. It has what level of authorization it needs. But that's not very granular when you say, I actually want to take that virtual machine and chop it up and put 15 different programs on it and have them each be in their own container. And that's what we're going to talk about today, is technologies that do that and then kind of break them. So, okay, so what does this look like? Here's how that works. And here's how that works. Remember, anytime you see the six-sided thing, somebody remind me whether that's a hexagon or an octagon. I think it's a hexagon. Hexagon? Okay, whenever we see our hexagon, that's a node. A node's a virtual machine. Okay, so we got a process. It's running on the hexagon. It's running on the node. And that process basically will reach out to the metadata API, this magic IP address, 169.254, 169.254, and say, hi, could I please have my security credentials? And we'll get back like, yeah, here is your role is the node instance role. And it will let you do things. And you're like, thank you. And now you can reach out to S3 and go and read that Darkhold bucket. Cool. So that's how it works before we go containers. When we go containers, we can keep doing this, but if we don't do anything, if you start up an EKS cluster right now, right, or you start up your own self-managed cluster on Amazon and you want to do this, for any given node, all of the containers on there basically are sharing the same account. That's what you get right now if you stand up the latest EKS immediately. So all of those containers are all reaching out. They're getting the same node instance. And what that means is that you've got to put all the things that a node might need is going to have to go in the same place. And I've got some diagrams for this. I'm going to stop and say, by the way, you might start noticing I say Darkhold and I say Wanda a bunch and I say America Chavez, and this is all themed on a recent Doctor Strange movie. So if you haven't seen it, I won't wreck it, but you'll at least get the themes. So Wanda Maximoff is going to be our kind of bad person. We're basically playing her because we're the attackers, and Wanda wants to get America Chavez's powers so that she can move from universes. Okay, so when we do this, what happens? I've got Doctor Strange and I've got Maximoff. These are each containers. Whenever you see a circle or an oval on our hexagon, on our node, it's going to be containers. So you've got Doctor Strange, you've got Wanda Maximoff. They're both running on the same node. They need to reach out to the metadata API, get their credentials, and then Doctor Strange needs to be able to read this one S3 bucket called Darkhold. evil, powerful book. And Wanda Maximoff needs to be able to, say, do some EC2 stuff, make snapshots of instances, volumes, and start up clone ones, take them over, and in general be batty. But if they're both going to run on the same node, they're both going to have containers on the same node, they're both going to get that node instance role, the exact same thing, node instance role, and as a result, they're both going to have powers that they shouldn't. Wanda will have Dr. Strange's powers, Dr. Strange will have Wanda Maximoff's powers. So the solution to that is what's going to come up next, and then we're going to poke holes in it. So this kind of thing, the way we solve this is with something that kind of gets generally called workload identity. So workload identity is going to help solve this, but this is my visualization. We have all these pods. We have 6 different pods here. They all have different things they need to do. One of them needs to read a given bucket. Another one needs to read a different bucket. Another one writes the buckets. Another one sends SMS spam. Another one creates load balancers and so on. So if we don't add workload identity, the only way to let them all have their credentials via this metadata API thing is that they're all going to have the same node role that's going to be seriously, over provisioned. So what was the first solution? The first solution, classic, still in use, is called kube2im. And what it does is it proxies requests to the metadata API. And I'll show you this on a picture in a second. And what it's going to do, I'm telling you, all of this is just Linux. So what it's going to do is basically programs on your system are going to reach out to that 169.254 address, and kube2im is going to write an IP tables rule that says, let's NAT that back to me, and it's basically going to run that proxy. And for all the things that aren't getting credentials, it'll just proxy it on. For the things that are getting credentials, it'll do what it does. And what it does is kube2im will be the one thing on the node that has the node's account. And it will, and this will happen on all of the nodes where you have evil containers going. Oh yeah, remember, I think all of my users are attackers. I think all of my workloads are either hacked or intended to hack me. It's occupational hazard. So anyway, kube2im is going to intercept all those requests. It's going to be able to, it's going to look at the pod's definition and say, I see that you're supposed to have AWS role this. And it will do this kind of, it'll use the security token service to assume whatever role that pod should get. It'll get short-lived credentials and pass it on. That all seems better on a diagram. So this diagram's not as complex as one of the future ones will be, and I apologize for that a little. So anyway, now we've got Strange doing the stuff in green, Maximoff doing the stuff in red. They're both doing the same thing. They're both hitting the metadata. They both are trying to hit the metadata API. What's happening is instead they're kind of being redirected. So this is the goal: is they end up getting separate roles. Strange gets a role called reads Darkhold, and Wanda gets a role called clones worlds. So what we're doing in this talk is assuming node compromise. So things get it's really weird, beginning, everyone was like, wait, you're talking about Kubernetes and you all are always talking about being inside the thing. You're like, well, it's kind of not that interesting from the outside. There's not a lot of attack surface. And when you're inside, there's a lot more, but the really juicy and challenging part is what happens if you get the container breakout one way or another. We'll talk about different ways. So one of the ways you can get container breakout is just somehow you were able to stage an overly privileged container. The defaults will totally let you do that. Ian Coldwater and Duffy Cooley have a nice little one-liner. If you are allowed to create pods and no one's done anything to change the defaults, then you can create a privileged pod and you can take over the node. So it's not that strange. It's not that odd. The other one, though, is there's constantly, there are Linux kernel vulnerabilities all the time. What makes a program something that's in a container is just Linux kernel keeping track of its view of the file system, its view of the network, its view of, et cetera. So if you have a kernel vulnerability, there's a very decent chance that somebody can turn that into, let's change those tables. So we'll wave our hands and say the container breakout is not just theoretical. So if you've gotten control of a node, whether that by having an overprivileged container, by having container breakout, or any other way, if you've compromised the node, you have the node's privileges. And those node's privileges are kind of like any control plane elements that are on the node that have to have some privileges to do their job. There's whole great talks on that. Again, see some of the ones that I'll reference. Kubernetes has been trying decently hard to make it so that whatever control plane elements are on each node only have what little privilege they should have. So an example is the kubelet that's running on a node. It's told what pods to create. It then goes and tells the container runtime to create containers, and it gives them configuration and so on. And when it does that, it's got to push in configuration. It's got to push in things. It's got to push in secrets. And so it's got to be able to read all these secrets. But the goal is, the idea is, the design principle is, the kubelet on a node should only be able to read the secrets that are for its workloads, for whatever stage to that node. So that's the expectation that we all have, and that's an expectation that's not going to hold up with some of this workload identity stuff that we're doing today. There was a great talk a couple of years ago called Walls Within Walls, What If Your Attacker Knows Parkour, that kind of talked about some of the ways that people were trying, that researchers were getting around that, and then how they fixed it. It's a great reference. So we're going to use, for what we're doing, we're basically going to take a Wanda Maximoff pod, and this pod will probably be like this most of the time. It'll just be something that is able to mount a host path volume. Now, some of you know about host path volumes, and you're like, lame, Jay. Come talk to me after about how the new pod security standards do block, like in the thing that's supposed to block all known privilege escalations, the middle one, there's like pod security standards, there are now 3 things. You either get no, you do it by namespace, you either get no protection, you get complete, but it's a little painful, so you have to be really mature, or you get the thing that, don't worry, it's good enough, it blocks all known privilege escalations, and it missed one. It missed it missed persistent volume claims, which were in Kubernetes' first third-party audit. So I don't know how that happened, but maybe it was for backwards compatibility or something. But this is actually reasonable. I use the host path volume instead of doing the PVC because it makes it a little easier to follow. What I want to do is do a first demo and basically say if we can compromise one node, then we get, remember I said, if you compromise a node, you should get the ability to read the secrets for any workload that's put on that. You should only get what privileges you need for that node. We should be able to have a compromise of one node without losing the whole cluster, without losing either control of the cluster, control plane, or without losing, honestly, whatever the cluster was there for. And in Guardians, we've done a bunch of pen tests, and our experience has been, if we're on a cloud provider, very often, even if we can't control the cluster, the kinds of things I'm about to show you end up making it so that you end up getting everything you wanted. It's like the whole thing we're on a Windows environment. If you don't get DA, but you do get every bit of contents, the file shares and the databases, you have all the data, who cares? So let's do our demo. So what I've done here is just done a quick thing to show you what happens when you're in a pod. So this pod's called Dr. Strange. When Dr. Strange says, hey, give me my identity, I'd like to know who I am. Apparently I need to switch what is shared. That's not good. How do we do that? Let's kill that and go there. Did that do it? No. Well, that's very bad. And I am in that mode where you're like half as smart as you normally are, because there are a whole bunch of people looking at you and hoping that you'll, use their time in a way that doesn't, that's considerate. So there we go. Okay, so here we are. We're going to start out. We're in one pod. If we're in a pod, this is a cluster that's running kube2im. If we're in a pod in a cluster in AWS and they're using our first workload identity product, kube2im, an open source project, if you're in Dr. Strange's pod and you reach out and ask the metadata API for your role, that is if you just run some AWS commands, what you get back is, hey, you have the protect timestone role, not the node's role. Good, that sounds great.
Can you make the font bigger?
I can't. The question was, could I make the font bigger? And the answer is, no, I have apparently potentially screwed you. That sucks. I hate when people do that. I will narrate a bit. What's scary is he's in the second row, so I've really screwed up. So anyway, what I've done is then put us in another pod. I put us in that overprivileged pod, in that Wanda Maximoff pod where we're going to mount the file system of the node. So in mounting the file system, then I just ran a chroot command so that everything will feel like I'm just in that file system and not in the containers file system for a little bit, because that'll make it easier for me to go and use for me to go and explore the file system and so on. So what I'm going to do, this is a container that actually has, it's running, it's got that file system, it's also sharing the host's network interface, so it's kind of like that part of the containerization has been broken. I haven't gone as far as just saying, I have access to the file system, let me set up a cron job, which is something we do in Paratis. We're like, we have access to the file system, we'll set up a cron job, have something reach out to our C2, cool, we're outside all the containment. So I've just, the kubelet is allowed to get a list of pods and get all the detail about the pods. We're going to use that a few times today. And so what I've done from Wanda Maximov's perspective is I've said, give me a list of the pods, and then I've said, give me all the detail, all the status detail about the pods. Nothing secret, but all the status detail about the pods. And it tells me all of the all the AWS IAM roles that are in use. So cool, I see some. Remember, Wanda wants to travel the multiverse. She wants America Chavez's power to travel the multiverse. And so what we're going to do is try to get that capability. So I've taken that list of roles. We're calling them ARNs. I put them in an ARN file. And then I'm just running a quick loop that says, hey, let's do a hit the STS security token service and ask if I can assume each of the roles. And because we've got that, because we've broken out, we're able to assume every role that is in use. We're able to assume every role that's in use that node might have to use. And by default, the way every cluster I've seen is set up is that no one is really doing the extra work, and it's actually a pain in the butt because part of what you wanted out of Kubernetes was to be able to really flexibly use all the compute and not have to spend more. So people will make it so that every node has the ability to assume every role that could be used anywhere on the cluster. And so what I'm showing you is kind of a quick manual example of something that some of my coworkers automated. And so what I've done is just said, let's go and do an STS to every single role. And we can just see that going by, and that kind of gives you a sense for you can do a lot. So as soon as we're outside the container, we have probably all the roles in the cluster, but at least all the roles that could be used on this node. Not even the ones that are being used, but the ones that could be used. It's fairly weak. We're going to take one example. This is a shorter demo, and we're going to say, hey, let's take that America Chavez, the role that the America Chavez one had, the travel the multiverse. We'll ask for it. We get those credentials, and if I take those credentials and use them, just export my AWS environment variables, then when I run get caller identity again, it says, you have that role. You are doing things as that role. And whereas Wanda Maximoff couldn't list any of the S3 buckets, this other account can, this other role can. And so Wanda has gotten the ability to see all the S3 buckets, and actually America Chavez is so provisioned that Wanda will go and just delete one too, because she kills people, so she just took out a universe. Hope you didn't, or at least the Kamartaj, hope you didn't level those wizards. So this is kind of this is the simple one. This part, I would say, is not new. I think that lots of people have got to know about this. So that's the kube2im, and the reason, so I'll just kind of show you the implementation, why that is. So the way it works, remember, if the strange container or pod tries to reach out and get to the AWS Meta API, it gets redirected to a kube2im proxy program, which is set up, via IP tables. That's our steps 1 and 2. And then step 3, kube2im actually makes the query, actually goes and asks the Kubernetes API server, tell me about this pod, what role should it have? It's just an annotation, it's listed. I'm not going to get into kind of like without namespace isolation. It's like if you can create a pod, you can have all the service counts you want. You can have all the, it's really bad. So anyway, you get back, the API server tells kube2im, yeah, that pod's supposed to have reads Darkhold. And so kube2im asks the STS service for a token for that role and gives that token back to Strange, and Strange can do Strange's things. So that gets us, without the container breakout, without the overprivileged stuff, that actually does make it so each of the containers gets a role and not all of the roles. But if you break out of the container, this one's trivial. And the way that I got to have some experience with this, I didn't get to have a direct experience with it. I got to watch some of my coworkers who were in our front row. We have Rob Curtin-Seifert and Jareth Kelly, and they actually were on this big test. And like I said, you have lots of things in the cluster. So this is a big product, and the company was running the product in Kubernetes. They had like 50 different roles, and those 50 different roles could do lots of things. And they also had, let's just say, 100 different buckets. And we're like, well, wait, we know the one bucket has all the keys to the kingdom. It has, like, if that bucket was violated, then it's game over, it's awful, it's really, really bad. And one of their coworkers said, yeah, but you'll never be able to actually figure out which one. Like, we don't have the ability to get whatever. So, like, you're going to go and, like, you can spend the next 3 days, like, doing that. This isn't practical exploitation. And they said, hold my beer, which is a phrase I hadn't heard. And they wrote a shell script, because as consultants, you often don't have time to write more involved things, but they wrote a shell script that basically iterated through every single one of the, went through and did the same thing I was doing with those 5. It went through every single one of the roles, and from every one of the roles, it tried to do all the things, read all the buckets, and came back and basically made a pretty, Excel spreadsheet. And these are all our attack paths that get us there. Call it a very, 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 very poor man's bloodhound. So anyway, Hold My Beer was epic, and I still refer to it. So kube2im, why is kube2im not that strong? It's requiring every node to have a role that's capable of assuming the roles that any workload on the cluster, or at least any workload that would be on it, and usually any workload on the cluster would have, which means every single node you have is basically super over-provisioned. And the problem is, like you've got, in Kubernetes, you've got your control plane nodes, which are kind of better protected. You're not running, there's nowhere near as much ability to, there aren't going to be workloads. There aren't going to be things that, things that you put on there. Things that developers put on there, et cetera. That's not where the work is happening. You've got the worker nodes that are the higher risk. So each one of those higher risks, each one of those worker nodes has a lot of privilege. So that's kind of the downside of kube2im. So there's your takeaway. For us, that's meant, like, each time, almost nobody actually goes and says, I'm going to make a node group, and this node group will only be for these sensitive things, because outside of presentations, it's not usually the case that you have only one sensitive thing on the cluster, and you're like, okay, cool, these nodes are just for that one thing. The rest of the nodes can be for everything else. You usually are doing a lot. We'll talk about that later on. So the next thing that came along, and I'm watching my time, the next thing that came along, and this is the thing I'm going to share some 0-day in, was KIAM. So KIAM basically said, okay, we're going to stop having the worker nodes have this level of privilege. Directly. The worker nodes will not, they don't need any kind of AWS IAM role at all. Like, you can assign nothing to them, you can assign a dummy role that can do no things, that's just fine. What's going to happen instead is that the control plane nodes, in most clusters, there's either 1 or 3, right? Those control plane nodes will have a thing that will have a role that can transition to all the roles that might be used in the cluster. But these worker nodes, they're going to do the proxying part. They're going to take the requests that are coming in and intercept them, and then they're going to figure out what role should be given, and then they're going to ask a server, they're going to ask something on the control plane, can you please give me a token for that? And that thing on the control plane is probably, going to do some good security checking of some sort and say, yes, you can have it, pass it back, and give it to the thing. So this was, you'll notice the second bullet in their README, it says, hey, look, this is going to be better, this will enhance cluster security, because the thing that's going to be doing the assume role STS work is over here on the control plane. There's very few of them, the worker nodes deprovisioned. So this should be great. Okay, well, let's see what that actually looks like. By the way, yeah, let's see what that looks like. Let's go demo first. If I'm going to make you look at stuff, okay. Again, I got to turn off the one, go to the other, and go to the next thing in my playlist. Said go to the next thing in my playlist. There we go. So this is a KIM cluster. So in this case, we're Wanda Maximoff. We have an overly privileged container. So we're able to get to the root file system of the node. Wanda Maximoff, normally in KIM, just like in Kube2IM, the effect is asks for what asks what's my role, and is told you have that role that can just read the Darkhold bucket, nothing else. Wanda doesn't want that. Wanda wants America Chavez's powers. So what's going to happen? So Wanda's going to say, okay, what can I do? I can't read that bucket, but remember, I've got the ability to, I've got the node's file system. So I'm going to go and I'm just running a chroot to make commands easier. You don't have to do some stuff. So I'm going to run kube control commands, and I'm going to use the kubelets. Credentials. So the kubelets credentials, remember, we'll need to be able to pull secrets for any pods that will run that are running right now on the machine, but won't be able to pull all the secrets in the cluster. The kubelet has been deprovisioned. It's being wow, give me the word. Somebody who's got English. Desupported's kind of good. Deprivileged? Deprivileged! There we go. Man. Yes. Yeah, so the kubelet's been deprivileged a lot, and maybe it should be like a little tiny bit more, as I'll show you in this. But the kubelet is going to be allowed to pull secrets for anything that's running on it, and that will end up being kind of useful to us. But it also is just able to list all those pods, and that's really helpful, and get all the information about the pods, like what ARNs are done to what. So using the kubelets privileges, Wanda sees that there is, and I've made things a little harder, there's an America Chavez pod, but that America Chavez pod is not on the same node as Wanda. So America Chavez, like gone and used taints, tolerations, and node selectors to make everything else land on the one worker node, except for America Chavez, our keys to the kingdom workload, and I put that on the other node. So from a secrets perspective, from like our normal expectations of Kubernetes, the breakout on the one node shouldn't get us Wanda's privileges. I say should, which as a longtime consultant is that word I listen for, because either as a hacker or as somebody trying to manage a gig, it's always juicy. It's always the place where someone's not sure. So what we do real quick is Wanda's going to just get that listing of pods, get all the IAM roles that are in play, same as before. We've got that kind of list of those four, and then that travel the multiverse one up above. And we cleared the screen, and now we're just doing that one more time. We're just going to grab that list of roles and stuff it in a file, because Wanda's going to want to be back in the container and not on the node in a sec. So we've got that list of things. We also, I'm asking you to imagine that when I showed you the IP address that belonged to America Chavez's pod, that we made note of it, that we wrote it down. So you all wrote it down, right? I forgot to. So here's Wanda's IP address, 1038.04, and here's America Chavez's IP address, 1040.03. By the way, those IP addresses, one node got 1038 for its pods, another node got 1040 for its pods. Kind of, useful, and makes some of the diagrams actually make a little more sense too. So Wanda Maximoff, who's on worker 0, wants privileges that should only be available on worker 1. Making a quick little note, Wanda's on worker 0. Type faster, recorded J. So Wanda's just going to do one more thing. Wanda's going to look for those, everything in Kubernetes is getting stuffed in a container, in a pod. It's kind of cool. It's totally eat your own dog food. Not everything, not the kubelet. Wanda's going to take note of where the KIAM agents are, where those proxies are. You have a KIAM agent on each worker node, and they send requests for credentials onto the KIAM server. So these KIAM agents, the one that's on Wanda's node, and so again, like probably shouldn't have privilege over anything that might be on some other node. The one that's on Wanda's worker node is this one whose name ends with a 9. And Wanda's going to ask for a little information about it. So we're going to say, hey, describe this pod. Tell me about this pod. Tell me about its configuration. And what we find is, oh, there's a secret. Oh gosh, darn it, this is not specific. All the nodes have the same secret. So these KIAM agent secrets, just a TLS key and a CA cert. I was able to pull the secret because I have the kubelet's credentials, so I can pull the secret for anything that's running on my node, but not on anything else. So we're going to grab that secret, and we're going to use it. We're going to use it to impersonate KIAM. So what I did, and I'll put the source code up with the slides, is I made a little program called Impersonate KIAM that Wanda can run, and we'll do that. So I need those keys. So I have those keys from the one node, and we can kind of take a look at what they look like when you base64 decode them. And the program we wrote, it's in Go, and what we did to do this, okay, so first, simple, what does it do? You run the program, you say, hi, I'm going to run impersonate KIAM, I'm going to provide that CA cert, the key and the cert, I'm going to give one more thing that's useful for the TLS connection, which is to say what the host name is of the KIAM server, that's well known. And then I'm going to say what the IP address is of any pod in the cluster I like. And I'm going to do that. I'm just pretending to be the agent. And I send that to the KIAM server. And the KIAM server says, oh, I know that IP address. That IP address gets rolled, do all the things that you shouldn't be able to do from your node. But I am not really keeping track of, I could know that you shouldn't, but I'm not actually going to bother to check. That IP address gets this role. You asked for that role, and the IP address that you say you're representing is the one that has that role, so here you go. And the game's over. That's great. You can iterate through all the IP addresses. If somehow we couldn't actually get the IP addresses, that were in the pods, that'd be fine. We can just run that and basically just kind of iterate through all the IP addresses in the 10 dot space. It'll be fine. So from that, we get the same kind of thing that Hold My Beer gives you, which is, hey, copy and paste these export lines, and you will get that role. So we can go and quickly just copy, paste, and now say get caller identity, who am I? And it says, hey, dude, you are that highly privileged role that your node has no business knowing anything about. And we can use it. So I think in this one, I just list the buckets. I don't actually, and so just to keep in theme with the movie, we've got the universe. We've got the different universes that were 616s in the movie, 838s in the movie. There are like 70 more, but I didn't want to write that many. So anyway, that's our KIAM thing. Let's talk about what that was about. So what we basically found is if we could compromise one node, we can't get all the secrets from Kubernetes. They thought about that. That was really intentional. They gave us powers so we could make sure that our workloads that if we wanted to, if we did the work, if we were willing to kind of take the financial hit, as it were, then a compromised node wouldn't have anything that would be, wouldn't have any Kubernetes secrets or other privileges that would belong to workloads on other nodes. But we come over to AWS, and we have our thing that was supposed to be better for security, and actually, if you think about it, it's worse. So found that a little while ago. Sorry, held on to it for a little bit. The good news, actually, is that the project is not canceled, but it's in maintenance mode. They will make security patches. They will make other kind of patches. But they're kind of telling you should go to the next thing we're going to talk about, Ursa. So anyway, that's that. I have a little diagram for how that works based on implementation. And I will take my friend Mike's advice and not go through every little bit of it right here with you. But I spent a lot of time working on this diagram, so I highly recommend that you download it later and look at it. But it basically tells you this is how this is supposed to work, this is how this works, and if you notice, like, the problem is that the KIM server actually never checks to see whether the KIM agent that's reaching out to it is actually running something that, is actually running the pod whose IP address is being asked for. This is very much like well, it works, so it must be, yeah, it's a security tool and it's working, so that must be good. Again, this kind of thing like, oh, you're a KIM agent. You are logged into the system, thus you are good. Cool, right? We've all been on those pen tests, or we've all seen those systems where it's like authentication, no authorization. Yep, it's really fun. So anyway, I try to make that a little more obvious, like, hey, wait, the pod IP's on this node over here, or one set, the pod IP's on this node over here, and the KIM server didn't even bother. Okay, so KIM does have one security feature where you can like annotate the namespaces to say what roles pods in those namespaces should be able to use, but that actually doesn't matter for us at all because we're just getting all the roles that are used anywhere in the cluster, and we don't care about namespaces. It's the namespaces. We don't need no stinking namespaces thing. Okay, so anyway, so that was kind of like first gen workload identity, sorted. Second gen workload identity, are you sure this is second gen? Sorted. And that brings us over to Amazon's URSA, so IAM roles for service accounts. And URSA is actually kind of smarter. It's not sitting there intercepting requests to the metadata API. Actually, if you're using URSA, it's going to work differently, but you still have to go and set up an IP tables rule to block off the metadata API, or all the things that we were dealing with already are still here. You have the nodes, you have node privileges. You have whatever roles the node would get from that API, so be careful. So what happens instead with URSA is like, it feels like some crypto people actually got a little involved. So URSA doesn't intercept requests. Instead what it does is at the time that you stage your pod, it says, it looks at the annotations not on your pod, but on whatever service account you've got. It's like, oh, well that service account, that Kubernetes service account has been mapped to this IAM role. It's kind of nice because lots of people are allowed to create pods but aren't allowed to create service accounts. So it's kind of, you're moving the authorization to break the system further up the responsibility stack. And so URSA basically says, I see that you're standing up a pod and that pod has this service account. I will go and get you. I'll basically go and get you short-lived credentials, and I will push them into your pod as a volume. And your pod will have that volume, which means that the node you're running on will have it. But I haven't figured out how to break the node issue. I'm not bringing you the KIM issue here. So it's cycling just like the others. The credentials are short-lived, which is great, and it's neat. And I did not give you a super dense diagram on that. So anyway, I'm going to give you a quick little demo. The issue with URSA is still that if you get to the node, if you get to the node's file system, if you either run an overprivileged container or get container breakout, thank you, then you can go and hoover up everything you want that's running on that node, but only what's actually running on that node right now, not what could be running on it. So it's getting worlds better. So I have a little demo, and this one is even shorter, and again, I need to remember to do this. So back to our, come on, full screen. Yeah, that's the other one. Once they tell you that your time is starting to run shorter, then you get stupider. I'm telling you, we all do it. So here we are. We're in Wanda Maximov's pod. It's allowed to mount the file system. This is what you see when I've chrooted just to make it so that we're working from a given directory. We can see that there are all of these. We can see that there, for every pod that's running, there's all of the volumes. Remember I told you we come back to volumes. They're all the volumes, all this kind of stuff that's being pushed in dynamically at runtime, at the time the pod is started, and even being modified as it runs. And what's being sent in now is these AWS IAM tokens you see. So the IAM tokens now are being provided in these volumes, which actually makes them a little harder. Like some kinds of overprivileged containers can't actually get to them so easily. If we're privileged, it's endgame privileged pods probably should never exist, but or at least be more granular than that. But we can talk about that another time. So anyway, there are these IAM tokens that are being mounted in. I'm just gonna. So what's Maximoff going to do? Find all the things that are directories, find the ones that say container on them, and that's simply because it gives us a really quick way for me to show you which of those long hashes maps to what container names. So we have Dr. Strange's container name, and we can find other ones. So these are just the containers running on this host, on this node, which means I don't see anything from America Chavez, which is kind of a pain in the butt if I'm Wanda. So I see these volumes, and in the volume for, I'm using the one that belonged to Dr. Strange because he gets the, title billing, that word eponymous that took forever for me to learn. And I'm going to go into that AWS IAM token directory. I'm going to find a token, and if I take that token and throw it into a JWT decoder, I can find out like, oh, this thing says you have like you are this it's actually mapped to service count. It's actually a bit of a pain in the butt just to find out what role that's going to correspond to. But I can take that token, I'm going to copy it out to the root file system here, and so I can exit the chroot. And then I'm going to say, okay, what roles here are available, and look at the environment variables, and use those environment variables, and basically say, Dr. Strange, what role does he have? I need that. I need the role name. So I had to find, I have to find some way to get it. This is actually getting to be harder. It's a little bit more of a pain in the butt. And so now I'm going to do that slow typing where I put in the role name, I put in the location of that token file we just used, which is in /mount token. It's available in the container because we did that kind of host path mounting. And we can do that get caller identity, and it says, yep, you got that assumed role, you've got protect timestone, you have Dr. Strange's timestone, which somehow has become even more important. I think we learned that from the Loki TV show than the damn reality stones were. Yeah, people don't watch too much TV. That's good. So anyway, so what we got out of that was in Ursa, if you compromise a node, if you get access to the node's file system, if you have an overprivileged pod, if you get a container breakout, then you still do get all the AWS, you still get AWS credentials for everything on the node, but only for what's in the node. So you're having that kind of situation where you're kind of getting what you expected in terms of, the way the kubelet was deprivileged, in terms of what you think you should get on a node. The blast radius is lower, ideally. So this is kind of cool. So Ursa's stronger, but I was trying to search for your takeaways besides, hey, look, I broke some stuff. Oh, I just got the, cool. I have under 5 seconds or less. Hey, go grab the slides. Everyone get your cameras out. I'm going to give you a QR code. You don't have to. Go to InGuardian's website, you can find it, and there are lots of other people that you should learn from. I've put a ton of their handles on here. Also, follow InGuardians and me on Mastodon and Twitter and stuff like that, and see you around. So, thank you.
Oh, really?
Yeah, so last night I was up very late, like doing like why the fuck my like cluster works and I'm trying to.
Oh, really?
Yeah. I mean, Kayam is basically dead. Like, you just demonstrated there's no future for it, right? Like, there's no remediation.
No, I mean, like I could flash, but like I couldn't get the whole like I started to get before I could get a hold of it.
Oh, really? Oh, then it's gone. Okay.
So I'm like, this really should be responding. I know, what is going on? Just moved on to, more profitable things or something.
Well, that'll be me too. Hey, I wanna talk to you about some Snowflake work and stuff like that for actual Guardian stuff.
Dude, that would be awesome.
If you guys have today.
Yes, please. Do you want to?
Speaking of my DMs or something, like, how have we been talking? I forget.
Probably that. Do you want to just sit down in 20 minutes?
Yeah, 20 minutes.
Reg is a very easy place to find. That's central. So I would call 20 minutes to be 12:15 to make it easy. Okay. Series 7 timer for 12:10. Call code to Reg. Not you all.
Yeah, we gotta do like a
I will answer a question in exchange for photos. I'll take photos and listen to other people's questions. I want to get the badge out of the way. Oh yeah, much better. Good enough quality for you, or do I have to do a read? Yes. Yeah, as well as my eyes. That's all. So the
I'll catch up
slides-
with you later. I'll catch up with you
This
later.
is old ShmooCon shit. Okay. So, you know, from I don't remember what it was. It's not poison. Oh, like sulfur. Well, but no, anything. Right. Hello. You're Brian Pham. Oh my God. Yeah. The slides are on the Guardian site later today. Very soon. Got it. Very soon. Okay. Because I was like, I got the last thing, and then I tried to take a picture, and it didn't. Everything around is like, oh shit. Okay. Yeah. Awesome talk, though. Thanks. All right. Thank you. Okay. Someone will kick off. Jack up again? Yeah, it's not connected again.
My name is Brian. I'm going to be introducing you as soon as they get all their stuff set up.
Current information. I finally broke out of it 40 years in the Department of Defense, and I'm out doing So I'm actually
So this is the since you do want to right for lunch, so
I timed it on like 5-40 minutes. Any question?
okay. So they'll have a sign for you if you move enough to or you're getting 10 minutes, 5 minutes, get off the stage.
this one decent now?
Maybe if they don't agree with, well, whatever they're doing, they're changing your AV settings. Well, theirs is for a different reason. Yeah, they're
Your laptop is still sharing?
Still says it's me right now.
I'll read here. For the most part, it's, I get to So welcome back. We're struggling again with AV issues in this room, so please give us a minute as they're working on that. I've got some more, the same announcements you've probably already heard before, and I have some more stuff to give away. Some of the stuff that we give away is heavy and would hurt if I threw it at you. So one of the benefits of sitting up front is that you can sometimes get nice giveaways. All right, so we have a number of t-shirts that are available still. At 2 o'clock, we will begin giving away, as a thank you for donations, past conference t-shirts. Those will be available for $10, again for charity, and past bags. So if you liked previous conference bags, I know, for example, the bright orange dry bags, we absolutely love those in my family. So we've already picked up another one of those. So those will be available as well at registration for a $20 donation to one of our 2 charities. Additionally, we have boxes of crap. It sounds terrible, I get it. But they're actually pretty cool. I opened one up. They're all different. The stuff that's in there is, every box is going to be a little bit different in terms of what's in them. The one that I bought and I opened up had one of those steel mugs, really nice, a whole bunch of other stuff in there, and a moose. So I have a moose that I'm going to give away. Is there anybody under the age of 15 here today? Are you actually under the age of 15? You're a tall 14-year-old. So would you like a moose? Thank you for coming to ShmooCon. We love to see the younger generations come out and learn, so we really appreciate that. I have a t-shirt. This is one I'm actually going to throw, so pay attention and good luck. Yay for not getting injured. All right. And they're going to continue to work on AV stuff. So if you are parked in the hotel, we recognize that it's incredibly expensive. We're sorry. It's not something that we can control. If you are staying in the hotel, if you're in the room block, the discount should already be applied to your parking when you leave. If you are staying here and commuting in, right, you live in the local area, come by registration. We have a little ticket that you can get that will reduce your cost parking here. I know it's expensive. We're sorry. It's just part of doing business. All right. It looks like.
No, we're not ready.
Oh, we're not ready.
This is debugging.
Debugging AV stuff still. So continuing on with our COVID response, this year we are not doing our traditional giant party. We are doing something that we adopted last year. We're going to continue that again. We are going to be have small tables available scattered throughout, such that people can congregate, but in a more safe fashion. And we'll have plenty of board games available and other opportunities to interact, mingle, and socialize, but in a much more safe fashion than if we were all standing around drinking excessive amounts of alcohol and dancing. All right, it looks like we're still continuing to debug.
We'll be there soon.
Just waiting for Gmail to scan for viruses.
There's no malware there, right?
Not yet.
All right, it looks like we're about ready. Okay, so without too much further ado, as we slide the replacement laptop in place, I would like to, while our next presenter has spoken at other conferences, this is their first time speaking at ShmooCon. So we want to give a very warm ShmooCon welcome to Jacob, who, as soon as we can get Office to do its thing. Come on. Almost.
Computers. All right.
All right, there we go. Please give a warm ShmooCon welcome to Jacob, who will be putting on a big show, defending by attacking attacker incentives.
All right. Thank you, everyone, for coming. I know this is the coveted me between you and your lunch slot, so I do appreciate everyone that is here. And yeah, so let's get started because we are running a couple minutes late. So real quick, I'm just going to talk about deception, both from what I've seen as an outsider and then as I've slowly started to learn about it, and how we see it at Things Canary. Then I'm going to hit my mental model for conspicuous deception, which is kind of what this whole talk is about, and then a couple implementations, one of which is kind of like ready and, out there, and then the other one is more of like, first steps. And then we'll wrap up and hopefully have some time for questions. So real quick, I've been kind of in different places across the cyber kind of field for the last 15 years or so. I ran some teams at AWS Security, kind of in the AppSec role. I was a DARPA program manager. I got to fly an F-16. Is this slides not? Oh, it only works there. Okay. Look over there, everyone. And then before that, I was doing hypervisor, OS kernel type research. So now I am at Things Canary, Things Labs. I'm new to the deception space. It's kind of a weird place for me to be. And so I'm still learning a little bit about it. And so this is kind of some of the things I've seen and what I've picked up. So now I work at a deception vendor. We're not here to sell you anything. Everything that we're going to talk about is going to be open source or free and given away today. But I have been in the audience both as a PM, you kind of always are getting pitched ideas, as well as, just kind of going to RSA. I've seen the deception hype cycle. I hear that it's the next big thing, and then I've seen it. Now we have no slides. Okay. It's deception, not like stealth. All right, well, you can imagine that there is a slide showing how excited people get about deception, and then when it doesn't work, people are a little more upset, and then maybe they start to actually get some real value out of it. There we go. We got 1 out of 2. Perfect. So kind of what you usually see, and I'm sure some of you have been to an RSA booth or a Black Hat booth or been pitched, you see something like this. You see a picture from one of the previous world wars where they have an inflatable tank, and then of course you have to quote, the master Sun Tzu, and so they throw a slide, a quote from him about why you have to have deception. And then it never really goes beyond that. Like, I've never seen it hit that tipping point to something that really creates a lot of value. And so, coming to Canary after it's been around for a number of years is very different, right? So, in my mind, deception exploits the information asymmetry between a defender and an attacker. And so if you can deploy deception in seconds or minutes, then forget about it. You have no more cognitive load, but an attacker who's trying to understand and learn what's in your network, they have a lot more to sort through and try to get themselves oriented. And as they're stumbling around, they're creating noise, they maybe are alerting you, or at least they're not being able to maximize their attack because they're kind of confused about what's going on. And so real quick here on the left is what our hardware canary looks like. And then it looks like it's a Windows server, and it takes about 20 seconds or so to deploy on your network, and now you have a Windows server that people start interacting with it. You start getting alerts, and you can start kind of getting at least a little bit of a tripwire. On the right is the canary tokens, which are kind of smaller subsystem level tripwires. And so in this case, one of our canonical examples is we will vend you AWS keys. You can get a unique set for every single laptop in your organization. You can put them anywhere. And if an attacker who gets on that computer sees, ooh, they have AWS credentials, what's behind that magic gateway? They then open it. They see, oh, well, actually, it's a canarytoken.com key. I've just gotten busted. And on the right, you'll see when I hit manage this token, it's kind of small, but you can actually see that we got an alert that someone is calling get caller identity from that. And so this is it's a free way. Like, you go to the canarytokens.org right now on your laptop. You don't have to sign up or anything. You just get this for free. And so this is kind of the idea behind canary tokens, and this is kind of the thought process that I've been seeing in the deception space since I've come to things. And our thinking seems to be working. We do have a lot of love, public and private. Just recently, someone used an AWS key in their Circle CI environment to detect unauthorized access, and then a few days later, Circle CI says, hey, we've been breached. And so that was a quick, easy way for someone to be able to get a level of trust in their vendors and be able to understand how secure or insecure they are. And then we also get reports from red teamers who get caught by us, and it changes their behavior or at least pisses them off. And so it kind of works in this way. But something that I didn't expect, I started seeing as well. So privately, we get a lot of love as well, and you start to see this strange sentiment of, we don't want to tell anyone that we use you because then, the deception gig is up. And so we want to keep it very private, don't share our logo, don't talk about us as customers. And so they have this sentiment, which I always think was a little strange, because I've always seen the fact that there is something like that altering behavior. And so this led me to a very brief stint, jokingly, in BizDev, because think about to that token example. As soon as they call get caller identity, they see they're using a canary token, and they're like, crap, I just got caught. So what are they going to do? Next time they come to AWS keys in some organization, unless they need to get through there, they may leave them alone if it's not part of their objective. And so we had a red team recently attacking us. So we gave them access on a laptop in our network, and we said, go ahead. And then we watched to see what they were doing. And obviously, we have a lot of canaries running in our environment. Every employee has some for their home as well. And they did nothing. They just sat on that laptop terrified to try to scan or go outside of there. And so it was a pretty, not great report for us. We didn't learn a lot about how we can improve because they didn't do anything other than say, well, this laptop that you gave us access to, we could access it. And so this is also you can, on that one slide that works, one side that works, you can see that now this is, a red teamer who now is altering their behavior, and they're changing how they work through your environment. So they're going to be slower. They're not going to be able to exploit your environment quite as deeply, and then there's going to be that kind of concern in the back of their head. And so my BizDev joke was that we should offer a Canary Basic program where you pay us $100, we send you some t-shirts, and we tweet, hey, thanks XYZ Corp, for buying 50 canaries. Love to see that they're all deployed. And then if an attacker is researching XYZ Corp, they see that tweet and they go, oh, maybe I'll go elsewhere, maybe I have to be really slow, maybe I have to find some other things. And so, jokes aside, like that's kind of where we're at. And so that's what we're calling conspicuous deception. So we're overtly signaling that we are lying to you about capabilities and maybe that they're deployed. And the maybe that they're deployed, thank you very much, is actually a pretty cool thing as well, because organizations that do nothing still get a little bit of benefit from that. So stepping back a little bit, what do attackers want? I mean, it feels great to pop a box and get root and domain admin on an engagement, but at the end of the day, that's really not what their goal is. They want something else from that. And different attackers want different things, right? So there is some reason that they're going after an organization. It could be fun, they want street cred, they don't like an organization politically, they want money, which is a big one, or, say we are in DC, they want intelligence or to steal some like sensitive information. And so by understanding the incentives, we can figure out how to kind of counter those, right? So money obviously driven by financial incentives, intelligence, you're trying to either steal information to understand what your adversary is, or farming access for later, if you're going to tie it with something else. Political is kind of one of the weird ones because most of the other actors are fairly rational, right? Like a ransomware crew doesn't go and spend $10 million buying a bespoke exploit chain and then asking for $2,000 ransom. Like they want a payoff at the end of the day. Someone who's politically motivated may just kind of waste so much time because they're driven for it. So that's one of the more difficult. They're not necessarily a fully rational actor. We also talk about attackers being on a spectrum of technical sophistication, so people who are like script kiddies or running low orbit ion cannon versus the APTs with their 0 days and their sophisticated stuff. I think there's also another spectrum of attacker sophistication, which is what I'm going to call translation, which is basically how easy it is for them to translate access into their goal. And so I'll talk through a couple of those, but I also want to call out that we're not the first people to think about attacking attacker incentives. So Dino Dizovi, he gave a great keynote at Black Hat Asia a few years ago, and he had this kind of fake quote of like, I rob banks because that's where the money is. And you think about it, very few people enjoy robbing banks. It's not a fun experience, but you get lots of money, and that's where the money is, and so that's why they do that. And so, now we're going to look at some of these different types of attacks and attackers and like their translation sophistication and how we might be able to go in and disrupt that. So ransomware is the easiest one. You take something they want and you say, give me money or else something bad will happen with it. Either I'll encrypt all your data and I will only give you the key if you give me money, or I'm going to reveal all your embarrassing, Outlook PSTs unless you give me money, and then I'll delete them probably. And so there are some ways that, right off the bat, like if you can back up and do recovery drills and advertise that you can get back in operational very quickly, that is some preventative measure. I think that's what's really cool about conspicuous deception, is that you can move from a reactive alerting capability and something that slows down attackers, something that may actually cause them to find another target. As if they think that you can recover your operations in a few hours, you're probably not going to pay a big ransom. And then another one is this idea of chaffing or chafing, so basically wheat and the chaff. Separating those out. If you can intermix fake data with real data, the threat of revealing that is less compelling. And it provides a little bit of plausible deniability, a little bit of concern of maybe that data is not real, and so it kind of decreases the value when that is being made public. Moving to more, kind of traditional data theft. So this is a breach. You may not necessarily want to get caught. You don't contact them and try to get money out of that. And they'll have different kind of goals depending on what they're going after. So like I would say a very low sophisticated in terms of translation, they want to get monetary gain very easily. So maybe they steal a credit card or something like that, a PayPal account, and then they can pretty easily turn that into money. I talked to one organization. They were a high frequency trading firm, and they had lots of money moving back and forth very quickly from various positions, and they had a huge amount of value in their positions research. And they were compromised by an attacker who just stole their FedEx account number and then left, because it was easier for them to like monetize shipping stolen goods on eBay than it was to monetize this, incredible like gold mine of financial information, because they were a low sophisticated in terms of translating from data into access, into value. Medium is kind of the middle ones where there's a little bit more effort. So like medical records, they're incredibly valuable, but you have to know how to tap into that value. And it's a little bit more complicated. You need to have a more formal structure of someone is stealing information and then someone is monetizing that. It might be a separate organization. And then last, kind of the high tier, this would be more like, the APT group, where if they're stealing the schematics for a fighter jet or a missile, like someone has to be able to extract value from that. And they're probably not the same people. They have, essentially a very structured organization to exploit that information, and exploit being the intelligence gathering of making use of that information rather than exploiting, like getting onto a system. And so all of these pieces of data create value based on the assumption that the data stolen is correct, valid, and useful. And that's where we're getting into here. So we need to attack them by hitting those incentives, right? So they need to be able to use stolen data to create it into value. And so we want to be able to demonstrate the feasibility, at least, if not more than feasibility, of breaking that translation from data into value. Publicly show it's possible, like go speak at a conference in DC in January called ShmooCon. And then that maybe now anyone could have deployed these publicly available defenses, and now there's something sitting in the back of every attacker. And so now we also want to help make potential attackers aware. So later there's going to be a call for everyone, if they like this talk, to share the ideas and everything like that so that people start worrying about it. And then you also get the reactive benefit, right? So when you do get an alert on your canary token, that still is valuable, even if it didn't necessarily prevent an attacker from going after you. And that's a lot easier because now they need to move in a different way that might not be their standard MO because they're worried about, say, using AWS keys or something like that. So today in this talk we have two instantiations. The first one is a useful tool that we just released. You can start using it now. And then the second one is more of like taking this even further. It's still very early, like not production ready, but I hope it will spur some thinking and some discussion, and I'm happy to collaborate and share what I'm working on with anyone that's interested. So if you think back to a few slides ago, we drop that AWS token, we forget about it, and then you get an alert saying, hey, someone just accessed the AWS keys on your CTO's laptop. Now you know exactly what device they're in, you know which computer they're on because you have a unique set of, say, AWS keys for every laptop in your organization. And then either you can now quickly respond to that and maybe shut down that laptop, or attackers start getting wise to it and they're like, well, I'm just not going to go after AWS keys unless I really need to. And so we're doing the same thing with the new token type today, which is going to be a credit card token. So this is how we're going to try to attack credit card fraud. So if you go to canarytokens.org, which is our free canary token site, you can click generate credit card. It will give you a real credit card. It's not just the Lund check. This is like a real legit credit card that is active today. It will decline all transactions because I don't have the budget to pay for everyone that goes on there. And it will alert on attempted use. So either webhook, email, and then for our customers, we can feed it into Splunk or SIM or whatever you want right there. And then just deploy one everywhere you think it may get stumbled on, right? So if you do store payment information, right? If you are a first-party payment processor, put a couple there. If you have multiple branches of your location, put one everywhere so you can start understanding maybe if there's only a partial compromise. A previous job, we'd have a Word document on a shared folder with everyone's corporate credit card number, and then the executive assistants in the travel team would use that to book travel for us. Stick a couple in there that they know not to use, and then if someone's like, an insider or something like that, and they're ready to, punch out, and they want to grab as much information, now you know that you have that to kind of clean up. Also email, like PSTs, that's a really easy one regardless of if you have Exchange or Gmail or whatever. There are a lot of companies that you send them an invoice and they say, please charge this credit card number, and they respond with the full credit card number in the email. So it's not that out of the norm to find credit cards in an Outlook Exchange. And there are actually tools that will grep basically through these things looking for the credit card number signature so that you can monetize that. So yeah, stick one there too. And so this was one that I generated a few days ago. So Kyle Lowe is a fake name, obviously. My name is not Kyle Lowe. The number is valid and the CVC number is valid. There's no billing zip, you'll see, because it doesn't actually matter. So when you try to do a transaction, it's kind of like going and asking a big organization for approval. Everyone has to say yes, and anyone can essentially veto the transaction. And that's what happens. And so when you get the number, it's okay, the number is valid. Does the name match? No. Okay, that's like a hit against it, but sometimes you don't even have the name. So is the CVC valid? Yes. Oh, that's good, that's good. Does the zip match? No, no, okay, that's not great. And then you can even do things like, Stripe has a system called Radar, which is kind of like AI fraud detection. So if they've seen someone swiping and getting declined multiple times from an organization or one store, they'll start flagging future transactions like, hey, until we know that there's not some guy with a stack of credit cards he made trying to test them all, let's just kind of block that one down. And so it could be the legitimate card gets declined. So there are a lot of things out there that basically prevent a transaction. The good news is we don't actually want you guys to spend all of our money. We want just to know that the transaction attempt occurred. And so then the cool thing with these is that you can ignore that. If it makes more sense to put it in under your name, that's fine. If you want to put your own billing zip, that's also fine. So you can essentially use all of that however you want. If you want to stick it somewhere programmatically, we allow you to download it as a CSV that does have, like all the fields that would make sense, and then you can just stick that in, a database or somewhere as well. So that's really straightforward right there. As I mentioned, I'm going to hit on this again. The transaction attempt will be declined. We are not giving you free money. But the person who created it will get an alert. And so this is an example from my inbox. Basically, it will give you the merchant name. It will give you the last four of the credit card just so you can remind yourself which one it is. The token reminder, so put something useful in that memo. And then the transaction amount, it will try to grab basically how much you're trying to authorize it for. So, on a computer that is not my own, I will try to do a demo. You can't see that screen, can you? Okay. I'm just going to type something in here, canarytokens.org. You guys can follow along if you'd like. Yeah, I'm going to, yeah, 1 second. I can't type very well looking that way. And someone has very nicely volunteered to let me do this semi-fraudulent transaction against their web store. So thank you. All right, so I will try to do this blind. So I have a tokens.org, canarytokens.org. Is that the credit card one? Someone who can see it? Yeah. Okay. All right, and then is it selected the field? If I put, okay, did I type jtip@things.com? Cool. All right, and then we'll put this in, our Outlook PST file, and then it does take a couple seconds. Did I click on it? Yep. Okay. It does take a couple seconds because we're actually generating a real credit card and issuing it and all that work. And there you go. So now we have a real credit card number. This is going to be really challenging for me to copy and paste all of this without being able to see the screen. Was that? Okay. I may only be lying to you. This is a talk after deception, but I will be honest. I'm going to go to Binary Ninja. I understand that I'm purchasing a non-commercial license because I am an attacker, and every attacker needs a good disassembler. All right, put in my email address, attacker@attacker.com. All right, and I'm just going to nicely copy the information. There's a little UI field that helps with that, which is pretty slick. All right. Copy the card number. Expires 01/25. And the CVC. All right, what's a good zip code for here? Like 22203 sounds reasonable. All right, so now I will click. Hopefully it says declined. Okay. Jordan, did you make money yet? Okay. So it does take a couple minutes for it to flow to the transaction, like the Amex people, and then down. So if anyone has a question right now, it takes like 2 minutes. Go ahead.
Do you only offer American Express credit cards, or do you get other?
So right now we are, oh, I need to go fast?
Repeat the question.
Oh, sorry, the question is do we only issue Amexes? I will talk about that more. Right now, yes. We are trying to add that, and that's actually part of the selling point of this, is the more bank identification numbers we can issue and the more card types, the harder it is for an attacker to throw them away. Right now, maybe attackers just say, Amex, not going to worry about it. Yes? So we're open to work with anyone. Amex is their own, oh, sorry. The question is which banks are we open to working with? And anyone who wants to work with us, we think this is a cool idea. We think this will, nip at credit card fraud, which is $40 billion a year. So if anyone works for a bank or an issuing platform and would like to talk to us, please do. All right.
Is there a way to get a physical card?
Not unless you pay us money. Oh, can you get an physical card? So most of the time, our issuing platform will pay, charge us money. We were actually talking about doing this as business cards, so our own business card. Like, what would you keep a business card in your pocket for from a random person? So we would actually make it so that there'd be a QR code on the back. It would be a real credit card with one of these tokens. You scan the QR code the first time, you put in your email address, and then any subsequent time, if it's swiped, you get an email, or if someone scans the QR code, you get an email as well. So that we were thinking that would be kind of a cool business card, make it look like a corporate card or something like that. You'd keep that in your wallet as a physical token. But right now, we haven't got there yet.
Question.
Yes?
So these are persistent in that you can continue to leave this thing up there for different attackers. It's not a one and done.
Yes. They will continue to be, sorry.
I thought I was loud enough.
The question is after this is triggered, do you need to go and regenerate and reinsert? And the answer is no. These will last until they expire, which is about 2 years. All right, now I will try. Did it say it's?
Because the audience has been playing along with you.
Cool. So it's been triggered. So sometimes it triggers multiple times if the error code comes back as like temporary issue. So for example, I've noticed that Stripe will actually try it twice in quick succession. You should only get one email as long as they happen a certain amount of time. This also could have been some joker who is also going in and trying to do it. So if you click on that, you should actually see, I don't know if that actually says like $300 something from, okay, so there you go, it worked, perfect. Sorry that the demo was kind of clunky. All right. Okay. Cool. Glad that worked. All right, this is a video, if it didn't work, showing you the same thing. We don't need to watch it because we already saw it. So, some caveats about this, right? So this is now available. It does have beta in parentheses. It does obviously rely on more third parties. We are not yet a core issuer. And so we're trying to work on more card types and more bins. So please do keep it track. And then as we add those, they'll just start getting mixed in randomly. So that way you'll just kind of get a MasterCard one day and a Visa the next day, hopefully. We have run into one payment processor that if you've paid extra with them, they can do some form of validation before they issue a transaction. And so they can check if the zip code is correct before they actually say, I'm going to spend some money on this. And so they won't alert because they'll say invalid zip or incorrect information, check again. All the big ones seem to work just great, but that may be something that you may run into, so it's not 100%. And then also, kind of going back to your question, unlike our other token types, you do need to think that these will expire after a couple years, just like credit cards expire. And so, if you have this stuffed in a payment database, you do need to set a reminder, hey, in 2 years I need to go back and add a new one in there. But that 2 years is pretty good. So it does require a bit more upkeep than, say, the AWS tokens, where you can just literally forget that you even put them out there, and then you get an alert. Just like certificates, yes. So now what? This is a public tool anyone can use. Anyone that has a laptop can go and do this. And now attackers have to be cautious about monetizing stolen card information. I'm sorry, attackers, if you're watching this. And the cool thing is even if a target organization doesn't employ these, if they store an Amex, it could be one of these. And so, now everyone gets a little bit of preventative benefit just from the fact that this exists. And so again, share this with your community, tell people about it, put some on your organization's network, and you're helping kind of add to that shadow of doubt. Now, obviously, unsophisticated attackers that don't go to ShmooCon or watch our live stream, they're probably going to just continue to do the test thing, and they're going to get caught sooner, which is great, because currently what happens is someone recognizes a fraudulent charge on their card, they report it to their bank, and then the bank has to go and see, okay, where else have people been shopping that have also reported fraudulent transactions? And that can take a while depending on people's spending patterns. Now, the moment someone tests this card to see if it's active, they know, hey, everything in this database is compromised, let's go lock it down. Sophisticated attackers, as I mentioned, will probably generate a lot of these tokens and capture the bins. So the first number is like, is this an Amex or a Visa? Then the next few numbers is basically what bank was this issued by? And then the last number is like the account number, and that's the unique to this card. And so they'll probably generate a bunch, and they'll start seeing which of the bins we're issuing from, and then probably discarding that, which is actually a great sales pitch to onboard a bank to this platform. Say, hey, banks, would you like it if sophisticated attackers threw away your customers' cards when they breach an organization? And then hopefully they'll say yes. And then they'll onboard it, and then we'll give more bins, which will make it harder for an attacker to be able to figure out which ones are legit and which ones are tokens. And then also it means that those legitimate customers are now protected from fraud because they're not going to be used by a sophisticated attacker because they're worried about that. And so hopefully that's like a good thing for everyone. So that was the first instantiation of conspicuous deception. So now we're going to go again. I want to highlight this one is like cute, super early. I think there's something there, but it's not quite cracked yet. So at its core, as I mentioned before, deception is this information asymmetry between defenders and attackers. I talked a little bit earlier about like chaffing. It's not a new concept. I think there's a Rivis paper from 1998 that talks about how to get data confidentiality without encryption by adding bogus data around it. And so it's hard to deploy though, and it generates, it's outside of our traditional use case of encrypt the data and protect it. And so this new concept, Deception DB, is a very much proof of concept trying to make this deployment easier. And so all you have to do when you wanted to protect an application is use my replacement PyMySQL driver, and then you need to provide the semantics of the table schemas you want to protect. So you may have a column named password, and the semantics of that is it's a SHA-256 hash of a string. And so you have to be able to tell that's what it should be generating to make it look like that. We have a lot of baked in, like, social security number, phone number, names, all that kind of stuff, but also like you can generate, give it a custom function of what I want to generate. And then basically it just generates silently fake rows, and I'll talk a bit about how that actually works in a little bit, and then it filters them out when the application is using them. But if you get root on the database and you say select everything, you're going to get all the data, which can be programmatically up to like 90% bogus. The example I want to talk about is medical records. So medical records are very expensive on the dark market, black market. They are between $200 to $1,000 each. Credit cards, for reference, are like 15 to 25 cents. They're used for, medical records are used for nefarious purposes, and also they're much more long-lasting. You can't go call your hospital and say, I'd like to delete my entire medical history and regenerate one. I think a lot of people would mulligan on their health care if they could do that. And so, some of the big ones, insurance fraud, right? So if you get a medical record of someone that has kidney problems and is on dialysis, you have their insurance number, you have their social security number, you can bill their insurance company and say, hey, I provided, Joe Bob dialysis, please send me $1,000. And that's a pretty common problem with the insurance industry. And so that's one of them. Obviously, identity theft is, very concerning for people who are impacted by that. And again, it's not something that you can go easily and regenerate and cancel your social security number and your entire banking history. But we also know that the data itself is, again, an enabler that has to be translated into value. Right? If you're doing insurance fraud, you want money. If you're doing identity theft, you generally want money. So if we can impede that translation by ruining that data, we can then devalue it and hopefully, disincentivize the attacker. And what's interesting about medical records is that they are technical, but in a different domain expert. I'm actually a volunteer EMT, and so I do have a little bit of medical knowledge, but I would say most attackers probably can't look at an x-ray and understand if that person is dead or whatever, if it matches. And also the last thing is that generative AI models are all the rage. And so while people have been making cat pictures, I've been making x-rays, CT scans, and MRIs. So I say, Dolly, make me a CT scan, and I don't know if someone's dead. I don't actually know what part of the body that is, but it looks real to me. And so this MySQL driver, it uses GPT and Dolly to basically generate patient narratives and medical images. And then we're able to then stuff those in. So MySQL and some of the other databases have what's invisible columns. So unless you know the name of the column, you can't query against it. So if you run select star on a table with an invisible column, that column's data will not come back. You have to say select star, comma, long column name to get that information. So unless you know the name of the column, you're not going to get any of the data. And so essentially what I can do is I can have an extra column there that stores state about whether or not this was generated or not. And so again, that's the really rough edge. It's not perfect.
The question is mostly when you look on the scans and you figure out, like, from that point, even though the skeleton, can you filter that into the column? The question is, if you know the science or the medical reason, can you put that in the filter in the column?
I think the question is can I filter off of the medical records being real or not?
Yeah, so when you do the filtering in the column,
Yes.
can you, like, if you know a little bit of medicine?
So no, the medical stuff is too difficult to be able to filter out automatically. Now, obviously, if someone steals this and they hire an army of doctors or nurses to go through and say, hey, their chief complaint was a broken thumb and I see a chest x-ray, like this one we can throw away. But that's going to cost a lot of money and probably not provide the value they want. This one I can't demo because it was running there. So conveniently, I planned ahead. And so we will just quickly walk through this. Essentially, I built the most ugly patient medical system, an e-health record system on the left. Is it playing? No, it's not.
Still better than the federal one. You haven't seen the real one.
I haven't seen what?
You haven't seen the real one.
I guess I have not, yes. So it basically lets you add users, so that would be doctors, and then patient records. And on the right, you're seeing me, I'm logged in as root, so this should be see everything right here. So you see I've just done nothing, there's nothing in the database, just one admin user that comes pre-configured. I create myself as a doctor, I give it a password, and then you'll see on the right, I'm going to rerun that command, and you should see not one new user, but two new users. And so, like, that's really nice, because if you spend time cracking that hash for David15, the web app is going to filter that out anyways because it can't see that that exists. So you're now wasting your time. And I turned this down to only generate one fake record per insert. You can do this 100 times or whatever, so you could really bloat yourself up. So now I'm going to create a fake patient record for John Doe. I added another user. You can see now that there's 5 users there, of which a couple of them are not real. So this person has a fracture to the left wrist, and this is just some kind of, trying to make something sound medical. Patient arrived with a chief complaint of something out of 10 pain in the left wrist after, fall to that area. They were x-rayed and, sent on for, home or whatever. So hairline fracture, and then here's a fake image of a wrist x-ray, save the record, and now you can see this is what the x-ray looks like. That looks pretty good. Like, again, like, I'm not a doctor, not a radiologist, but Dolly said that's an x-ray and it looks pretty good. And you select now you're looking at this, so now you see there's 2 records here. So Victor Adams is a 55-year-old male, booked an appointment. He has some chest pains, and he was worried it was serious, so he came in. And then this is the dolly photo that it generated to accompany that. So now you're going to see basically the medical image that they have generated for this poor patient. And actually, we got really lucky. It randomly picks a body part to x-ray. So we got very lucky that the narrative said chest, and we got a chest x-ray. So good for you, random chance. So this was kind of the demo of that. And so this is something that you can very quickly add into any existing web application or other types of thing that uses a database. But there are definitely some issues with that, right? So there's a lot of rough edges, not including my web design skills. And then obviously, if you can get SQL injection before the driver, depending on how you do it, you may be able to get real results through the web application. So it may actually filter out the fake rows. So there's still a little bit of work to be done with that. And then obviously it adds a lot of pain to a database admin who's trying to go in and make legitimate changes. So I think there's something worthwhile here. I think there's something valuable here. You just got to figure out exactly how to make it really seamless. And so it's just kind of a cute idea, but it's not there yet. So in conclusion, right, we're making this credit card token public and freely available. Like everyone asked when I told them, why aren't you charging for it? Because if we charge for it, then people, the attackers will think, oh, it only really thinks customers would have this. And so by the fact that anyone could have one of these, now they need to worry that everyone might have one of these. And they always need to worry about this poison pill that in a dump that will ruin them all. And it's a preventative measure against fraud. And hopefully by mixing bins into our system, attackers will have to discard stolen data or risk alerting on it. And I think that this idea of conspicuous deception can go beyond just credit cards. I showed you a demo to that extent. Obviously, we still have more work. But the cool thing is that the costs are really only storage and a little bit of compute time. It doesn't really cost that much to store, a couple extra pictures. You can make them small and then a couple extra rows in a database. And you can get a really interesting, preventative measure from that. I've also heard this called security through obesity. Where you just fluff everything out there, and now it's really difficult to know what's real. So obviously, if you're a bank or a financial institution, please reach out. There's my email. And then otherwise, I do have one last thing that was kind of cool. So some of the folks here who are more government, if you're in the defense industrial base, Dolly can also generate semi-realistic looking schematics for fighter jets. And so if you're worried about someone going in and grabbing those, maybe go and spend a few minutes on Dolly and download some pictures and stuff them in there. So with that, thank you very, very much, and I'm happy to take questions. The question is how do database administrators validate which is real and which is not? So in the current prototype that I have, there is an invisible column that's called checksum, and if it's a random number, and if that random number is even, it's fake, or if it's real and it's not. So that's what I'm doing. I'm basically, every query that goes to database, I'm also adding a where this hidden column is odd or even. So if you select all, it's not going to show the invisible columns. They don't show up. If you do a describe table or you look at it on disk, it will show up. So then you would know. Yep. Yep. The question is there an upper limit on the number of canary tokens that we can create, like an issue to you? Yeah. So the answer to that is for the credit card token, we're not sure. It shouldn't be an upper limit. We'd like for people that this will benefit to actually use and to kind of densely deploy, but we don't know. And for AWS tokens, there's no limit. We have organizations that have tens of thousands, hundreds of thousands of them throughout their organization. For this, we'll find out what happens. The question is, do we have a revenue stream for these canary tokens? No, it's good publicity. So hopefully, people who like our products that we give away for free. One of the cool things, if you're a paying customer, you get a private canary tokens instance that doesn't have the canary tokens URL and domain in it. And so And then also you can tie alerts for your Canary tokens directly into your SIM or however it can generate a Slack alert. So there are some benefits, but realistically, $40 billion of credit card fraud is going to bad things, and if we can make a tiny dent in that, like, I'll sleep better at night. So that's the real thing. Okay. Okay. Perfect. Yeah. Yes. We get a lot of Twitter spam. So the question, I guess, was a comment, good use for NFTs. Because we do have the tokens domain, you would not be like, it's shocking how many people mention us when they're releasing a new NFT type because they think we're in the token space. And so our Slack channel that gets like all of our mentions on Twitter is just constantly flooded with people doing an ICO or a token release. So, yeah. Yep.
Your alerts, is it only email, or do other things like integrate with a SIM or anything of that sort?
So the question is the alerts only email? Email, webhook, and if you're a paying customer, they'll feed through into a SIM or however you have it set up. Okay, and I'm done. Thank you. We can put them up. We can post them. Yeah, they're not yet, but I can put them on our website, things.com. Good. Sure.
apparently.
ready? All right, we're ready to go. Thank you all for coming. This is afternoon on Saturday for ShmooCon 2023, and our talk next is Riverside, a network security visualization tool by Caitlin Duvall. Please.
Okay, thank you for coming. I know it's like right after lunch, so I hope everyone's like not sleepy from like FoodCon or anything. But yeah, I just want to talk about a tool that I built during my master's program that I just finished, and that I kind of just finished putting together and put up on GitHub, which I'll have all the links at the end. This is my first time talking at ShmooCon. We love coming to this conference, so thank you, yeah. So just a quick background, as I said, so I did just finish my master's at Maryland, but I'm actually in the Coast Guard. That is what my previous job with the Coast Guard was. I worked in a SOC, and I also did vulnerability assessments, which is kind of where like the inspiration for this tool came about, and I'll talk about that on the next slide, but yeah. So why a visualization tool? I got asked this a lot when people came up and asked me about my talk and like why I built this specifically. Something that when I used to go out and do assessments, and you know, you go ask like, oh, can I have like a network map or like an asset list, like, because we're going to go assess your system, you know, for our job. And half the time it was either non-existent or inaccurate, or I had to go find this one specific person that has worked there for like 40 years, and they're the only person that could tell me exactly what was what. And when we did start to do scans and stuff like that, it took us like days to figure out what was actually connected to what am I looking at? And especially when you're talking to maybe not someone that is the most technical, like having them understand that why that's so important for us to have that complete picture of like what's going on in that environment. So that's kind of what inspired me to build the tool that I'm going to talk about today, Riverside. So part of my master's thesis was actually talking to people in the community, asking them like, what would you want in a tool? Like, what do you need when you're talking about a visualization aspect? So that was something that was really important for me, was getting input from the community. So asking people like, what's the data that's important for you? What aspects of a visualization are important for you? What would you want to see? So these are kind of just some like very, very rough sketches that I had from people that randomly they drew up, and they were like, this would be cool if it could do this. So this person specifically was like, it'd be great if we had a visualization as well as like a table that matched that, to be able to show the raw data tables as well as the data that's being visualized. Another person was like, it'd be great if it solely built out the network map. I know, this is a very, very rough, these are people's rough sketches on like MS Paint, okay? So, you know, this is not what the tool looks like. But like something that can start from one point and then grow out from that. So to be able to like grow and do that like dynamic discovery and be able to like show everything that's in that environment. Other people liked the mix of the, again, kind of like that information while you selected maybe a piece of the network. And other people kind of like that ability to like drill down into the data. So as you clicked one thing, it would show more things. Though not maybe showing everything automatically up front because of that like kind of idea of like burnout. Like seeing all this information at once can be a lot. So that is what led me to develop Riverside. This is just a quick diagram that I'll walk through of how Riverside talks, communicates, and how everything's kind of connected. So it is an agent-based tool. The agents are all written in Golang, so the entire backend is Golang. It's cross-platform compatible, and I've tested it on a variety of different operating systems and environments. But basically, the agents send all of their raw host data through gRPC, and I use protobufs in Golang to like actually make everything nice and neat so that the server can understand what it's seeing. The server then is also a Golang binary that simultaneously sends that data to the front-end visualization as well as stores it in a database so that you have the ability to actually go back in time and look at all the data that happened previously, because Riverside allows you to look at both real-time as well as go backwards in time depending on when the data, what like time frame of data that you have. The front-end visualization will display the network data based on the time that you're looking at. And I also have a piece for session data that I have that you can like be able to log into like a server if you have multiple servers running. So you can have multiple sessions and be able to look at all of that. I handle all of the front-end stuff with WebSockets so that it's constantly updating. I do about a 2-second data batching, so it's as real time in terms of like, it has about 1 to 2 seconds that you'll see like time differences of once in a while. That's just to be able to batch the data all together that's happening like in that 1 to 2 second window and be able to put it on the front-end visualization. This is kind of an overview of what it looks like. This is something that I built starting back in probably August. This is like 6 months rapid development, got something working. It's definitely a work in progress, but this is the initial visualization that Riverside has. So all of the blue nodes that you'll see there are actually the agents. So those are agent nodes that are constantly being tracked, that have data flowing, and they connect to either other agents or remote nodes that are the gray nodes, things that they're talking to. So they're connected depending on when they communicate with other hosts. So the different colored edges are actually based on the protocol. So for example, the light blue color there is actually SMB. The dark blue color is HTTPS. Yellow is ICMP. And if it's gray, it's either just TCP, UDP, or the DPI library that I have just maybe couldn't fingerprint it at that time because it just doesn't recognize that application or that protocol. The bottom is the timeline that actually is kind of like the base of Riverside. So you're able to take that blue cursor, which is your cursor, and drag it either forward or backward in time and be able to like watch the visualization change as data is being flown into the server, as the agents are sending data, and as the front end is being updated automatically. I'll have a quick video and a couple slides that'll kind of show it in action. But that's the overview. You can pause and play the timeline at the bottom. You can fast forward to catch up to real time. So let's say you like went back a couple of days and you're like, okay, well now I'm gonna go look at what's happening right now. You can just click that. It'll bring you back to real time and fast forward the visualization. I think that's, yeah, that's all I'll talk about there. So I'll quickly show. So this is a quick setup demo that I have of just like opening the command line and being able to like run one agent and one server. So right now I'm setting up the server. All of the configurations for both the agents and the servers are handled with YML files. So like you can have everything in there. I have examples of like example configuration files on the GitHub, but those are just like some default stuff that I have set immediately. And now I'm gonna run the server binary. So it's gonna spin itself up. And it's just waiting now for host data. I already had the front end running. I'm just using a simple Python like web server in my command line, like that's it. I don't have it deployed on anything. But this is the option to like register or log into a server so that you have different like sessions or different servers running. You can like log into them and be able to look at different visualizations if you have other servers running and stuff like that. This is now the agent, same thing, .yml file, just having those configs, telling it what server you're looking at, being able to like tell it where you want the log file output, all that kind of stuff. And this is all just default stuff that I have set. You do have to run it with root for the agent because it is capturing like raw network traffic, so kind of same concept with like TCP number or anything like that you have to run it with. Then the agent has a couple of different options. Listen is the default that I'll use here. That's like just to start capturing traffic. Ping is something that I added for like just testing that an agent's working that you can just run. But listen is the command that will actually allow you to start capturing traffic on that agent. And initially it'll ask you to have the server address and everything like that so it knows what server to talk to. If that's set in the YML file, it'll do automatically. You don't need to provide that in the actual agent start line. So it'll actually see the agent get entered, and then it'll start. And I have a database already running that's like collecting this, which is why it had that SQL statement for doing that. So this is the agent actually running right now. It's just a new Ubuntu agent. I was in a VM when I did this little test, but it's just capturing traffic. So you can see the blue cursor is going because it's keeping up with real time. We're just kind of watching. This is in a VM, so not much is happening right now. I think I Googled dogs, which is why you'll see like the HTTPS traffic come for the web pages and different things. I also then started opening like GitHub pages and like some other stuff to just start like triggering different traffic. But as you can see here, I paused the visualization. So the red line that's real time is still going, but I'm looking at a static point in time. So you have that ability to stop and like look at interesting traffic. You're like, oh, there's something that happened at this specific time that I want to go look at as an analyst. Let's say like an incident popped up and you have like an alert. You're like, I want to go look at this one point in time of like what was going on in the network at this one specific point in time. So you can go back to that time and look. And you have the option to like play with the time picker here that allow you to go like up by seconds, minutes, hours, whatever. You can do that manually if you want to just use arrows and stuff. Or you can have it then play from previous in time to actually watch from that moment in time how it progresses up. You don't necessarily have to go fast forward, but you can then watch in that point in time that you maybe had that indication that something weird was going on in your network, or you wanted to see what your environment looked at this point in time. So I'm going to switch back. So some of the things that I'll just talk about are like just some features of Riverside that I either built in or they're just kind of inherent in how I developed it. But it showcases both internal antenna as well as internal external, so it kind of gives you that entire holistic picture versus something that maybe just shows what agents are talking to. But it gives you kind of that whole picture. As long as it's talking to an agent, it will show up on the visualization for Riverside because it captures everything as long as there's an agent on it. So even if you maybe have a host that's unaccounted for that still talks on the internal network to another host that does, you would see that. And then that would be an indication you're like, hey, that's another internal IP that should probably be an agent. And that kind of gives you the indication that maybe you have something that's not accounted for on the agents that you already have deployed. So metadata, like for a connection or a host, is shown by hovering. So on that, I had shown like a host. You can see all the interfaces. You can see its IP address and all of that. For an edge, you can see the two hosts that were talking, as well as over what ports, the number of packets that are being sent, as well as the start and end time. And the end time will keep updating with real time. If the communication is like continuous and it keeps going on, that end time will continuously get updated. I also allowed, this was something that after talking to people, I wanted to kind of incorporate some like user features that you could like change the visualization so it wasn't just something that was like static and everything always looked the same. So being able to like change the shape of a node or add like a picture because maybe that's like something that's like a computer that you know does this weird communication all the time, so you're gonna like label it or make it a different color so that you know when it pops up, that's something that you know it's okay. So you can change the labels on it. So here I changed the label to my host instead of the default, which is the host name. You can also change the colors of the different nodes. And for example, for this one, for remote nodes, if a communication is continuously happening on the network that you're on, the transparency of that node will actually decrease, kind of like making it like less noticeable because that's something that happens all the time. So it's probably normal communication. So nodes that, or traffic that's like less frequent, those nodes will actually be like full colors. So those would be something that you would notice more. So maybe some traffic or communication that's happening less frequently or like something that's maybe anomalous on your network is more noticeable for an analyst when they're looking at the visualization. As I said, links are, I use a deep packet inspection library to do automatic coloring of the different edges that are connected. If it can't immediately figure it out, it'll be gray. But here, the dark green is SL. This is an HTTPS connection, and the purple is actually a DNS connection for these. And I try to, I correlate the edge width with the throughput. So if there's a lot of packets, like it's a continuous communication that's occurring, the edge will actually get thicker. And I'll show it in the video demo, like an example of that, where I have like a continuous RDP connection, like I'm connected to something via RDP, and the edge will just continue to get thicker because that connection is still happening, and I'm still connected to it. So it kind of draws your attention to the connections that are like continuous or last longer than maybe like something that's like a second, like maybe a DNS. Okay. So I'm gonna play, this is a sped up version of something that I did. So I simulated an attack scenario with Docker and had Riverside run on the environment. So I simulated like as if I was an attacker, ran a bunch of commands and stuff like that coming in I like simulated brute forcing RDP into an initial host. I will show some like what is lateral movement. Technically, I use PS exec like SMB to a bunch of hosts. And then I used FTP to like take data off of one of those and then out to like an attacker IP. But it was like just simulation done with Docker, just kind of show how Riverside would visualize something like that when I was demonstrating it to other people. So here, the dark blue colored line is, or link is RDP, but as you can see, like this is like the example I said, I literally was just sitting there like brute forcing RDP connections, and I connected. And so that link will continue to sit there. I then connected, and then I just stayed on that host. And so I'm gonna fast forward real quick. Okay, so this is, then after I did that, I then used PS exec to like move to another host on SMB. The light blue is SMB. So I did that, and I did that throughout the network. So I kind of was just showing how Riverside can visualize that, where if you're moving through the different colored protocols, the host will actually show that communication happening in real time. I also had a traffic generator running that showed like other traffic that was just kind of randomly happening on the network, but this is like the actual attack scenario that I built out where I did that. So, whoops, I don't know why I restarted, sorry. So something else was that I used the coloring to kind of change the color of one of the hosts, because I was like, oh, this host is probably bad, because that's the one that initially RDP'd. So I colored that red, so that later on, when that host is communicating again, it pops up and it's red. So that I'm immediately drawn to my attention to like that node, because that node is colored differently. So as you're like doing an investigation or looking through Riverside, you have the ability to like change the colors of nodes, whether it's something that's like more noticeable for you, or the shape, or something that's maybe like better for you as an analyst to recognize on the visualization. Because again, that's the whole point of like the visualization, that it's something that you as a person can like actually use, so that it's a useful picture for you. So that's another, so then I did the PSExec again from WS03 to WS02. I was using one host to do DNS beaconing, so I just had like little DNS beacons that were coming out, so that's what that one is. I then started changing all the colors of the nodes that were like compromised, or that I was like investigating technically, to orange, so I could kind of track all of those communicating. And then the last piece that I talked about was then I used FTP to just like move data from one host to another out of the network. And so that's what the orange line is. So that's just kind of an example of Riverside visualizing a very, 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 very high level like attack chain scenario of obviously not showing stuff at the host level like that, but being able to show something like an initial brute force attack over RDP, SMB lateral movement, and then data exfiltration. And being able to visualize all of that for someone, because being able to see how everything connects and how everything actually looks in your environment, I think is really important, and something that at my previous job, I think a lot of the groups and people that we worked with struggled with, and it's something that can be really useful, especially when you're talking with people that maybe aren't on keyboard all the time, and you're trying to communicate to your boss or like to your other coworker like why this is important and like why this is impactful, or just even explain what you're doing. Like, this is what it looks like. I colored these orange, like these, like, and being able to show like this is what happened on the network. And I think that visualizations can have like a really powerful like effect for that. Just some recent updates that I did. I am in the middle of moving, so I haven't had as much time to devote to this since I finished my master's program, but I would like to keep working on this and keep adding stuff. So some recent things are that now you can actually just immediately grab the blue cursor and it'll pause the visualization. So like, let's say you're watching it in real time and you're all of a sudden like, oh, that was interesting. Instead of having to like go hit the pause button, you can just grab the cursor and it'll immediately pause that and allow you to move. And I also track like something that I realized it wasn't doing immediately was whatever host initially initiates the connection, I wasn't like making that apparent for people on the visualization. So like, it was always showing it from the agent perspective, but on the right you'll see the picture. Like, this is an example where the remote host is actually the one that initiates the communication with the agent. So the true like source that like initiates the traffic is actually going to be shown on the left, and then the like host that's actually receiving that initial traffic will be shown on the right. So you kind of know like who's initiating that, who's starting that communication. This is just like some stuff that I put together of like things that I'm going to try and work on and incorporate, and just things that came out of like me doing my master's program and doing my research and stuff, and things that I think that are important for like visualizations in general, and things that could help, maybe not just with Riverside, but just in general with like adding to other visualization capabilities. Like, I don't think by any means that Riverside is like, you know, the best tool out there, but it's something that I made that I think will hopefully help other people maybe say like, oh, that would be really useful where I work, and either taking this and building their own, or taking what I have on GitHub and making it better. And yeah, so thank you for listening. If you have any questions, I'll take them. All of the stuff that I just showed is on my GitHub. Again, like, I've just put it out there as something that I made, but if you have any questions, I'll take them. Thank you. Stop. Okay, yeah. Yes, it's fine. I'm sorry, I couldn't.
Network tap port?
Oh, so right now, sorry, the question was, please correct me if I'm wrong, the question was if I pull information from a network tap port right now? Yeah. So right now, the only way that data gets entered into the database is if you're running the agent will immediately collect all the interfaces that it sees on that host, but beyond that, I haven't tested it on specific instances like that you're talking about, which was like something that I got asked about previously, and I just haven't had the time to like test it on various environments and stuff.
How are you handling data import?
So that is something that I want to add, is being able to like take, like, let's say you have like a PCAP or something like that, and you want to just upload it and see like, what does this look like, and be able to move through in time. I don't have that yet. Right now, I was running a Docker instance of Postgres, and it just will create everything for you. I use Gorm, an ORM library, to like do all that in the back end, but past that, like right now I don't have any way to, I guess, like upload a PCAP or something like that and then be able to visualize it. It's on my list of like to do, because I do think that would be like really important, because like not everyone maybe has that running immediately, but yeah. Yes? So right now, the largest that I've tested it with on any of mine, because again, this is like all on like my little home network and stuff, is 30. I think that if we got into like the hundreds and the thousands and stuff like that, I would need to change some of the front end stuff so it like basically caches so that the front end doesn't like slow down in that after that. Because I think when I did it with 100, after like 20 minutes, I noticed a difference. But depending on what you're, like when I put it on a droplet and like had better stuff than me running it locally on my laptop, I didn't notice any performance issues, but again, I haven't tested it like large scale in terms of like thousands or stuff like that. And I would definitely need to look at like changing the data views and like probably using some caching to do that for when you're going back in time in that. Yes?
Are you looking at, in the future, maybe Windows-based agents and stuff like that?
So right now it does work on Windows and Linux. I have the binaries pre-compiled. I've tested it on a couple different Linux flavors. Ubuntu, Kali, and Fedora, but in Windows. It works on Windows 10 and 11. I've tested them, and they'll all run together as long as they're all connected to the same server.
And is the agent lightweight?
It's going, so like as lightweight as a compiled binary can be, but I mean, I've run it on my laptop while doing other stuff, and I don't notice that my laptop's like I don't notice a difference. But again, like I would have to test it on larger like enterprise environments and stuff like that to know if it's like truly lightweight, I guess, in that sense. But I use like RPC and everything, gRPC, to send everything back and forth. So kind of like all the standards with Golang with the protocol buffers and stuff. Okay, I think that's it. I'm sorry. Thank you. I know, you guys threw so much stuff. Okay.
For the agent,
Yes.
do you configure each agent individually?
Thank you.
Do you configure each agent individually, or do you like compile one agent like a backdoor that
Oh well. I usually have one because I know that sometimes they just disappear from there for no reason. I don't think there's quite time to go back and get it, so.
Probably.
Oh, it looks like he has one, though.
Oh, yeah.
That's the thing I need.
Yeah. We have a secret supply of them backstage.
Das ist wunderbar. Dankeschön. Yep. Well, if it isn't.
Do you have any audio output that you're going to use?
I have no audio in this.
Okay.
I'm easy.
What's that?
Cool. So just oh yeah, I've spoken here like 3 times.
Better with names and faces, especially when I come. How would you like to be introduced?
You can just call me Falcon Mullet.
Okay. Mullet?
Yeah. Do you feel the need to introduce me more than
that.
No, not at all. I just wanted to hopefully it's
Oh, yes,
give
I'll watch
away,
this.
give away a couple of things. Or what is your time taken and through they would hold about 10 minutes and 5 minute warning to work. And then this.
And I'm supposed to show up at 20 and take questions for 5.
No, you have a total of 20 minutes. So.
Okay, I'm supposed to shut up at like 18 or 19 and take questions for 2.
Exactly.
This is the first time I've tried to give a talk this short.
So yeah, other thing is a small room with streaming, so please remember to repeat the question. The whole world is watching.
And the future too.
Yes, exactly. We're in a time machine. I'll pick up my turn. Any questions? Okay. Thanks for doing this for us.
Thanks for the stage.
My giveaway questions are pretty lame.
Oh. Big mouse pad. They have solar mouse. It's a cute mouse pad.
This is the best. Un-parsing Manifesto.
Yes, we can just introduce it as that. That's fine. The subtitle is superfluous. It's an intermediate slide. To which I will call attention to later. But there was only room for the first time. I just academically feel compelled to subtitle everything, and I'm not really sure why. Paper titles have to be, you have to have the short and snappy part so that people can say what it is, and then the long part that describes something about it. But then the long part turned into like, no, it has to be some kind of pithy statement, but it has to be a longer one that's less gamely. Anyways, yeah, so you go. Yes, sir. Oh, you need this one. Yes, please.
Howdy, folks. Hope everybody had a wonderful lunch and first talk back after the lunches. Taping and streaming, are we ready to go? Oh, hey, we're ready to go. So just before we go, I have a couple of giveaways here. Can anybody tell me what logo that is? No. No? Anyone? I mean, ShmooCon's close, but that's... Aha! We'll see. Well, given the demonstration of throwing ability, I'm not going to throw anything else. A couple of reminders. There are various things that we have brought, such as bags of crap and previous year's t-shirts that are available for a donation and registration. Please take them home so we don't have to. And also, this evening's events will be starting at 9 o'clock. You will need your badge. You will continue to need your mask. Thank you very much for wearing those. But we're looking forward to seeing you playing games and the ShmooFac. So that'll be a lot of fun. But without any further ado, I would like to introduce our next speaker, Falcon Momot. Please give him a warm ShmooCon welcome.
Well, thank you. Good morning. Well, Seattle morning anyway. This is a talk about defensive systems. Un-parsing Manifesto. Essentially, this the topic here is another one of the language theoretic approaches that I've spoken about here in prior years, but just going into a touch more detail on what we might do to try and deal with the parsing and injection issues that have been the plague of software development more or less since at least the dawn of the web age, if not before. I'm Falcon, used to be in pen testing, not anymore. Now I manage product security for this little cloud data company called Ivan, Ivan.io. We manage databases. You can move them between clouds by a click of a button. It's really quite awesome. I love it. It's nice to be in-house. Intermittently, I still do a whole bunch of research on LangSec. This is sort of part of it, postulating things and hoping. And of course, I've finished the master's degree I used to introduce myself as a student of before. Anyways, so input sanitization. We talk a lot about input sanitization. It's been a long-standing frustration of mine, more or less every time that I talk to somebody, hey, what do you do about cross-site scripting? And usually in the context of something like a job interview, they're, yes, cross-site scripting is solved by input sanitization, purely by rote. You know, this question, this answer all the time. And I think input sanitization is perhaps sometimes the wrong tool for the job. A little bit like trying to clean up the beach or your carpet with a floor mop, or brush a laptop screen off with a coarse nylon brush. It's not necessarily going to work. It's kind of a crude tool for what we're really trying to do. And I want to talk today about offering some alternatives to that approach, because I think we can do a little bit better than that. Most of the approach of language theoretic security is about making our code very easy to verify and then verifying properties of it. You'll recall that we talk a great deal about limiting the complexity of systems. This is really just part and parcel with that. So input sanitization doesn't actually stop injection attacks. We know that it doesn't. And I'm so sorry if you're one of the folks that was taught this over the course of the past 2 decades of information security, because, yeah, oh boy. Is any input inherently dirty or clean? Is this bad, this input? Do we want to make values judgments about these strings? Well, they're here on my slide, and no exploits are popping, so it can't be that the strings themselves are the thing that is bad. And these strings are kind of their twins. What if I want to talk about the JNDI exploit? How am I going to do that without actually saying the JNDI exploit? Do we really want a product like a web application firewall in between you, the users, and something like Stack Overflow, preventing you from saying the swear word? Is that really going to help? But we kind of have been thinking this way, right? You think, well, if I'm going to prevent cross-site scripting, if I'm going to prevent this particular class of exploit, I'm going to do so by sanitizing my input and making sure that the bad exploit strings don't make it into my application. This is why the subtitle of this talk was Reconnecting the Corpus Callosum. We're kind of of two brains about this. And it's really necessary to integrate our thinking a little bit more about this. Stop this reflexive response that isn't really necessarily as well thought through as a well-architected control might need to be. So if we can say these things, if we can talk about these things, if we can have strings that are of this form, and it's perfectly safe, the thing that matters here is not the strings, the thing that matters here is the context. Right? So all of these various things, depending on one context, they might be vulnerable. Or they might be an exploit, they might be a payload. Depending on another context, they might not be. And what we have to really do when we're trying to secure a system is understand not so much the definition of valid input, we do have to understand that, but we have to understand the definition of valid input in each of our contexts. And the context about which we care most when we're trying to prevent injection attacks is that layer between the data that I have in my backend, the data that I have in my data store, the data that I'm accepting from you, and the next place that that data goes. That's where the definition of security is. So don't attempt to create universal, safe subsets of arbitrary data. We can talk about this kind of as, what do I want to say? We have these sets of characters. And again, I was saying earlier, there's no bad strings, there's no bad characters. I've seen altogether too many times specifications for things that say only put plain text. Don't put any of them hacking characters in here. Well, these are all hacking characters in some contexts, but not in others. My favorite one, the example on the far right of there, of course, is valid SQL. It's executable, I suppose. But really, it's just, it's something that you might say. You might write this down. You could type this out in a message to your friend, and it would make sense. It's normal, readable English text, even though it's also SQL injection. It's also not a problem in HTML. And so the only thing that really matters here is the output context into which this is going. Which leads us to, the answer here is not input sanitization. The answer here that we should be concentrating on and investing all of our effort in is output encoding. Commonly used characters in neutral language are commonly used characters in neutral language until they go somewhere. The reflex that we often have when we're dealing with untrusted user input at scale is to say, okay, let's grab the user input and we'll encode it into something that we think is safe. Let's say we'll take our string and we'll run it through the HTML sanitizer so that we've scrubbed it off. You know, all those hacking characters are gone. Now it's HTML. There are two fundamental problems with this. One of them is that, as you can see, this isn't that wholly ultra perpetually safe ASCII, A to Z uppercase, A to Z lowercase, 0 to 9, and whichever punctuation I feel like today. It's not. It's full of ampersands. It has syntax. It turns out that its length on the wire is different from its number of characters, which is one of the favorite properties of people who like to find a very special subset of injection attacks, buffer smashing exploits. It's also a little bit awkward, difficult to read. Natural language parsers might not necessarily have the best time with this. Why is this word amp appearing so much in this text? Well, if I ran it through a naive natural language parser, just to make a straw man of this here, really it would think that the text is about something like electrical engineering unless it was aware syntactically that the string ampersand amp semicolon actually was just the word and. So you really don't get safe subsets. What you really get is syntax. Everything has syntax all the time, and everything that reads something has to understand what that syntax is in order to be able to process it accurately, or you will end up with results that are at best wrong. And as we know, results that are at best wrong, well, the whole point of being red team is you're in the job of manufacturing bad luck. So why are we doing this? Why do we want to take random strings that we're inputting from the user and run them through an HTML encoder and then put them in a database? When I put it that way, is that a flow of processes that somebody would design and call a well-architected system with good design rationale? I probably wouldn't. But you do this a lot to try and make it safe. So let's put this into the context that I've been kind of alluding to. One of my favorite contexts for input handling is I've got some random review website. Because it has one of the things that are fairly difficult to do with input sanitization. It requires that the data has some degree of formatting attached to it. And this some degree of formatting has been the consistent bugbear of web forum software, review sites, anything really that stores user-generated content is, well, we would really like people to use bold and italic and stuff. Many just elide this completely. I know that there's lots of reviews that you just can't do formatting because it's dangerous and difficult. Well, it does. It is difficult. It requires a little bit of design. So let's take a look at this website. The input that I've chosen 4 cases where this input must be treated differently. The first one is this user input. The user has some declarative specification. Limited formatting is allowed. We know what limited formatting is allowed, I hope. All tags must be closed. If you don't close your HTML tags, you get an error back. You have to correct it because of the input filter. Okay, we're good. So the point of doing that, typically, the reason that we do this limited definition of input and validate it is so that when it comes time to display this stuff, we can just yeet it right out into the template HTML and all. Templating by string concatenation, unparsing by string concatenation. Primitive usually works. It's kind of okay. And we need that formatting for user engagement, so we better allow it. Well, if your controls are getting in the way of the business objectives, I submit that they're probably bad controls. So we're going to allow formatting. But then we have these other 2 use cases beyond user display that we may not have anticipated at the beginning of the existence of our software suite that takes the stuff in and displays it. Well, before we just stored and retrieved, but maybe later on we'll want to mine the data. Well, now again, we have to worry about that stupid keyword thing, and now our data mining has to understand HTML. Why? And then, of course, the last thing, legal holds. What if some business wanted to dispute the review that was left of them, and we need to find every mention of them in our software to figure out what our position is? those three strings, business A, business XML entity non-breaking space A, and business expanded French quotation close mark A. Are these the same business? Are they a different business? Who knows? Which ones of these should be output? Will we get them all? Will we be able to anticipate every possible interposing string that goes between business and the letter A? I don't really want to do that. I don't think you really want to do that either. It's a guarantee that you're going to miss something. So this is why it's important that we make deliberate choices. I also want to kind of call this out because there have been a few cases about this recently in the Pacific Northwest. This Squamish language orthography contains the 7. It's a glottal stop, kind of like an apostrophe in some other script. Some folks in BC, a Squamish family, tried to name their kid this. I'm not going to butcher the pronunciation. I don't speak the language. I shouldn't even try. But the point of it is they couldn't because it has a 7 in it. Don't make up rules that aren't real. So one of those rules is HTML. It's perilous to make up the rule that all input and output should be HTML. It requires you to import this huge amount of understanding. The other thing is if you make what we might think of as a common sense rule, names include only A to Z, A to Z. They maybe start with a capital letter. Maybe they're all case insensitive. That's just not true. And it's been causing a lot of problems with people having to rename everything from their company to their children in order to fit into a security person or an application developer's definition of what constitutes a valid string in a language. So it's more complicated than you think. Don't do this. And in particular, we already know all of this to be true in the context of passwords. You already know that if somebody is saying your password can't include any of this following list of special characters, what the heck are you doing with the password, right? So you already believe that input sanitization doesn't work. So this is the solution, output encoding. You already do output encoding, and I'm going to breeze through this so that I can concentrate on the examples. You already do output encoding because you already use parameterized queries. You already use output escaping libraries. You already use streaming encoders. So parameterized queries, of course, the way it works under the hood, typically there's a wire format by which you're making your SQL queries. It might actually just be SQL. The library normalizes out whatever strings you take in. You pass it something in your programming language. It transcodes that into the wire format and goes. It's completely transparent to you. It's encapsulated. That's awesome. We're separating concerns when we do this. Output escaping libraries, the same way. You might notice that there's an output escaping library for HTML, there's an output escaping library for XML, there's an output escaping library for JSON, and you need to use the right one for the format that you're in. That's literally just output encoding. And of course, streaming encoders and things. Let's stream this markdown out into PDF. We're output encoding. And the awesome thing about this is you can very easily show if you're writing out to a format that what you're writing out is that format. You don't need to be worrying about, hey, did anybody ever manage to get anything into my backend at some point that can't be validly concatenated into this particular point in this particular template for all templates that exist in the past and future? That's not encapsulation. It's not even testable, really. So yeah, output encoders are nice. They're fuzzable. You can test them and ensure that everything that they generate is actually valid. They're provable. You can generally verify them if your output format is simple enough. You can certainly show that something outputs valid XML for the subset of XML that people actually use. For instance, it's very easy to show that these can only output valid SQL or can only output valid JSON. And you get to choose the complexity based on the output format that you're willing to encode into, just how difficult or complicated your output encoder will be. The output encoder is also encapsulated. The thing that the output encoder encapsulates is a definition of what breaks the break between data and signaling in the output format. What constitutes valid or invalid can all be contained within that boundary. Leaves us the question of what do I actually store in the database when I do this? What do I take in? How do I transform that? You've got to do it twice. There we go. okay, the example. You've got to do it twice. You've got, the user wants to write this SQL statement. The user writes a saved filter, like select star from customers where country is Canada or Finland. And we want to store a canonicalized representation of that if at all possible. You can also store the string kind of for display, but what you really want to do is you want to canonicalize it. This helps you in a few ways. It helps you compare it later. It helps you answer questions about it. It helps you make it kind of independent. If you do this, if you take the SQL and you parse it into this intermediate language canonicalized representation that I just kind of made up in 5 minutes, it translates like this. It's the same as the SQL. Select, and then we'll OR two things together. Field 1, ISO identifier Canada, or field 1, ISO identifier Finland. Field 1 in this case corresponds to country. And this kind of stores the string. It's kind of it's a hack job. You would have to do a little bit more detail than this if you were doing it for real. But the point of generating this kind of intermediate representation, this is the way that basically all compilers work. You compile your C into an intermediate representation, IL of some sort, and then you write it out into the binary format for your target architecture. We can actually do the same compiler technique with basically any type of data, whether it be formatting or whether it be SQL. Once you've done this, you have a few advantages. One of them is that you can write it out into SQL that you know is safe, because you can say, well, my transformations from this only generate SQL of the form that I was looking for. The point of this was, maybe I went too fast through it. We wanted to allow the user to determine which table they were selecting from and what predicate they had, but not more than that. We didn't want them to join other tables together. We maybe want to restrict the names of the tables that they could access. This is beyond what parameterized queries could do, which can only do the parameter part of this, not say what are the table names or how many predicates do we have. You have the advantage that you can actually output and code this into wherever you want it to be. You can write it in ISO SQL. You can write it out as a MongoDB query if you want to. It's the same, as long as you're willing to write that definition. The point of this, our interchange is a well-defined programming language. We can reason about it. You can show what it's going to do, and you know what it's going to do. If somebody injects some garbage into your database, you'll more likely get an exception in your output encoder than you'll get a SQL injection exploit, so that's not injectable. Here's the other example, back to formatting. Let's take our string. We have a heading, we have a line break. It has a little bit of syntax in it. If we transform it into this representation, and there is a paucity of these representations, we need to make more of them. I wish I could say, just use this library. It doesn't exist yet because this isn't as common a technique as it should be. You want to basically write it as, this is kind of a JSON-like representation. You can pick something like that that you can very easily show is correct and well-formed, and you can throw exceptions if it's not. Make your own keywords. Try and make them so that the representation is as unambiguous as possible. Then we can do our permissions check on it. Is the user who wrote this allowed to use the H1 operator? Much, much, much better than having a regex that tries to filter HTML input, which we know is a technique that doesn't work because HTML is not regular. When it's time to write it out, again, we can choose our output formats. Our interchange format can be stored in the database safely. Of course it can. We can serialize it out to strings that can be stored in the database using a different output encoding library. And this is what protects us at the boundaries. So in a very short summary, the thing that we ought to be doing, rather than trying to sanitize input and prevent people from sending us exploit code, is try to make sure that when we write it out, the thing that is doing the writing out is not naive like a string concatenator. It actually understands what it's writing it out into. You can verify what it's going to generate and what it isn't, and you have verifiable code. Congratulations. Just have a little time for questions, I think. Yeah.
It's really either or, though. I mean, there is still some benefit to some forms of input sanitation in the right context. So if you have a context that lends itself to input sanitization, you're not saying that's no longer valid. You should also be doing this on the back end.
The question being, isn't there still some role for input sanitization in short? I would say that we only have a finite amount of effort to spend, for one. I would probably rather see that effort go into writing verifiable output encoders than writing signatures for exploit code. I think that I've had this conversation a few times when I've talked about this control, and I think that the biggest argument that I can make in favor of input sanitization really is that An XSS payload is probably spam. It's probably not topical. If you're in one of those contexts where it doesn't make sense, certainly filter it out because it's spam. But I think that fundamentally speaking, there's very little input in a well-architected application that really needs to be subject to it by being inherently bad. And it's kind of a special case factory. What if I want to allow my forum users to talk about cross-site scripting? I have a special case if I'm doing input sanitization, and that's kind of what I'm trying to avoid. Okay. If nothing else, I think I'm being told to get off stage and shut up. So thank you again, and see you soon. I am being bombarded. Is it because I was wrong or because people have spare schmooballs? It's a schmooble.
Tell me your name.
It says double trust.
Excellent. We don't ask for ideas, so we'll just trust them. And then you can talk to the slides, or it'll be like a
Honestly, I think we should shuffle all the slide decks up and have other people present them. I think it'd be a good time.
Is this your first ShmooCon?
No, this is my third ShmooCon. First time I got accepted for the CHP. I always play a game of chicken.
Well, congratulations. Thanks so much.
Oh, yeah.
So, you know that this is our Fast and Furious.
Yep.
15-minute block.
I asked to not be streamed. Heidi asked, so you have to remind them or...
They know. I will go.
Okay, thank you. Okay. Well, I mean, they're basically starting with your ending. This one, right?
Rapid fire. Which slides are yours?
Oh, jeez. How do you guys do it?
Whatever you submitted. Probably either your first name, your last name, or the title of the talk, or your handle.
Oh my god, my handle is Noble Trout, but I don't see it.
You have yours down.
Can we use Command
I
F?
think, was that, what's the title of your talk?
Oh, there we go. There it is, right there.
Oh, yeah.
It's a.
Yeah, that's it.
It's a funny icon.
It's an HTML document?
No, it's a PDF. I want a PDF. Is that a bad idea?
It should be fine.
I can plug my laptop in.
No,
Oh, there it is. Working over there now?
The V2 slide.
Yes, correct. And and I'll just do a sound. Yeah, I think we're good. Should I start right now and then I get a little extra time? Oh yeah, that's the I was going to run a timer here myself so that I know how badly I'm screwing the next guy. 12? Shit. We're going to get through the game show. I know, they got to move from the other one. I was glad I wasn't in the huge room, but then I'm also like, this room looks full. I think there's actually, might be more people here than there were an hour ago, I think, so. But it's nice. It's, a great venue, you know, the White House Correspondents' Dinner. Very prestigious. Honored to be here. So I should just go. You give me a what? Oh, okay, yeah, that's fine.
Howdy, folks. Thanks for being here for our Fast and Furious talk block, where the talking happens on the stage, not so much in the room, he says passive-aggressively. Howdy, folks. If we could quiet down in preparation for our next speaker, please. Thank you, Ted. That's a reminder. We are taping and streaming most of the talks. Not everything goes online, but for things that do get recorded, you can get copies to take home with you from Ted. See him at the table out front tomorrow for that. So without any further ado, I'd like to introduce our next speaker, Andrew Logan. Please give him a warm ShmooCon welcome.
Shall we play a game? Love to.
How about the OSINT game that reveals hidden helicopters in DC?
Or would you prefer a good game or chess?
Okay. Let me start with a quick show of hands. Who here lives in the DC area? Okay, keep them up. Who has heard or seen a helicopter in the last week? Keep them up. Keep them up if you didn't know who was operating that helicopter. Okay, thank you. You are the demographic for this talk. You can put your hands down, I appreciate it. But for people who are out of town, I do want to illustrate the all of the helicopters over DC have drawn criticism for endangering protesters, spawned a Government Accountability Office report, and have even brought about proposed regulation in the House. So today I want to tell you about our project to attempt to demystify these helicopters for DC residents and the game we designed to aggregate this data for public use. So when you first hear or see a mystery aircraft, where do you usually go? FlightAware and Flight Radar 24, Radar Box, apps like this use ADS-B transponder data. This is a flight safety feature that is mandatory in Class B airspace, most of major cities. And it stands for Automatic Dependent Surveillance Broadcast. Automatic in that it does not require a pilot's intervention, dependent on a number of sensors, surveillance in that it reports those sensors over broadcast on 978 or 1090 megahertz, unencrypted, intended for reception by other aircraft and control towers, but also frequently received by enthusiasts like us who upload that data to FlightAware and Flight Radar 24 so that you can get that global map. So this is where our app started as a humble ADS-B bot. However, we quickly found out that ADS-B data is incredibly limited in the DC area because of the Code of Federal Regulations that exempts government aircraft from using this flight safety transponder in sensitive cases, but used as broadly as funeral flyovers at Arlington Cemetery. So what is a person to do? Well, we crowdsourced it. And this is how you play the game. Everything you need is currently in your pocket. Start by taking a photo or video of the helicopter. This will come in handy later. And then send it to @HelicoptersOfDC on Twitter. You can tag a specific type using the helicopter icon like an emoji, helicopter emoji like a hashtag here. And crucially, give us your specific location by hitting that blue location pin in Twitter. This is the Lincoln Memorial, for example. That will get you on our feed with a map and the probable operators of that helicopter. And it will also get you on our leaderboard, which you can see some people have gotten maybe hard to catch at this point. So if you are not using Twitter, congratulations. You can submit on map.copterspotter.com, where you can see our interactive data set, and you can browse it and filter it by specific operators that you wouldn't find on Flight Radar and FlightAware, and specific types. If you go down to the lower right, hit the plus, you get our form where you can submit anonymously, government contractors. And you can more specifically pin your location or that of the helicopter and backdate your post to something you saw yesterday or a week ago. We do have a formal methodology for figuring out what type of helicopter it is. If you have a photo, you can count the blades on the main rotor. Those are the columns here. And then in the rows, you have the landing gear configuration. 1 and 2 front wheels refers to tricycles. Many helicopters are. However, once you have thousands of user-submitted photos of helicopters, you don't really need the methodology. You create a computer vision program that automatically identifies helicopters. So now any photo sent to us, it gets a type, the probable operator of that type in the DC area, and the confidence we have in that assessment. Couple metrics about this computer vision model. It is comprised of 17,000 annotated images, many more that are unannotated. If you want to help with that, come tell me. Also, we looked at 1,000 uses of this computer vision across since April when we started it, and it was effective at finding the correct type 77% of the time. Now, we really benefit from having a data set that is custom tailored to our use case. So that means that the most probable helicopter here, the Air Force 1st Helicopter Squadron's UH-1N Huey, responsible for VIP evacuations, and the most spotted helicopter 2 years in a row, comes back with a very high probability, and you can rely on that most of the time. More rare helicopters we struggle with at the moment, such as the President's new VH-92A helicopter, which is undergoing testing. They have worked out the holes that it was burning in the White House lawn. Of course, we have a more conventional OSINT source for presidential arrivals and departures, the President's daily schedule, which we scrape and create cron jobs that tweet later in the day, so you can find out when he's going to Joint Base Andrews. So the glaring issue here is that images are not very useful at night. So we needed another data source. And it turns out even government helicopters have to talk to DCA Tower. So we deployed a Raspberry Pi on a balcony near DCA to automatically receive these radio calls and upload each call as a tweet to UFOs of DC. They're unidentified, but you get to identify them. And you find ones like this.
Okay, 3023 requesting 2 to 1, 1 to south, and 1 for back
And you send that to our main account, and it builds an annotated map for you so you don't have to read the FAA helicopter chart, which nobody here wants to do, but that is OSINT. And it gives you very specific information about that operator. So this is a really powerful way to figure out the clandestine operation over your house at night. And you get points for this, and you can do this anywhere in the world. So I'd like to talk about the elephant in the room. Despite a avowed commitment to the free speech in November, in December, Elon Musk started banning flight tracking apps, ADSB Exchange, our account for 16 hours, journalists that he doesn't like. So we don't have a lot of faith in this platform in the long term, so we are kind of creating redundancies over on Telegram. This is because it allows geolocation mainly, and so we have a bot there that you can talk to, Copter Spotter Bot, and it'll walk you through submitting to our data set or just getting your image identified. So let's talk about our data set. In 2021, we had 10,000 spots, and we're down slightly from that, probably because inauguration accounted for some extraordinary cases. And here on this chart, you will see in that bracket the data that is available to you on conventional ADSB flight trackers. Everything below that is novel data. The FAA is not tracking military aircraft. So this may be the most comprehensive data outside of the military on this. And where the helicopters are and where they aren't is very important. I ask you to look at the green, blue, and orange dots on this map of the week leading up to January 6th, where we see normal preparedness and training until the 6th, where DC police is the only helicopter circling the Capitol. Other revelations include this.
And Black Check 2, we just had a near miss. I request you mark the tape, please.
This is a Coast Guard helicopter reporting a near collision with another military helicopter, neither using ADSB. And without a program like ours, this might just get lost. So here is our information, and I hope you'll consider sending us your helicopters. I think I have 1 minute left, so I'd like to play a mini game with you guys. It's called What's That Agency? This is the game where I show you the picture of the helicopter, and you tell me what agency or military branch operates that helicopter. Raise your hand, we do have some fabulous prizes. All right, does anyone know what this helicopter is? That is not DC Police. DOE, Department of Energy, yes, they are doing radiation monitoring. This man right here, thank you. Okay, here's our second one. Who said Navy in this area? Okay, you're a winner, you come talk to me after. This is a Seahawk, it's a Black Hawk variant with active radar underneath, and the wheel is tucked up because the back folds in so they can store it on an aircraft carrier. Very cool. Easy one here. Army, okay, well, you guys all get stickers. Come find me. Yeah, this is the 12th Aviation Battalion. They transport 3- and 4-star generals. So this is my PBS moment. This project is brought to you by viewers like you. Thank you.
All of the ones, some people don't have to talk about it, but all of the ones that are there is a request on yes.
Thanks, everybody, for coming out for our selection of 15-minute fast and furious talks. Turns out we've been doing pretty good on time, so that means I have a time for a giveaway. So let's see here. To the person who can tell me what year the first ShmooCon was. What's that? I have a book. You're welcome. Without any further ado, I would like to introduce Michael Rudden. Please give him a warm ShmooCon welcome.
Awesome. Thank you so much. So in contrast with helicopters, which was an awesome talk, I'm going to talk about parking my car and trying to not get a ticket. So almost as exciting. So here's a disclaimer. I've talked to people from both Passport Parking, Common Parking app, and the city of Raleigh where I live. What I'm about to discuss is not an application flaw in Passport's app, nor any municipal system. To be very clear on that. I'm just trying to not get a ticket when I park. So relevant background about myself, I'm a security engineer. So I got a little bit of security engineer mindset. I live in Raleigh, North Carolina. It's a wonderful growing city, population a little under 500,000. And in 2019, they moved their downtown parking to Passport Parking from old traditional meter system. And North Carolina allows you to get special characters in your license plates. It's pretty unique. I think there's a couple others that do something similar, but mine has a $sign in it. So I did do a little bit of digging and find out how that worked. Sometimes when you try to do like license plate reader, park your car at the airport, it reads it funny, so you have to kind of know how these things work to have a special character. And in 2018, I went to Scotland and I got a parking ticket when I parked my car at a grocery store to buy a sandwich because I thought it was a I, but it was a 1, and their app didn't normalize that. So, going to the present day, why do these things matter? So I went to City Hall for a meeting. In this scenario, I parked in a 1-hour metered zone. Directly across from City Hall for a meeting with a big agenda. I was there for an item pertaining to my neighborhood, and it was 1 hour parking, but, you know, sometimes where you fall on the agenda, you might have to be there a while. And I did indeed have to be there a while. So since I had used the Passport Parking app, what I've done in the past is it'll alert you, you top it up. Well, it turns out this rule that they had put in for this parking zone meant that at the end of 1 hour, you could not renew. So here's what happened. I bought an hour of parking, it expired. I went to renew it and it was like, sorry, it's restricted. So I'm sitting in this meeting, pretty sure something coming up soon is something that, you know, got a lot of people from my neighborhood at, kind of like Parks and Rec when you have a lot of people at the meeting and they all have opinions. And I'm one of those people sometimes. So I'm sitting in this meeting, I'm trying not to leave because it's like any time, you know, I might have to like raise my hand. So what would I have done in the past? I would have probably just put quarters in the meter, right? Or sometimes you move your car over a few spaces, maybe a block. Or you rub chalk lines off if you're in one of those places. So really what I'm trying to do, like I said, not hack a system, just not leave the meeting and not get a ticket. So going back in time, when you request a personalized license plate in North Carolina, there's this form on the DMV website that explains all the special characters you could choose from. And the verbiage that they use are characters that count as 1 space, characters that count as a half space, characters that count as 2 spaces. There's a whole bunch of them, right? There's actually way more special characters I think we have than pretty much any other state that I've seen. California has like a heart and a handprint and stuff. Anyway, and side note, zeros and O's are the same thing. So that problem I had in Scotland wouldn't happen where I am because everything's a 0. So as I'm sitting in this meeting, I'm like, there's something about these special characters. I remember there's something about them. And I look it up. And sure enough, I find this guide to special characters. So here's a table of all the special characters and how many spaces they are. But then at the bottom is the key here. It says, note, special characters will not be considered when determining if a plate text is available. For example, plate A&3 at C is the same as A3C. So we now know a character is the same as a space is the same as nothing. So that means that every license plate number that has a special character can be expressed 3 different ways and still be that valid plate. So what I did was I took the $ out of my license plate and I ran it through and it worked. So this is kind of what got me started here. So I thought this is kind of cool. Start, texting some people I know. I'm like, this is kind of a neat security, like kind of overlay with the way, the real world works. So I'm IRL, applying security thinking. I was able to kind of just work around. It's 1 license plate. I expressed it 2 different ways and got 2 different results. So what I did was I reached out to someone at Passport Parking, someone from the city of Raleigh, and had some really interesting conversations. And that's going to inform some of the stuff coming up. So thinking going beyond. Here's an example of a default license plate in North Carolina. They have a format that's like ABC -1, 2, 3, 4. This means everyone who doesn't have a personalized plate has 3 valid plate numbers. And not every parking system, as I mentioned, can handle all of them. So sometimes you won't be able to type in a hyphen. Sometimes you won't be able to type in a space. Sometimes you won't be able to type in an O or a 0. Sometimes you can't do $. So basically, if you have special characters in your license plate, you have to be familiar with how to type them in, or how the license plate readers that are automated will recognize them, how these things are going to go. It's a very strange rabbit hole to go down. So other considerations, as I mentioned. O's and zeros are the same. This is actually really convenient, but what I heard from people in Raleigh was that when they got kiosks to go on some of the streets that would kind of link up with the different parking systems, they could not all normalize O's and zeros. So people could put in their license plate 2 different ways on the street kiosks, which is kind of weird. They're not the same character in a lot of states, and that leads to very weird license plates where people try to get away from cops by putting like O0, O0. We have a lot of specialty plates in North Carolina, over 100. Many states have these. We've got fun things like, support the Blue Ridge Parkway, support our local sports team, Let's Go Canes, Purple Hearts, and different plates for veterans. And my personal favorite is watermelon. So let's prepare for unforeseen consequences. So a lot of this comes out of my conversation with the city parking department. So what happens when parking enforcement comes around? Well, they've got these things called LPRs. It's like license plate recognition or license plate reader, depending on the context. So if they detect your plate and it's in the table of the paid plates from that block, you're good. If not, they do a manual check, and it kind of gets up to them whether or not they think that you're good, right? And then otherwise, you'll just get a ticket. One interesting thing, our parking department does not, the police don't write tickets. It all goes into the parking department budget. And they're very proud of this. They said that they write less than 5% of the people parking in our city each year a citation. And the budget doesn't go to police. So there's not like a lot of incentive for over-ticketing. But there's, it's still annoying, right? And people are trying their best. They're just trying to go visit downtown, support local business. So there's a workaround to all this, which is the appeals process. So sometimes when people get out of their car, they see a number, say Passport Parking app, they type it in, it's actually the block over. Our city's pretty understanding about that. That's kind of cool. The other thing is, going back to these special plates, right? These letters are actually part of the plate number, and it doesn't tell you that anywhere. So they don't want to write Purple Heart veterans tickets all the time for missing the PH on their plates. And they said they accept 60% of the appeals. So, how does this overlap with security concepts? So, truthfully, this discussion I had with city parking was super interesting. It's basically like they have kind of a sysadmin economic thinking approach to like the entire transportation network of a city. And you know, parking, there's all these different nodes. There's like parking decks, street parking, parking lots, like anything. And they want people to get where they're trying to go. A few years ago, a lot of people switched how they do entitlements, and they used the word entitlements, which I thought was great, right? Basically, you know, they're thinking a lot like IT people, but about like real world, real things. So it used to be, you'd feed a meter, that space is good. Anyone can park in that space, it is funded. Now it's, you use your license plate. So now when you go to the beach at Carolina Beach, people used to hand the ticket off to the next person pulling into the lot, and it would be free all day, right? But now everyone pays 40 bucks. They do automated detection and handling false negatives. So like I mentioned before, they use these LPR technology, and LPR, they said, is about 90% accurate. We have a lot of special characters, so it's all the edge cases, and I fall into them with my own car. Then there's rules-based enforcement that's hard to apply consistently across different vendors and tools. So anyone that's worked in firewalls, web filtering, anything like that is very familiar with these things. But yeah, so they're trying to figure out, okay, we have kiosk A, app B, parking deck C, like there's a lot of technology that spans about 60 years of different types. They're trying to create one cohesive system, so it's kind of interesting. Goes back to what I was saying about kind of system architecture here. Input validation and standardization. So I mentioned before, there's a kiosk that couldn't tell that O's and zeros were the same. So that leads us some interesting outcomes. You know, I said every plate has three different plates that it's legally valid as. There's actually, if it has O's and zeros in it, it could be more. So that's kind of fun. End user awareness and training. You want people to know, how does the app work? Which zone are they supposed to be in? It's supposed to be readily apparent. If you're like me, what they told me was because I was going to be there for longer than an hour, I really should have parked in a parking deck. So now I know that for next time, it's cheaper to park in the parking decks long term, at least in our city. And regulatory requirements, because everything has to follow city and state law. So that's it. Special thanks to the City of Raleigh and Passport Parking. Thanks, everybody.
have slides. Would you like to use these slides?
Yeah.
Do you know? What's that? Oh, you have. Okay, sorry. I didn't see the.
We can stay on here if you want.
Well, I don't have any way to get them off of here to on there.
USB, juice?
Yeah, my USBs are locked down.
No, but USB juice? We got power.
HDMI cable.
I got an adapter here somewhere. Sorry. Don't run away with it, it's my only copy. Better if I actually prepped this before I got here. How much time? I got time, right? I got 5 minutes. Okay.
Close email.
Yeah, right?
Front messaging.
Hopefully nothing pops up while I'm doing the presentation. My kids are in the front row. That's always nice. Oh, they changed it. I don't know where everything is now. Where's my presenter? Oh, I gotta put this in first, right?
Down in the right corner.
Good. All right. Good.
Thanks for. I think you've done this time.
Once or twice. But how do you call me on Wednesday? Like, hey, I need to speak first. I'm like, I gotta leave in a day.
Well, thank you very much for being here. You're taking the streaming.
Okay.
You're okay to be.
Is that mine or is that random?
I can get. I will bring you.
If you got a bottle of water or something, or even a cup or something, that would be good.
I'll bring you a new cup of water. Once you're
Thanks. These mine? I might use one of these. How much slack do I have? You guys okay if I use this mic? Yeah, a little bit. Is that okay? Oh, because then you got to move the camera? Oh, I see. They don't want to make you do too much work. I'll stay in the general vicinity.
So yeah, there your time computers and ask you to keep it in 20 minutes.
Yeah.
And like I said,
As long as they give me a 2-minute warning or whatever, I should be good.
Yep. I'll give you a 10-minute reminder.
Okay.
The stop sign.
Hopefully, if anything, I'll be short. I won't be over. Okay. I'm almost never late.
I don't have any giveaways right now.
I don't either.
The introduction will just be space brokers.
That's very old sweater.
Are you here for your votes? I'm here for the
I got one copy, I'm not giving it away. I only have one copy. That's, yeah. It's here for display purposes only. You can pre-order it. You get it in February. Huh? No, not yet. I don't know. Depends on how much I can get, how much somebody's going to charge me to record a book. Not cheap. That's the problem with audiobooks, is they're wicked hard to produce, and sales just aren't there to recoup that.
So where did you want to walk?
I just, like right here.
Oh, yeah.
I don't want to have to hide down to it.
Yeah, no.
I'm not going to walk across the
Wait a
stage.
minute, you know who that is?
Yeah.
So I should come over and say hi.
Oh, okay. I knew who that was back there.
So you're ready to go? Ready. So my question.
Thanks, everybody, for coming to our 4 o'clock talk this afternoon. You may notice that you have a slightly different presenter than you were expecting, and that's because Space Rogue has stepped in because, unfortunately, our originally scheduled speaker couldn't be available here at this time. But that doesn't mean that it isn't great to have Space Rogue here. So please give him a very warm ShmooCon welcome.
Thank you. So we're going to talk about entry-level InfoSec resumes today. As was just said, my name is Space Rogue. I've been around for a little while. I've done a few things. I've been interviewed by a few media outlets here and there, or given some talks. I was a member of Loft Heavy Industries. And if you want to know about that story, I have a book coming out in February that tells the complete story about Loft and Loftcrack and the Hacker News Network and the WACMAC archives and testifying in front of Congress and at stake and the early days of the information security industry. It's available for pre-order wherever you buy your books. I also want to mention that I am not an HR professional. I do not work in human resources. While this talk will cover specific hiring practices, it is from the viewpoint of the hiring manager. Also note that there's a lot of automation in recruiting these days, but eventually the hiring decision still comes down to a personal interaction with someone who actually looks at your resume. Now, I work at IBM, so I'm wearing their t-shirt. I got their stickers on my laptop. I have their slides. And one of the first things I did when I arrived there, with the help of a gentleman named Johnny Shaib, well, actually it was his idea, was create an internship program for IBM's X-Force. Now IBM has its own company-wide internship program, and it's called Extreme Blue, and it goes across the entire organization. Thank you. There were some slots in that program devoted to IBM security, but there were none specific for X-Force. So Johnny and I, we asked for some budget, and we asked for some headcount to create our own program, and I was like, sure, Johnny, we'll go ask for money. That's not, yeah, so we got budget and we got headcount. But neither one of us had ever run an internship program before, and suddenly we had to find 10 people willing to come or spend their summer in Austin, Texas. And I think at that point it was already February, and if you know anything about the internship cycle, February is very late in the cycle. We figured there was no way we were going to get enough applicants, but we opened the rec and sent out some tweets, and boom, we had 800 resumes for like 10 slots. And that first year, it was just Johnny and I slogging through all 800 resumes, trying to whittle things down to just 10 candidates. And now, here we are like 5 years later, and the program has expanded to like 4 other countries. It's become one of X-Force's primary recruiting tools. We have an entire team devoted to sorting through the candidates and the resumes that we get. We've learned to open the resume application process a little earlier. We try to start in September now, and there's a full team involved. We still get over 1,000 applicants every year to those 10 slots. So over the last 5 years, we've seen a lot of resumes. Some of them good, most of them pretty bad. But before we get into that, let's talk about the purpose of what a resume is. It is highly unlikely you will be offered a position based on your resume alone, but that's not what the resume is for. The resume's sole purpose is to get you an interview, right? The interview is where you're going to wow your future employer, and they're going to be like, oh, I got to hire this guy, or person, or woman. The resume's job is to provide enough information that the person reading it says to themselves, I need to talk to this person. It's kind of like a movie trailer, right? Or a football highlight reel. Only put the really good stuff on the resume. Leave the people reading it wanting more information, wanting so much more that they have to call you to give you an interview. All right, that's why I'm here today. I want to help you create a better resume. A lot of times I'm scanning over a resume, in that 20 or 30 seconds that I have to review each one, and I'm asking myself, where's the rest of this? Where is it? There's got to be more here. Like, I get the feeling for a candidate based on what they've put down on the paper, and I'm like, I think there's got to be more to this person. But all I have to go on is what's on the paper. I can't go with a feeling. I have 1,000 resumes to grade, and if it's not actually written down, I can't count it. And I feel like we're just missing out on so many good candidates simply because they have a bad resume. And I don't want any more bad resumes. I want perfect resumes. So that's why I'm here today. All right, so before I get into specific do's and don'ts, let me remind you that these don't come from an HR professional, and they may tell you something completely, totally different. These are my own personal recommendations that I and my team at X-Force have come up with after reading hundreds and thousands of entry-level resumes from students who are still in college, trying to break into the information security industry. And the beauty of the resume, and one of its downfalls a little bit, is that there's no standard format, right? Each resume is as individual as the person who wrote it. And that's great. Also not so great, because then you're, as the reviewer, I'm like trying to sort for stuff, trying to search for stuff while I'm reading it. The air is dry. So I just got done watching my other son play Hack Fortress, and his team just won the semifinals, so good job, Xavier. Considering he's never played the game before, and his team was just made up this morning, or last night. No, anyway. All right, so let's cover the don'ts first. One of the biggest things I see people do all the time is they list what classes they have taken, all right? I know this one is probably a big shocker, like right out of the gate here, but especially if you've taken a resume writing class at school or in college, and they always tell you to list your classes because you're in college, you don't have a lot of experience, you don't have a lot of items maybe to list on your resume, and you're searching for things, what can I put down? And you're like, oh, list all the classes you took. Don't do that. Why? Because every one of you who are in college, you all take the same classes, right? I know what they teach in those classes, and depending on what school you're at, I probably know your professor. Don't waste space on your resume by listing out all the individual classes that you took, and I'll get into this a little bit more, but instead, I want you to list the projects that you did in those classes. Right? Tell me the things that you did, not the things that you were taught. All right, if you're an undergrad in college, a sophomore, a junior, a senior, which is mostly the applicants that I get for the internship, there's no need to go to 3 pages on your resume. And in my opinion, even 2 is pushing it. You can fit everything you need to fit in 1 page. Like, remember, we're looking at a highlight reel here, right? You just want the movie trailer. Leave them wanting more. If you think you really have enough relevant information to fill 2 pages, well, that's great. Cut half of it out. Remember, we only want stuff that will get you the interview. We don't need an entire work history or anything that is not relevant to the job that you are applying for. Ask yourself, will listing this item on my resume get me an interview? If the answer is anything but an emphatic yes, think twice about putting it down. Listing references on the resume. I don't know why people are still doing this. It was a norm years ago. It was a common thing. People put the references right on the resume, phone numbers, names, the whole thing. Don't do this. Listing references will not get you an interview. Therefore, it's a waste of space. You don't need it. Some people instead, they put down references available on request. Again, you know what? I already know that. I know if I need a reference, I'm going to ask you for it and you're going to have them. You don't need to list it on the resume. It's not going to get you an interview, and therefore it's a waste of space. All right, don't listen to your professors. Another one that's probably a little shocking, at least when they say anything about resumes. Okay, listen to them for anything else. They know what they're talking about, but not necessarily about resumes. Ask your professor when the last time they wrote a resume or had to apply for a job, or ask them when was the last time that they actually hired anybody and looked at a resume. Most of the time, it was years and years ago. It's amazingly obvious when I'm reading a resume, when someone listed a specific item that didn't fit anywhere else on the resume. And most schools offer a resume writing class or a workshop, and by all means attend those workshops and classes and those sessions, but don't take everything they say in those sessions as the final word. One thing resume classes teach is keywords, right? And how it is important to include all these hot topic buzzwords on your resume to beat the automated HR scanners. Well, I'll tell you a little secret. If you're following the job requisition that you're applying for, the one that was posted, and you're qualified for that position, then you're going to have the keywords necessary to get past the filters already, just by listing out what you have that qualifies you for that job. If you try to game the system and stuff your resume full of keywords, by the time it gets to a real person, your resume is either going to be unreadable or irrelevant, and either way, you won't get the interview. All right, and this follows right along with don't listen to your professors. A lot of schools have an example template or a school suggested format, or maybe the school auto-generates your resume based on the classes you've taken. I don't know. But when you're reviewing thousands of resumes, all from pretty much the same schools, they all start to look exactly the same. Or at least the ones that look exactly the same stick out like a sore thumb. And I never even knew this was a thing until I started getting resumes with the same exact format from different people. And you're like, oh, wait, this was the same one I looked at 5 resumes. Oh, there's the same school, right? And you're thinking, well, they must have been teaching this format, and everybody copied this format down. And there are several, this isn't just one school that this happens from. This happens from a couple. So there are thousands of different formats out there. There is no one set format. Feel free to Google one and find one and make it your own. And that's kind of the beauty of it, right? Be an individual. Let yourself come through in your resume. If you're applying for an information security position, don't try to be a graphic designer with your resume. No flashy colors, no really shaped text boxes, no animated GIFs. Yes, I've had animated GIFs. No multicolor fonts. None of that is going to get you an interview, especially if you have a hard time finding information on the page. If I'm like looking around trying to figure out, all right, where's his work experience, where's her projects, where's this, where's that, I'm just going to get frustrated. It's like, okay, this person's not qualified, I'm moving to the next one. Don't make me look for stuff. Like, even if it's a delay of a few seconds, that's going to hurt your chances. And it might, like I said, it might just be enough to make me give up and move on to the next candidate. Nicely formatted text that's easy to read. Give me enough white space in between sections. That's all I need. This includes photos. I don't know why there seems to be a resurgence of people adding their photo, maybe because of all the social media, everybody has an icon or whatever. People are putting photos back on their resume, headshots. Don't do that. I mean, it could trigger an unknown bias in the reviewer. Maybe your photo reminds them of a person they used to be in a relationship with that ended badly or something. Who knows? There's nothing to gain from including a photo. It's not going to get you the resume, get you the interview. You're not applying for an acting position or to be a model. A photo's not going to get you that interview, so save the space. I do have one other don't that I didn't list here on a slide because it could go either way, and that is listing your fraternity or your sorority. I've seen some people do this. I know in some cases that might be an automatic interview. If the person who's reviewing your resume attended the same fraternity, maybe they're gonna, oh, I'll give this person an interview. But at the same time, there's also a lot of people that don't like fraternities and sororities. So if you list it and you get a reviewer who is of that persuasion, that may be an automatic no. So my suggestion is don't include it unless you know who's going to be the actual reviewer and you know it's going to help you. Another don't that I didn't have room for is the cover letter. I would prepare a generic one and have it ready if you need it, but 90% of the time, don't bother uploading it and including it in the online system, because unless the automated system has a specific section for a cover letter, don't try to squeeze it in with the resume section. I've occasionally gotten just a cover letter with no resume because the system barfed on it and chunked the second page off or something. I don't know what happened, and I have to go back to HR and say, hey, I got a cover letter and a resume, and it puts a delay in the system while they go look for your resume because the person uploaded a cover letter instead. But it's one of those things that, and some people don't even read the cover letter, like me. I used to, but after 1,000 resumes, it's like they're all the same. I want a position in information security to better follow my dream and be a great cyber person, right? They're all the same thing. So I don't even read the cover letter anymore. But some people really appreciate those and thinks it goes the extra mile and shows some consideration to the position. So if there is a section on the form that you're applying to that says cover letter, put your cover letter in. If that section does not exist, then don't try to squeeze it in anywhere else. If you're actually mailing in your resume, I could go either way. I don't know if anybody actually still does that, physical mail papers. Anybody applied to a position with physical paper? No? Okay. Yeah. All right. All right. So if you remember back like 5 minutes ago, the first thing on my list of don'ts was don't list your classes, right? So if you've listed your degree program, you've listed your degree program that you're in, so I already know what classes are involved, so there's no need to list out the individual classes. Instead, list the projects that you completed in those classes. I'm much more interested in how you applied the knowledge you were given than a dry list of topics that were covered in the class. Did you write a quirky little side-scrolling game in your Scratch programming class? Well, list your quirky little side-scrolling game. And maybe I'm a gamer who's interested in quirky little side-scrolling games. That might be enough to get you an interview, right? Or maybe you wrote a Flash-based command and control framework with a web front end with HTML and CSS and JavaScript. Maybe that sounds a whole lot better than Web Programming 203, right? I'm going to be a lot more impressed by the project than the class. If you are still in school and trying to break into information security or the cyber industry, it's unlikely that you have much, if any, relevant work experience. It doesn't matter. List what jobs you have had. If those jobs don't relate to Infosec, then 5 minutes, all right. If those jobs don't relate to Infosec, then they don't need large descriptions or any description. If it's important for someone who's reviewing your resume to know that you have actually had a job in the past. Doesn't matter if that job was mowing lawns or flipping burgers or just babysitting the neighbor's kid, list it down. You absolutely need some sort of work history. The more relevant the previous job is to the job you're applying for, the longer a description it should have. Often I see resumes with absolutely no jobs listed at all, and I don't know why they didn't list something, because I've never interviewed one of those candidates, so I was never able to ask them, well, how come you didn't list some kind of job, right? There has to be something in your past that you've done to earn some money. Like I said, even if it's babysitting or paper route or whatever, put something down. I've already talked about not going over 2 pages, and really you should try to keep it to 1 page. I also mentioned not trying to be a graphic designer with your resume. Try to understand in any large company or even smaller companies that might be outsourcing their recruiter, your resume is going to go through at least a half a dozen systems before HR sends it to me, the hiring manager, for review. You want your resume to look as good as it gets when you submitted it as to when I get it. Now, PDFs, of course, make this pretty easy these days, but not every recruiting system accepts PDFs. So you need to have a well-formatted Word version and even a straight text version that you can just copy and paste from. The text version, of course, makes it real easy to preserve some of the formatting when you need to copy and paste your resume into a random web form. A lot of times these random web forms will lose all your formatting, and you just have a jumble of text. If you notice that, try to go back in and manually edit it. Yes, it's a pain. But when it gets to the other end, if all I have is a wall of text to look at, that's not good. I don't want to have to sit there and try to decipher stuff. If you have competed in CCDC, CPTC, Cyber Patriot, Try Hack Me, Hack the Box, local Capture the Flag competitions, Hack Fortress, right? Put that on the resume. I can't tell you how many people we get into an interview only to find out that they've competed in some competition, and then I find out after I get in the interview, and I ask them, well, why didn't you put that on the resume? And they tell me like, oh, my professor told me not to. Like, that's exactly the type of person I want, is the person who's going to compete in those competitions, and here the professors tell them, don't put it on your resume. I don't understand that. I mean, I can sort of understand if you're competing in an offensive competition and you're applying for a defensive position, yeah, maybe, but the mindset is there. And I'm running out of time, so I'm going to try to go a little quicker. Bug bounties, same thing. If you participate, list it. List the programs you're involved in and any rankings that you have. Don't list every single bug. I had one person send me 12 pages of every bug he's ever found. I don't want that. It's not going to get you the interview. But put enough information on there. I participate in this bug bounty. I got 5 bugs. Right? That's enough for me to maybe give you an interview and ask you about that during the interview. Right? You don't need big long descriptions if you do any sort of volunteer work. Even if it's not InfoSec related, especially if it's not InfoSec related, church group, pet shelter, soup kitchen, whatever. Doesn't need a long explanation. A simple line item is good enough, but I want to see a well-rounded individual. And this sort of extracurricular type of activity goes a long way in showing me that. Any InfoSec stuff that you do, helping out at a B-Sides conference, simply attending ShmooCon, put that on there. All right, you're entry level, you can get away with that. Put that on there. I want to see that. It speaks to the type of person you are, and just simply attending a major hacking / InfoSec conference says something about you as a person. Skip that. If you serve any time in the military, especially at larger organizations, we often give extra credit for veterans. So if you're military, active duty, reserves, National Guard, ROTC, junior ROTC, whatever, listed on the resume. If I ran out of room for this, but if you have a GitHub, put that on the resume. If you're not proud of the code in your GitHub, well, you can have more than one account. But also realize that just because you list the GitHub or other link, website, doesn't mean that I, as the reviewer, am going to have time to look at it. A lot of times I just know, oh, this person has a GitHub. Well, that's good, plus 1 point. I know some reviewers who make it a point to go through and look through the code and spend the time in doing that. I don't have time to do that. But if you have a GitHub, if you have code that's public, if you commit to open source projects, list those things. Hopefully, this is an actual example resume. How am I doing on time? I still got a minute or two? I'm done? I got 1 minute? All right. So hopefully this is properly obfuscated, but this was one of the better resumes that I got. They list their degree program. They list their GPA. I would not recommend doing that unless it's a solid 4.0, because if they're ranking by GPA, and some companies do that, there's always going to be somebody who's higher. So unless you've got a 4.0 GPA, just don't even bother putting it on there. If they want to know, they'll give you the interview and they'll ask. All right? A lot of clubs at this school that this person went to, big school of tech, a lot of various InfoSec related clubs, and they listed them all. That is great. One thing at the bottom, they listed, there's the word salad. It's down at the bottom. Okay, if you're going to do it, put it at the bottom. But again, I don't need all those keywords and buzzwords for me. That's for the HR automated system. All right, some of the stuff I mentioned the last 17 minutes or so would probably apply to anyone applying to any job, but some of it also only applies to entry-level positions. If you have a few years of experience and are looking for a more senior role, and you know the applicant pool won't be in the thousands, for example, I would include a cover letter for, So you really have to tailor your resume for your career. An entry-level resume is going to look different from mid-level or senior resume. Some things hold true across all, like focusing on things you have actually done, projects that you've completed, not just things you were taught or a list of software applications you heard of once. Now, we still, at IBM X-Force, we still have some openings, and I'm being told to stop. I'll be around for questions somewhere.
I never wrong. I don't know what the hell happened. I think I started off too slow.
That was my last slide anyway, so I got it good.
Yeah, I looked at your bag before and I thought it was mine.
Hey. Oh, where's your brother? Are you going to apply? Are you doing Infosec? You're here, so I assume so. Okay, what year are you? Okay. You're going to apply to Expo 60?
Yep.
Does he tell you I give him a lot of shit all the time? Give a bit more for me. All right, I will.
I think we're just going to use... We're not going to use this. And then I just want to make sure the demo videos actually go to the right screen. Okay.
Good?
Yeah. So, got a choice for you. You can either you want this bigger, or do you want big text, or both? Because
Maybe it's slightly, yeah, that's good.
Really? Really? You said you were 100%
all the time.
a couple minutes ago.
Yep, that's great.
All plugged in there.
It's been operating pretty smoothly. Awesome.
The kind of thing that I don't want to fix it.
Yeah.
How's your ShmooCon been?
A little rush. I only got here a couple hours ago, so just chaos at home. So. But,
Thanks for making the time.
Yeah. It's a privilege. Ready?
So, you're listening to, the taping are the hooks right there. They're easy to see. They'll give you your time cue.
That includes the time for the Q&A.
We just timed yourself at about 16.
Oh, yeah, we should have.
You'll be fine. Feel free to finish your that's what you'd like. But yeah, remember to repeat the question because not only is the people in the room, but you're online. How does the online streaming work? Is that anybody who buys it can
Anybody that tunes into Twitch can watch it.
I did not know.
Completely free.
Okay.
And then all of the videos are uploaded to the archive.
Great. Yeah. Good. I was hoping they would. I was hoping they would upload them afterwards so I can refer to them. Okay, great.
You can also buy them from Ted, the guy who does most of the he has a table set up. They'll have it tomorrow.
Is that mic active? I
They're
saw there's
actually-
another.
they're all-
Oh. Okay. Yeah.
I'm going to open, then we're going to switch. I'm just going to speak for about 6-7 minutes, and then I'm going to finish it.
I'll find out a couple of giveaways and announcements.
Cool. No, I think we're good.
Thanks for coming. Howdy, folks. Thanks for sticking around. It is just about time for our 4:30 talk today. Oh, please, no shots of the crowd. Yeah.
Okay.
As a reminder, please no photos in the conference rooms. And if you are taking a photo, make sure you have permission of everybody in the shot. So let's see here. Giveaway, how many cards are in here?
54. At least one.
I'm going with at least one. Who was that? Let's see. Oh, that was at least 2 rows too far. Sorry about that. Yeah, well, that is, it is a reason that I'm not going to throw this. Sir, would you like a ShmooCon book? Thank you. So, a couple of announcements. This evening, there is the games that will be next door, along with the ShmooFac, which is a pub-style trivia game that is a lot of fun. All of that starts at 9 o'clock this evening. You will need your mask and your badge, but show up and have a good time. But before we can have that good time this evening, we have to have a good time this afternoon. So please give a very warm ShmooCon welcome to Gabriel Landau and Mark Maker.
Good afternoon, and welcome to our talk titled Hide Your Valuables, Mitigating Physical Credential Dumping Attacks. I'm Gabe Landau. I'm a principal at Elastic. I love Windows internals. I work on endpoint security features, particularly Windows side. My best known research is probably kernel mode threats and practical defenses at Black Hat, process ghosting, and my AV sandboxing work. I used to wear red. These days I wear blue.
Hey everyone, I'm Mark Mager. I'm the Endpoint Protections Team Lead at Elastic. My background is primarily in defensive tool development on Windows, as well as reverse engineering and malware analysis. So just to jump right in, I'm going to discuss very briefly the differences between physical and virtual memory. So physical memory is pretty straightforward. It's literally the RAM chips that are in your computer, and you have as much physical memory as you have RAM. For this talk, one of the primary things to remember is that on Windows, access to the physical memory is controlled and maintained by the memory manager component within the kernel. As for virtual memory is basically the OS and the CPU cooperating to create the illusion that each process on the host has its own private contiguous address space. This is essentially what the concept of virtual memory. Memory is divided into pages, which are typically 4 kilobytes or 2 megabytes in size. And there's a hierarchy of structures called page tables that are used to map virtual to physical pages and describe other attributes such as page permissions, including read, write, and execute. Each process has its own page tables and its own private address space. And a virtual address space is typically sparse, with most addresses invalid. If you've ever popped any process into a debugger, that's probably something you've seen if you've ever looked through that process's memory map. Individual pages can be backed by RAM, files on the file system, or the page file. And the memory manager does provide seamless access to non-resident memory via paging. And the operating system provides APIs such as read process memory for accessing the address space of other processes. So here's a snapshot of what a process's virtual address space looks like as seen by the sysinternals tool VMMap, if you're familiar. Each color that's on the screenshot corresponds to a particular memory region type, including unused, private, file-backed, as well as shared memory. And so at any point in time, any used memory may or may not actually be resident in physical memory. And if that's the case, when the CPU accesses it, the CPU will issue a page fault, and then control will be handed off to the memory manager, which will then follow up and attempt to retrieve the data from its corresponding backing store, which is going to be a file or a page file typically. So now that that's out of the way, what are attackers typically after within memory? The short answer to that usually is credentials. And on Windows, the biggest credential dumping target for attackers is the Local Security Authority Subsystem process, better known as LSAS. And what you'll find within LSAS is that it houses several critical services and is primarily responsible for managing security policy. The tidbits that attackers are really after, though, is they're trying to dump Kerberos tickets, NTLM hashes, and clear text passwords, among other sensitive data contained within LSAS memory. So with that sensitive data, adversaries will use the credentials collected from LSAS primarily for privilege escalation, persistence, and lateral movement. So how are actual credential dumping attacks carried out? So for the virtual memory side of things, a few of the common tools that you might have heard about that attackers typically use are proc dump and Mimikatz. The common thread with these two tools is that they both rely on the NT-read virtual memory syscall, where the OS will switch to the address space of LSAS and copy out the memory that's requested. Since this copy operation is against virtual memory, any page faults are going to be handled transparently by the kernel and should be invisible to the user. So for mitigations to Mimikatz and proc dump and those tools of that nature, Microsoft introduced a way to run LSAS as a protected process light, or PPL. Processes that are secured via PPL are much harder to target with the NT-read virtual memory syscall. PPL also does provide mitigations for several other types of attacks you might be familiar with, such as the process forking or code injection, but those are out of scope for today's talk. Another type of attack that I'd like to discuss today very briefly is one that we've been seeing quite a bit pick up in prominence over the last year or so, and that's bring your own vulnerable driver, or BYOVD. The primary advantage that these attacks provide is that they provide a reliable way to circumvent the protections that are afforded by PPL. So typically what a BYOVD attack looks like is that adversaries are going to load a signed driver with a known vulnerability, and then they will later exploit that driver in order to get it to perform actions with kernel level privileges. Essentially this is done to disable or otherwise bypass PPL. In response to this attack vector, Microsoft at least blocks known vulnerable drivers by default in Windows 11, and it's optional in Windows 10. So I've covered virtual memory attacks. Now, to get into physical memory attacks, that's another avenue that attackers can explore for acquiring memory in order for extracting credentials. There's several methods to accomplish this. So when Windows blue screens or bug checks, it will save a memory dump to disk for error reporting and debugging purposes. This memory dump mechanism can be configured to save all physical memory to disk. Another option that you can pursue is the physical memory device, which is a section object created by the kernel that enables access to physical memory. Direct access to this device is facilitated by forensic tools via signed drivers, including WinPMem and Dumpit. And one primary advantage to this approach is that Microsoft's block list does not typically include such drivers like WinPMem due to their benign use. And virtual memories are also susceptible to additional threats. When a VM is suspended or snapshotted, a copy of its physical memory is going to be saved to a file on the host disk. And then this raw memory dump can actually be converted to standard DMP format using tools such as VMSS2 Core. So now that you have a physical memory dump file, what exactly can you do with it? Well, Mimikatz includes a tool called Mimilib that runs as a WinDebug extension, and that's used to load symbols and access the user mode memory resident within LSAS in order to dump credentials. Another option is a tool called Physmem2Profit, which basically employs a client server model and is network-based. So the server runs on the target and loads the WinPMem driver and exposes it via network socket. The client on the attacker's machine will connect to this socket and it will pull physical pages on demand by the user over the network. And the recall forensic framework is used to assist with walking the page tables and any kernel-related structures. reconstructing LSAS's address space from physical memory. FizzMem for Profit creates user mode mini dumps, which can then be processed with more standard tools like Mimikatz or PyPyCats. And then one other option is recall and volatility do include Mimikatz plugins that function very similarly to the Mimilib Windebug extension on acquired physical memory dumps.
So that all sounds pretty bad. What do we do about it? Well, let's talk about mitigations. So going back to our VM map example, processes data that's physically resident is called the working set. Pages in the working set can be categorized as either private to this process or shareable with other processes. Today we're going to focus on the private working set because it includes the process's heap, which often contains these sensitive secrets that we're talking about for LSAS. If you look at the image there, you'll see the private WS column is highlighted in red, and we can see about 3 megabytes of resident memory. Windows provides the empty working set API to empty a process's working set. Now watch what happens when we run it. We can see the 3 megabytes drops to about 100 kilobytes. When you empty a process's working set, its pages aren't removed from memory immediately. Instead, the memory manager keeps a few caches of recently used pages in case they're needed again in the near future. One such cache is the standby list, which is a list of unmodified pages that can be discarded at any time if the OS needs some free pages. Another is the modified list, which is a list of modified pages that can't be reused until they've been flushed to their backing store, such as the file or the page file. We can use an API to have the memory manager flush both of these caches, removing them from physical memory. We created a tool called Silhouette. It's a kernel driver that detects changes to LSAS's working set, flushing it in response. Because it's a kernel driver, it's compatible with run as PPL. It doesn't have to deal with any of those PPL protections. It includes a file system mini filter to detect paging I/O, so it can quickly reflush the pages after they've been brought resident. So I'm going to give a quick demo of Silhouette against FizzMem to Profit. So what we have here is we're running FizzMem to Profit, the server, and it's running on the victim's machine. I'm sorry, I should speak into the microphone. On the top is the FizzMem to Profit server. It's running on the victim's machine. And on the bottom, we have the client, which is actually running on an Ubuntu VM. And just to keep it all on the same screen, I'm running the commands over SSH. So we're SSHing to the attacker's machine to run the commands. So it's loading up the WinPMem driver, and it's generating a dump of LSAS right here. And it just generated. Now it's still on the attacker's machine, so we're going to SCP it to the local machine, and then we're going to run Mimikatz against it. And then when we look at the output, we can see that Mimikatz successfully collected hashes. Next, we're going to run dump it, which is going to generate a physical memory dump of this machine. It takes a couple seconds. And then we're going to pass that physical memory dump to Windebug, and that's going to load Mimilib, the Mimikatz extension, and extract credentials from that. So we're going to scroll up the output, and you can see we've extracted some secrets. So we're going to clean up now, and then I want you to look in the top right corner, and you can see there's about 9.3 megabytes of private working set for the LSAS process. So what we're going to do is we're going to start the Silhouette driver, and that private working set goes to 4 kilobytes, and perhaps more importantly, stays at 4 kilobytes. So now we're going to redo the 2 attacks we just did. First is FizzMem to Profit. And it encountered an error. But let's try to collect its dump. So maybe it corrected a partial. Nope, there's no dump, so there's nothing. We can't run Mimikatz against anything. So now we're going to run dump it. And then we're going to take the output of dump it, and we're again going to pass it to Windebug and into Mimilib. And if we look, Mimilib had an error and failed to extract anything useful. Thank you. Okay, so it's great that we're able to break these attacks, but there's tools out there, such as the Recall Forensic Framework, that given a timely copy of the page file, can work around non-resident pages by paging in the missing data during analysis. So let's take things a step further and consider attackers capable of this. While Windows is running, it keeps the page file locked to prevent access. Attackers can work around this with tools such as invoke ninja copy that access the raw disk directly, bypassing the file system. Invoke ninja copy, for example, will parse the NTFS data structures on disk, the master file table, and locate the file's data and then copy it. Silhouette can detect and block such direct disk access, protecting both the page file and the hibernation file. Unrelated to Silhouette, Windows has a built-in feature called NTFS page file encryption that you can use to also mitigate this attack. It ensures that the page file contents are always encrypted before they touch disk. Another bypass involves creating a volume shadow copy snapshot, and because the OS does not lock pagefile.sys within these shadow copies, that protection I talked about before does not apply to the page file version in these shadow copies. Silhouette can also detect and block these types of accesses because the NTFS file ID in these shadow copies for pagefile.sys is exactly the same as the file ID for the original pagefile.sys. All right, so let me give a demo of this one, and hopefully I can see the screen well enough. Okay, so we're going to start, we're performing a traditional copy of the page file, and we can see that the regular copy fails. Now we're invoking invoke ninja copy, which accesses the raw disk, parsing the MFT, and copies the page file successfully. Now we're going to use hobo copy, which creates a volume shadow copy and acquires the page file off that shadow copy. And that one's successful. Now we're going to start the Silhouette driver, and you can see its output in the bottom in debug view. And we're going to redo the two attacks. So first one is invoke ninja copy, and we can see that fails. And if you look at the bottom in debug view, you can see that Silhouette detected it and blocked it. And then hobo copy also had a failure, and you can see that Silhouette right there detected and blocked it. So let's talk about defeating this mitigation. Full memory dumps are slow, but fast attacks should be spammable. Silhouette ensures that pages are only briefly resident, and this window is much shorter than the time it takes to perform a full memory dump. An attacker repeatedly issuing RPC requests to LSAS while using a driver like WinPMem to perform surgical reads targeted just at LSAS's address space may eventually win. To mitigate such attacks, defenders should block drivers that allow physical memory access, such as WinPMem and Dump It. A variant of this is the Windows Error Reporting Secure Process Dumper, or WRFault Secure. An attacker with admin rights can run WRFault Secure as a protected process and use it to dump LSAS. WRFault dumps are encrypted these days, so you can actually extract useful information from them, but the act of touching those pages will bring them resident. And so you could then pair that with like a WinPMem in order to try to pull the pages that way. To defend against this type of attack, a driver could use an object manager callback or OB register callbacks to block the process VM read permission even to protected processes away from LSAS. Because that would prevent such types of dumps. Another attack is to disable, move, or dramatically shrink the page file, so the pages have nowhere to go. So it requires a registry modification and then a reboot. Potential mitigations include monitoring for such changes with your EDR, locking the registry value from the kernel, or if the change is detected when the system starts up, revert to a known good configuration and restart the machine. As for future work, well, these principles can be applied offensively too, many from user mode. You can remove your implant from physical memory with 2 API calls. Think about that for a second. It's easy to extend Silhouette's volume shadow copy to other files too, such as the SAM registry hive or ntds.dit. So you can break hobo copy and invoke ninja copy, not just for the page file, but for many other use cases. So as for my wish list, as is, Silhouette must flush the standby and modified lists system-wide. Ideally, we could do it only for the pages belonging to a specific process, but that's not an option today. While the EFI lock on run as PPL is great, its scope is really limited, and I wish we could lock more configuration options with EFI. So in summary, as you just saw, keeping LSAS's private memory out of physical memory stopped both physmem to profit with Mimikatz and dump it with Mimilib. Silhouette blocked Ninja Copy's attempt to collect the page file via raw disk access and Hobo Copy's attempt via volume shadow copy. We did some basic benchmarking, emphasis on basic, and there wasn't any noticeable performance hit, but overhead will vary based on your workload and your hardware. We'll be releasing Silhouette source code later today on GitHub. In conclusion, understand that physical memory is not omniscience. Paging is often taken for granted and happens more often than you think, especially on systems under heavy memory pressure. As for recommendations, we suggest running LSASS as a protected process, aka run as PPL, and enabling that UEFI lock mechanism. Enable Credential Guard if your environment and hardware support it. Deploy Windows Defender application control vulnerable driver block lists, and include forensic memory dump drivers in your driver block list. Any questions? Yes? It's going to be, I put the URL, it's on the bottom line right here. I put it on the company, Elastic's GitHub. Yes?
So, I saw one of the mitigations is Credential Guard, talk about that, but I guess the question is even though Credential Guard is enabled, you have some instances where once administrative access or administrative rights have been gotten, and that it pretty much eliminates the protection of Credential Guard?
So in Credential Guard, as we're talking about here, that actually runs it would store your credentials in a different virtual machine. So Credential Guard puts the entire Windows into a virtual machine, and then there is a separate secure kernel that runs, I believe it's a VTL1, that runs in parallel to you. And the physical memory device does not have access to that other virtual machine. It's as though you're running two VMs in VMware. One can't access the memory of another one. And the same issue, not just for the physical memory device, but even if you were to try to use raw page table access with like something like a PTE remapping. So you cannot get to the memory of that unless you go higher with something maybe like an SMM attack or that kind of thing. So that's it, we're out of time. So thank you. Thank you, Reed.
Yeah, thought about where my Indian tee. Plastic shirts is still free. Reed? You see, man?
Good to you too. You been
Doing all right.
hanging in there?
Yeah. How are things? It's a great place.
They're going well. Better than they were like 6 months ago.
Oh, really?
That's good. That's improvement. Yeah, they're going well.
Yeah. Yeah, it seems like you guys are big nuts. Growing.
Yeah.
Doing all that stuff.
We hired pretty fast.
Yeah.
Like we went like 60 fast.
Oh, okay. So a little more manageable. Yeah.
But yeah.
You would use, so run as PPL
Yeah,
will stop attackers from loading a custom
Yeah,
security
Greg, I
package.
think, just got here. He's right here somewhere. We had a happy hour.
So that's why I was talking about the UEFI lock mechanism. So Microsoft thought about that. And there's something called a UEFI lock where they can specify a firmware configuration variable in the EFI such that even if it's disabled via the registry or via group policy, if this firmware configuration variable is in the registry, it will enable run as PPL.
On Elasticsearch, like I probably should run that. It's a good company, but we still got the backpacks. Oh yeah, it's some great shit. Yeah.
Right after we renovated.
Right, yeah. It's all renovated it, but yeah, water damage. Huge leaks. Yeah, where do you guys have office space?
That is one way.
Is it good?
Hey, so I'm
Joe. I do.
Okay, so then I'll let you handle the details.
Yeah, that's fine.
I'll start about 1 minute before your time, so that I'm using it hopefully close to your time. And just briefly say a couple of odd things, and then it'll be
Yeah. Okay. Thank you. Oh, this one's me. This one's me. Yeah.
the guys back there doing the 3 and 3, whatever, they'll have this to signal to you, like, time and shit like that. So just kind of watch it.
What's this one?
This is if you went really over. It's like, shut the fuck up, get off. Because we're all a bunch of dorks and we think this is funny.
No, it's great.
So hopefully you
Yeah.
think it's funny too.
Oh, yeah. Sure. Okay. Hopefully we'll have to use it. Really, anything works. It doesn't matter.
That was my guess, but I'd like to try.
Right. Appreciate it.
All right, thank you for coming to the 5 p.m. session of ShmooCon here this Saturday. Thanks to all of you for continuing to doing a good job of wearing your masks. And a reminder that there's various bits of swag and t-shirts still available at registration. This presentation is titled I Spy a Spy, Degrading Advanced Phishing Campaigns, and I'll give you Joe Oni to give his presentation to you.
Thank you. I'm trying to figure out where the mic goes here. All right. First off, in the utmost of respect to the Shmoo group and they're correct. It's ShmooCon 2022, of course. So, and Landon, I'll change that after, so Virginia doesn't get mad at me. Okay. So I'm Joe Oni. I've been in cybersecurity about 13 years. Got started through the Department of Defense. And my background is really incident response, and I come from the intelligence side of things from the DoD, and so I generally take that approach to incident response and security operations. Currently, I'm an intelligence consultant with NISOS, and I'm still in the Kentucky National Guard, hopefully not for too much longer. I'm at 19 years, so it's time to get out. Previously, I was a security operations manager for Hogan Lovells, a large law firm, and information security manager at UPS. Also did a lot of the building of the security operations program at UPS as well. So the next 45 minutes, what are we going to talk about? Well, we're going to start with some baselining, where I just we all get on the same page, so we're using the same lexicon. We talk about certain phishing types through the rest of the presentation. And I'll talk about the end goals of the presentation as well, right? And then I'll get into the actual meat, the 4 phases, being requirements, setup, tactical reaction, strategic and political enablement of the output from the actions, and then a lower effort alternative, and also a lower maturity alternative would be in there as well. We'll talk about some impact, and hopefully at the end we have time for Q&A. So baselining. So the good old phishing attacks, right? They just username and password, right? This is your classic phishing attack, like this one, pay guy, almost got me, because I'm a pay guy user. Any other pay guy users? No? Okay, well, you guys should try it, it's great. I'll send you an email. But this is the classic stuff, right? I mean, it's just username and password. And then these days we have these new school phishing attacks, right? You have these Evil Jinx 2, Exprobotos, Crypto. They're not made for evil, of course, right? They're just for security testing, like all of our tools. So don't use them for evil. But these in particular, they can get through multi-factor authentication schemes, right? So they're setting up the proxy server in the middle of the communications, phishing the user, and then they intercept all the traffic between them and the legitimate, probably not malicious, depending on how you define malicious, right? Is O365 malicious? Yeah, sometimes, But so in between there, they're capturing all the traffic. They're getting, the tokens, and that's the end goal for them is the tokens, so that they can log in. We do have an advantage in that, you can do a lot of blocking phishing things, right? There's all the old school stuff, right? You can do your DKIM and DMARC and SPF and all that to help. You can do URL rewriting. There's a multitude of things you can do to defend against phishing attacks. You can train your users, right? That's another thing you can do. I mean, that's the minimum really at this point. And my opinion on it is that you can't depend on training your users. So if you can, build an environment where your users can make mistakes, right? That's what the URL rewriting and things like that are for. Build a secure environment where your users can click on phishing links without ruining your day. But I like thinking about how I can reach out and touch bad guys. That might be the DoD in me, but I really like messing with the bad guys, right? I want to make their day hard when they're trying to make my day hard, right? And that's the point, right? So this talk is really, a talk about deception. There's been a couple deception talks today. There was one just before lunch. It was really good. And then Chris Sanders came out with the book last year, Intrusion Detection Honeypots. And a lot of deception is focused on the inside, right? It's about using the credentials internally, making some, fake servers and things like that. My approach is really an externally based, deception technique, right? That's what this is about. So it's about, and you guys can feel free to leave the room after this slide. That's what it's here for, right? Like, oh, okay, I'd rather see how much a con costs, right? Which is fine. But here's the deal. So we'll set up alerting for when certain credentials are used, right? So in your infrastructure, do some, let's make some fake accounts, do things like that. When a phishing page happens and we detect it, we get it from a user like whatever, we're going to log in using those honey credentials. Hopefully we can set up an environment where those, when the attacker uses those credentials, they'll log in, we can watch them, do all the things. That's where we're gathering data on everything. And we'll take action when we get bored, because they're going to be rummaging through like empty OneNote or, OneDrive or like whatever. And you're like, okay, what are you even looking for, guy? And then we'll just block their IP. And then afterward, we'll use those things for, the sexier blue team stuff, threat hunting, detection engineering. And then, if you need it, you can use it to enact some change in your IT team. And that's the hope, right? It's all about like that systemic changes in security and making yourself a less attractive target. So the 4 phases, right? So the first one's going to be requirements. So we're going to log authentication to externally facing applications. And be creative here, right? Like you have the portals that your clients use, you have your own externally facing things, O365, Okta, Gmail, like whatever you're using out there, right? But make sure you're logging those, because that's the thing that we're gonna key in on when we give attackers credentials, right? This is the hard mode. We'll get to the easy mode later. But we need some sort of logging in order to be successful here. And you can create honey accounts with the logging you have available, right? And so look at the logging you have, figure out which ones are going to kind of work. You can look at historic phishing campaigns in your organization or against your clients, using your brands, and figure out what logging, what authentication you have available, create some honey accounts, enable everything you feel comfortable enabling, right? This might take some finagling with the legal team, but enable what you can with the idea that you're going to give an attacker access to the things. And you're going to want to create accounts with MFA as well. Because we talk about those advanced phishing attacks, they're going to expect MFA. That's what they're there for. And so, anytime, and that's another point for alerting as well, if you had that MFA set up on that user. But they're going to expect that, and you want to just be able to get as much data as you can, so do as much homework as you can, set up as much logging based on the things you expect your attackers to do. The next point is going to be creating detection logic, right? So you have all the logging in place, but you're going to want to create some detection logic so that when the phishing happens, because it may not be immediate, I've seen both ways where the phishing is, automated. You see this a lot with like legacy protocols in O365 or Azure AD, right? That was a big thing where you log in and they would instantly hit your Azure AD legacy protocols to see if that user existed and if the password worked. And then also there's the manual side of it too, if it's more targeted, where based on the email and then maybe they'll log in tomorrow or something. You never know. But you want those detections in place, and you want a plan for when that happens, right? That's another part of this, is you want to be able to create a plan, even if you're the only person doing this, you want to have a plan of action to take when the detections happen, create your playbooks, test your detections, just classic detection engineering stuff on these honey tokens. And then, you're going to wait probably 10 seconds until a new phishing campaign starts, right? And then you have to wait until your user sends it to you or a client or whatever. You're like, all right, yes, we have phishing. Now it's time for the setup. So you identified the phishing campaign. You're logging in with the honey accounts. And there's some things you need to do here, right? There's proper OPSEC. Because at the end of this, the attacker is going to be on defense. And that's what we want. We want to, put them on defense. That's the point. Make them change the things that they're doing. Don't let it be easy. So when a phishing campaign is identified, use a good OPSEC. use a dedicated system, make it look like your normal system. You never know how successful phishing has been historically. They might have a good footprint of what a device looks like on your network. And use that to set up your system. And this is another part of that logging, right? When you go to this website, you never know what it's doing in the background with the redirects or anything like that. And so you want, Sysmon, Wireshark, just gather as much data as you can on everything that's happening when you go to the website and put in the honey credentials. And then this is the hardest part for me. I'm not good at this. Take explicit notes on which honey credentials are put in what site. It's the most boring stuff. But it is important for later, right? Because if you really want to get this to a mature level, you don't want to reuse honey credentials. And this is tough, but you have to do this every time. And it's important for like long-term strategic looking at how effective your program is. We'll talk about later. It's important for your OPSEC considerations, for your notes, for writing your plans, for doing your detection logic. And there's easier ways to do it. You can build it into your detection log. You can have the notes in there, of like, this was used on this site, so we know what phish, adversary it came from. And then, if you're really cool, you're going to do basic analysis of site and traffic patterns. Because this is going to be important when you're also trying to build a profile of your adversary, right? You want as much data as possible. Do they use the same framework for web hosting over and over again? They use the same like registrar. Are they, scraping your site entirely? Like, we used to have good luck because I had this one adversary that was just scraping our site, and they would leave the marketing data in there, and so it would ping back like internal to our marketing systems, and we're like, oh, we get you immediately, right? Like that's easy, so you don't have to send a phishing email, we find you. And we were to build like a really nice, so this is your TTP for that adversary, and it helps us later measure our actual effects from things like this. And so if we can enact change, we're creating some pain, putting them on defense. And then tactical reaction. So this is, when the honey accounts are used, and they will be, like let's be honest, they're not just collecting them to sell them, right? They're going to try them to make sure they work. And they're lazy, right? Adversaries are lazy. They're going to make OPSEC mistakes. They do it all the time. And they don't expect you to actually, they don't expect honey credentials on phishing sites, right? They're sending the email out. They're just used to, users clicking the buttons and putting in the data. They're going to make those OPSEC mistakes. Like, track them, take advantage of this. There's things like this, right? This is just an example from Azure AD, where same IP address, it's like same browser. They're not going to any effort here. It's like mass logging in. And these are the type of things, you'll want to build your detection logic off of. You want to, look for mass events like this. And then, you're going to go back and use this data for threat hunting later, right? Like that's the point, is that we're going to create some data points, hopefully have some effects, right, by giving them honey credentials and all that. But really, at a micro scale, you're creating good data for threat hunting. Like there's nothing better than threat hunting with intel that you created, right? Like, it came from an adversary. You don't have to guess that this is like somebody just logging in or something. It's not a user, right? You gave them this fake data. Definitely an adversary. You're like, okay, did this IP address log into anything else, like ever, right? How much logging do you have? Can you go back in time and say, oh, this guy's, logged into all these other accounts? Like those are compromised, right? Like that's what that means. So anything that account does, now you have intel, like real deal intel, on your adversary. And then you take those appropriate defensive measures, right? We talked about when you're bored. But don't do it too early. I used to fight CISOs all the time on this, right? You're on the IR team. I'm sure you guys all run into this. Because the IR team, the IR lead, they're like, can we just watch the adversary for a little while, right? Can we just like leave them alone? And they're just like, no, it's my job on the line, like block it. And so I get both sides of it. But if you can talk them into it, the longer you wait and watch, the more you log, the more you'll learn. That's the short of it. And that's the case in all IR, right? If you can talk your CISO legal teams into letting you get away with watching your adversaries, you're going to get a ton of better data, and your incident response is going to be better. And this is a good time to do it, right? This particular scenario, it's a controlled environment. Like, let's let, this bad guy take some actions. Let's let them do their thing, and we'll take some notes and, maybe write a blog post, and we'll all be famous. All right, so strategic enablement. So this is, one of the, I like this side of it. It's not as fun as watching the bad guys, but it is important from the effect side of it. And so we're going to use the data that we gathered, the code and traffic patterns, all the things, right? You have your user agents, IP addresses. If you go back to, was it Cuckoo's Egg, where he talks about the order of the, the commands that were put in. If you give them access to the PowerShell on Azure, like, what do? Do they type, their options in a weird order? Everything you have is a good indication there. Do the detection engineering work after that. You have all this data. How much can you build into an alert? Like, these are very high fidelity alerts. Like, the more specific you can get, the better off you're going to be in the long run. And then don't forget to look historically. We talked a little about that with the threat hunting. Use all these indicators, right? And some of them may not seem very good from like user agents or something, a very generic user agent, but is the combination of that user agent normal for that geolocation, right? Is it normal for, the traffic patterns that you're seeing? And so the combination of two of these weak indicators can make really good detection engineering, right? Don't look down on any of them. And then political enablement, right? This is like all blue team, comes down to politics. Like even the talk before this, right? It was like super technical, and we're like, oh yeah, we can prevent, this in-memory attack. And it's like, well, if I can convince my IT team to let me do it, right? Like, it's very cool. But do you have an IT team that hates changes, Like, no, IT teams love changes. And do you wish you could convince them to make things more secure? Like, yeah, sorry, this is a bit of a late night infomercial at this point, isn't it? But that's kind of what you have, right? You have this whole case now of look, this guy came in, right, and he's using legacy protocols to log into all of our users. Can we please turn off legacy protocols? Like, please? Can we just do that? That's not that hard. And then you can go back and see how many of the actions that the adversary took do your users take. If they're doing some weird stuff that none of your users do, turn it off, right? Like reduce that attack landscape, that threat landscape in your attack surface. And the better you're reporting, the better your note-taking, the better off you're going to be here in making this argument with your IT team that doesn't want to do changes anyway. And it's 50-50, to be honest, really. You could come to them with hey, look, they did all the stuff that none of our users do, and the IT team's going to be like, that seems hard. Legacy protocols, that seems important. Both of those words sound important. All right, and there's a lower effort alternative to these things. So if you don't have the logging, right, and you don't want to take the notes, which I get, and you still want to create some friction, I like this method too. This one I might like a little bit more. Yeah, I'm on the fence. I think I like this one a lot, but it's basically just spamming their whole data set with stuff. You're not even worried about logging it on your side. Just send them 1,000 usernames and passwords, script it out, right? Because even if they do the easy stuff, they're well, they'll just, filter it out by IP address. And it's well, you know what? Now they're on defense, right? And if they're hosting this text file somewhere on their web server, can you imagine if they looked and they had a terabyte text file of usernames and passwords to see what their web hosting bill was the next day? Yeah, that would be awesome. We have to see that in the real world, right? Of where somebody's complaining on the forums, oh man, I was doing this phishing campaign and then I got this $1,000 web hosting bill because it was so good. But none of the credentials work. It's weird. All right, and what other opportunities do we have to do this, right? And so this is really, what I'm trying to get to in the talk is that we can be very creative about the friction that we create for our adversaries using just like random stuff like this, right? You can go out and make things harder for your adversary by just changing the things that they expect a little bit, right? Like putting 1,000 usernames and passwords in. It's fine. They'll have to play some defense at that point. Like make them take actions outside of their comfort zone. Let's make things a little harder for them, because that's really what the best part of the job is. As much as I like making IT do stuff because of incident response, I like making things harder on bad guys better. So what else can we do here? Like, you know, there was some deception earlier. It talked about a lot of the internal things, right? It was using usernames internally, looking for logging there, using the fake servers, you know, doing all the fake credit cards. Like that was pretty cool. And we can take advantage of those things by just making those data sets of adversaries like way less valuable. Like, can you imagine if we all went to one of those, you know, dark web marketplaces and we were all selling like 600 million records from Twitter, right? Like all of us, like suddenly there's, you know, 2,100 users new on the forums and they're all selling 600 million Twitter records. It's weird. You think the one is going to stick out? You know, the one legit one? Like, who knows, right? And you can do that stuff, like it's free, right? You see somebody selling your data, go out and make 1,000, you know, accounts on the forum, and, you know, have them all sell your data. It's fine. At some point, you know, the market adjusts. Like they have to get on defense somehow. They're going to have to get creative about how they vet their buyers, which they don't want to do. They're going to have to give more information that they want to give when they want to find the legit buyers, right? And, you know, use your imagination here. You can do anything you want. All right, so what effects can we measure? So we have, it's hard to do, right? Defensive effects are hard to do and hard to measure in general, right? And this isn't going to be any different. So what we're hoping to see, right, and on the far end of things, we can build, you know, an attribution case to some extent, right? I'm not saying you're going to know where the person lives. If you want to get to that level, come talk to us afterward. But really, you know, can you build a level of attribution based on TTPs, right? Do they always, when you put in the passwords, are they on some weird time zone, right, that they're always using, right? Back to the APT1 report. Are they always on some, you know, Beijing time, right, that they're logging in? And do you track password resets? That's another kind of nice way to measure things. Are you suddenly having less password resets based on phishing, if you're automating some of that on the more mature ends? And then some other measures of success. Do your adversaries suddenly all use VPNs? Like that's a good thing, right? Like that's making it harder. It's harder to automate that if they're at that side of things, right? And then are they changing their infrastructure? Are they using, you know, are they paying more for bulletproof hosting, or are they having to move to like, you know, other web frameworks or anything like that to try and put in defensive things so you don't spam their, you know, web hosting bill to $1,000 or whatever, right? So any of these changes, that means friction for our adversaries. It means that you're having an effect, you're doing the thing you're supposed to be doing. And even if it's just minor stuff, I mean, you get a little satisfaction out of it, right? It's like yeah, it feels good to like have some effect on the bad guys, because now who's on defense, right? I hope I ruin their weekend with their web hosting bill. All right, so I cut it short, but thank you all. Do we have any questions? Any ideas for how we continue this? I think there's some level of continuation we can do just as a community to just spamming phishing sites, right? I was thinking about that last week as I was preparing for the talk of, you know, what if we got the whole community out here just installing something on their, you know, like Fish Labs or something, right? Get something like that set up where we all just log into these phishing sites with fake credentials. Like that would be fun stuff. But do we have any questions? Yes.
So you mentioned like identifying their location as like something extra after the talk. When you're utilizing
Oh, gotcha, yeah, so the question is, after the adversary is logging in, giving us those indicators, like those initial kind of easy indicators, is the ease of them logging in and doing things creating more indicators that we can take advantage of?
Is there like some psychological, like, you're just social engineering them now, they're like putty in your hands essentially, right? Maybe you can do something to them more so than just gathering data.
Oh, for sure, yeah. What more can we do in there? Well, I mean, you can get really creative when you create the environment that they're operating in. So, just using the Microsoft example, you can give them other accounts, right? You can see what they're trying to do across the board once they log in. Like you can give them the fake credit cards, right, the guys were talking about earlier, and see them where those get used, right? So you can get really creative about the data that you give them to try and create more of those data points, right? How about a document that pings back somewhere all the time, right? If they just try and mass download stuff from OneDrive. It's like, now you're getting some good data, even if they're using a VPN. And so it can get, you can be as creative as you want to, really. Yeah. Anything else? Oh, yes, sorry, go ahead. You trying to call the cops on me? Is that what you're asking? Sorry.
The hosting provider of wherever the phishing site is located, do you have any success with contacting a hosting provider to get them shut down, use that or anything like that?
Yeah, that's a good question. Yeah, because the question is, we had any success after a campaign, right, and messing with the adversaries, with the hosting providers or law enforcement? And absolutely, right, because you're building that attribution case. A lot of hosting providers, in order to take something down, even if using your logo and like clearly stealing it, they require a ton of data to actually prove, right, that they need to take it down. Like that's a legal process. It's a pain. It takes days. Sometimes it just doesn't happen. And so any case you can build and provide to them of like, look, it depends on who you're talking to, right? But you can give them some information of like, look, I put in these credentials. This person logged in. This is what they tried to do. Like, this is all from your site, right? This whole thing, like it needs to be taken down. Yeah, go ahead. All right, sorry, I heard the first part of it. So in the OPSEC, was it failures or? Yeah, I can't think, sorry, the question was like, have there been any OPSEC failures where we get data that we didn't give them? Is that the question? Like, yeah, to some extent, right? And so, like, for instance, in the threat hunting side of it, right, you give them those credentials and you use those indicators to find other things that they've used. You do get an idea of, if you get really lucky, you can kind of focus those indicators on finding adversaries that are targeting like specific sectors of the business even, right? You'll see like, oh, how come every user that they've tried to log in with that was successfully phished was HR or something? Like, well, that's kind of more interesting. And you can really build some really nice threat models out of data like that, right? Out of the, are they targeting certain subsets of users, subsets of the business? It can give you some indication if this is advanced or not, right? Or your red team, right? That's always a fun one when you're like, give the red team engagement like bad credentials. It's always a good day. Yeah. Any other questions? Yes, sorry. Yeah, that's right. That's a good comment. Some hosting providers don't give a shit. That's absolutely correct. Yeah, no matter what you give them, right? And those are the ones the bad guys like, right? The bulletproof hosting stuff. Yeah, and that's why you can't depend on those legal processes to take them down, right? You go out, create friction yourself when you can't depend on the hosting providers to help you out. Anything else? More questions? Good. All right, thank you very much.
Oh, nice. Okay, yeah.
But I'm doing research into social engineering.
Oh,
what
okay.
you're doing is so different than, like, so let's say everybody's mentioning no before,
Right,
but yours
right.
is more like, you're putting them on the front.
Oh, yeah, absolutely, yeah.
And I'm just thinking, like, so you're making me think, like, so many ideas, but, like, I can almost imagine, like, you know, there's humans, these people on the other end, right?
Yeah, yeah.
And they're the boogeyman, essentially, but you're making them more human by social engineering, by doing these little things that are playing with their emotions. And that's so great.
And what's great, like in the long term, you know, the effects you can have, like you're sowing doubt into all of their data sets, right? And so like there's some of those long term like psychological effects can be really good.
They think they're in, and then one day they forget to turn on their VPN, right?
Right, right. It happens all the time. Yeah, yeah. Absolutely. Oh yeah, yeah, yeah.
Thinking about what you said, yeah, this sounds like the actions you're suggesting are more like the surveillance cameras you might see in a shop. They might push bad guys to someplace else, but they don't really scale to get rid of the bad guys. Or a different analogy would be, I only have to run faster than my slowest friend, not faster than the bear.
Yeah, I mean, I think that perhaps, right, but I think there's a certain level of people taking these actions, right, across the industry, right, if we can all kind of start taking these.
Right, if you can get more